Azure Account, a centralized platform for managing and accessing Azure resources. Azure Account provides a single point of access for managing and using various Azure services, including virtual machines, storage, databases, and networking. It acts as a central hub for controlling and monitoring your Azure resources. Inputs. Azure Subscription. Azure Subscription is an account used to access and manage resources within Azure. It represents a billing unit for Azure services and acts as a container for various Azure resources. Azure Account Credentials. Azure Account Credentials are the login details for accessing your Azure account. These typically include your Microsoft account email address and password used for authentication within the Azure platform. Outputs. Azure Resources. Azure Resources are the various services, components, and entities that you can deploy and manage within Azure. This includes virtual machines, storage accounts, databases, networks, and other cloud-based infrastructure. Access to Azure services. Access to Azure services refers to the ability to utilize and interact with the various services offered by Azure, such as virtual machines, storage accounts, networking, databases, and more. Your Azure account grants you permissions and access rights to these services. Steps. 1. Create Azure account. Create an Azure account, which involves signing up for a Microsoft account and configuring your Azure subscription. 2. Configure Azure subscription. Configure an Azure subscription to define payment methods, set up quotas for resource usage, and manage user access. 3. Access Azure resources. Access Azure resources involves logging into your Azure account and interacting with the various resources, such as virtual machines, storage accounts, databases, and networking components. 4. Manage Azure services. Manage Azure services involves controlling, configuring, and administering the various services you use within Azure. This includes tasks like creating, deleting, scaling, and monitoring your cloud resources. Prerequisites. Microsoft account. A Microsoft account is a login credential used to access various Microsoft services, including Azure. It typically requires an email address and a password. Email address. Your email address is used to create and manage your Microsoft account, which is required to access Azure. Password. A password is a secret code used to protect your Microsoft account and ensure authorized access to Azure resources. Azure Subscription. Azure Subscription is a fundamental element of Azure that provides access to and management of Azure services. Subscription ID. Azure Subscription ID is a unique identifier assigned to each subscription, which is used to track and manage it. Subscription name. Azure Subscription name is a user-friendly label given to your Azure subscription for easy identification and reference. Fine-tune parameters. Resource groups. Resource groups in Azure are logical containers for grouping related Azure resources, such as virtual machines, storage accounts, and networks. This helps you organize and manage your resources more efficiently. Virtual machines. Virtual machines in Azure are cloud-based computers that can run operating systems and applications. They provide a flexible and scalable platform for hosting various workloads. Storage accounts. Storage accounts in Azure are used to store data, such as files, blobs, and tables. They provide durable and scalable storage for your Azure applications. Networking components. Networking components in Azure include virtual networks, subnets, network security groups, and load balancers. They enable communication between your Azure resources and the outside world. Challenges and fixes. Access issues. Access issues may arise when you encounter problems logging into your Azure account. or accessing your Azure resources. Verify credentials. Verify credentials involves ensuring that the email address and password used to log into Azure are correct and have not expired. Check subscription status. Check subscription status involves confirming that your Azure subscription is active and in good standing, ensuring that you have access to the services you need. Resource management difficulties. Resource management difficulties may occur when managing your Azure resources, such as creating, deleting, or configuring them. Use Azure Portal. Use Azure Portal involves navigating the Azure web-based interface to manage and configure your resources. Leverage Azure CLI or PowerShell. Leverage Azure CLI or PowerShell involves utilizing command line tools for managing Azure resources, providing automation and scripting capabilities. Billing concerns. Billing concerns may arise when you encounter issues related to the costs of using Azure services or need to optimize your spending. Monitor Azure costs. Monitor Azure costs involves tracking your Azure service usage and expenditures to identify areas for potential savings. Optimize resource utilization. Optimize resource utilization involves identifying and adjusting resource configurations to reduce costs while maintaining performance and availability. Security vulnerabilities. Security vulnerabilities arise when potential security risks are present within your Azure environment. Implement Azure security best practices. Implement Azure security best practices involves adopting recommended security measures and policies to protect your Azure resources. Use Azure Security Center. Use Azure Security Center involves utilizing a centralized security service that provides threat detection, vulnerability assessment, and security recommendations for your Azure environment. Integration challenges. Integration challenges may arise when connecting Azure services with other applications or systems. Use Azure APIs. Use Azure APIs involves interacting with Azure services through programmatic interfaces for integration and automation. Leverage Azure SDKs. Leverage Azure SDKs involves using pre-built libraries and tools for interacting with Azure services, making it easier to develop and integrate applications. Resource group location like OpenAI resource container. Inputs. Azure subscription refers to the specific Azure account where the user is authorized to manage resources. It's akin to an account on a cloud platform that allows access to services and resources like virtual machines, storage, and databases. Resource group name represents the name given to a collection of Azure resources, such as virtual machines, databases, and storage accounts, that are grouped together for ease of management and deployment. This grouping allows for centralized control over the resources, making it convenient to manage and deploy them as a single unit. Outputs. Azure region denotes the geographic location where the resources are deployed within the Azure cloud infrastructure. This choice of location influences factors like data latency, availability, and compliance regulations, with various regions offering distinct features and benefits. Steps. Create resource group refers to the process of setting up a new resource group in Azure. This action involves creating a logical container for grouping and managing related Azure resources in a centralized manner. It provides a convenient way to organize and deploy resources for specific projects or applications. Set location involves choosing the specific Azure region where the resources within the resource group will be deployed. This choice impacts factors like data latency, availability, and compliance requirements. Careful consideration should be given to the region selection based on the specific needs and priorities of the project or application. Prerequisites. Azure subscription is an essential requirement for accessing and managing resources within Azure Cloud Platform. This subscription acts as a contract between the user and Microsoft, granting access to various Azure services and resources. It often involves specific pricing plans and resource limits based on the chosen subscription type. Subscription ID is a unique identifier assigned to each Azure subscription. It allows for tracking and managing the subscription independently, ensuring proper access control and resource allocation. This ID is crucial for identifying the specific subscription when interacting with Azure services and resources. Azure account represents the user account used for authenticating and accessing resources within the Azure Cloud Platform. This account provides a unique identity for the user, enabling them to interact with Azure services and manage their subscriptions. It often involves various levels of permissions and access rights, allowing users to control their resources and operations within the Azure environment. Account name is the unique identifier assigned to an Azure account, allowing for differentiation between different users accessing the Azure platform. This name serves as a primary identifier, facilitating the authentication process and enabling the user to interact with Azure services and manage their resources. Fine-tune parameters. Resource group name is a key parameter for fine-tuning the deployment and configuration of Azure resources within a specific resource group. It allows for precise targeting of resources and their associated settings, enabling granular control over the deployment process. The name should be clear and descriptive, reflecting the purpose of the resource group. RG name is a short abbreviation for the resource group name, commonly used as a variable or identifier in scripts or code for referring to the specific resource group. It provides a concise representation of the resource group, making it easier to work with in automation and scripting contexts. Challenges and fixes. Resource group already exists is a common issue encountered when attempting to create a resource group that already exists in Azure. This conflict arises due to the uniqueness requirement for resource group names within a specific subscription. The fix involves either deleting the existing resource group or choosing a different name for the new one. Delete existing resource group refers to the process of removing an existing resource group from Azure. This action is typically taken when the resource group is no longer required or when a new resource group with a different name needs to be created. It's essential to carefully review the resources within the resource group before deletion to avoid losing critical data. Invalid location refers to the scenario where the specified Azure region for deploying resources is not supported or valid for the chosen services or resources. This issue arises due to specific availability limitations within different regions. The fix involves checking the list of allowed regions for the specific services and choosing an appropriate alternative. Check allowed regions involves reviewing the list of supported Azure regions for the specific services or resources that are being deployed. This step ensures that the chosen location is valid and compatible with the selected resources. The list of allowed regions can typically be found in the Azure documentation or through the Azure portal. Insufficient permissions refers to the lack of necessary access rights to perform an operation on Azure resources. This issue often arises due to limitations imposed on the user's account or the role assigned to them. The fix involves granting appropriate permissions to the account or changing the assigned role to ensure sufficient access rights for the required actions. Grant permissions involves assigning necessary access rights to the user account or role that needs to perform specific actions on Azure resources. This step ensures that the user has the required permissions to deploy, manage, and interact with resources within the Azure environment. Granting permissions involves modifying the user's role or assigning new roles with specific Permissions based on the required actions. The first step is to create a Microsoft Azure account. This involves providing basic information, such as your email address and a password, and agreeing to the Azure terms of service. Choose a subscription type. Azure offers various subscription types, each tailored to different needs and use cases. You can select a free trial, a pay-as-you-go subscription, or a reserved instance subscription, depending on your requirements and budget. Set billing information. After choosing a subscription type, you'll need to provide your payment information. This could be a credit card, a bank account, or another supported payment method, enabling Azure to bill you for the resources you consume. Manage access and permissions. Once your subscription is active, you can control who has access to its resources and what they can do. This involves setting up user roles, assigning permissions, and managing access control lists (ACLs) to ensure security and accountability. Azure subscription prerequisites. Azure account. You need an active Azure account to create and use an Azure subscription. You can sign up for a free Azure account, which provides you with a set of free credits and resources to explore the platform. Payment method. To utilize Azure services, you will need to provide a valid payment method. This is essential for billing purposes, allowing Azure to charge you for the resources you consume based on your chosen subscription type. Azure subscription fine-tune parameters. Subscription quota. This parameter determines the resource limits of your Azure subscription, such as the number of virtual machines, storage capacity, and data transfer limits. You can adjust these quotas to meet your specific requirements. Subscription region. This parameter specifies the geographical location where your Azure resources are deployed. You can choose a region based on factors like latency, data sovereignty, and cost considerations. Azure subscription challenges and fixes. Unexpected billing charges. If you encounter unexpected charges on your Azure subscription, it's important to investigate the root cause. You can review your Azure usage reports to identify any potential overutilization or unexpected resource consumption. If you are unable to resolve the issue yourself, you can contact Azure support for assistance. Access denied. If you are denied access to an Azure resource, you should verify your user permissions and roles. Ensure that you have the necessary permissions to access the resource and that you are assigned a appropriate role. If your access is still denied, you can consult with your Azure administrator or contact Azure support for further troubleshooting. Resource group location like OpenAI resource container. Inputs. Azure subscription. This refers to the subscription you have with Microsoft Azure. It's an account that lets you access and use Azure resources and services. Think of it as a billing account that enables you to use Azure. Resource group name. This is the name you choose for a collection of Azure resources. It's like a folder where you organize related resources, making management easier. Imagine it as a container for your Azure assets, like a virtual machine, storage account, or database. Outputs. Resource group location. This represents the geographical location where your Azure resources reside. It defines the region where your resources will be hosted and can influence factors like latency and compliance. Picture it as the physical location of your Azure data center. Steps. Log into Azure portal. This involves accessing the Azure portal, which is the web-based interface for managing Azure services. Think of it as your control panel for interacting with Azure. Navigate to resource groups. This step involves locating and accessing the section in the Azure portal where you manage resource groups. Imagine it as going to the directory of your Azure resource containers. Select the resource group. This entails choosing the specific resource group you are interested in. Based on its name, it's like picking the folder containing your desired Azure assets. View the location. This involves inspecting the properties of the selected resource group and identifying its geographical location. Imagine it as reading the address label on your Azure container. Prerequisites: Azure account. This refers to your Microsoft Azure account, which is your identity within the Azure ecosystem. It's like your passport to access and use Azure services. Azure subscription. This refers to the subscription you have with Microsoft Azure. It's an account that lets you access and use Azure resources and services. Think of it as a billing account that enables you to use Azure. Resource group. This is the name you choose for a collection of Azure resources. It's like a folder where you organize related resources, making management easier. Imagine it as a container for your Azure assets, like a virtual machine, storage account, or database. Resource group name. This is the name you choose for a collection of Azure resources. It's like a folder where you organize related resources, making management easier. Imagine it as a container for your Azure assets, like a virtual machine, storage account, or database. Fine-tune parameters. Resource group location. This represents the geographical location where your Azure resources reside. It defines the region where your resources will be hosted and can influence factors like latency and compliance. Picture it as the physical location of your Azure data center. Resource group name. This is the name you choose for a collection of Azure resources. It's like a folder where you organize related resources, making management easier. Imagine it as a container for your Azure assets, like a virtual machine, storage account, or database. Challenges and fixes. Unable to find the resource group. This issue arises when the specified resource group doesn't exist or isn't accessible in your Azure environment. Imagine it as searching for a folder that's not there. Verify resource group name. This involves double-checking that the resource group name you provided is correct and matches the actual name of the resource group in Azure. It's like ensuring you're spelling the folder name correctly. Unable to view the location. This problem occurs when you cannot see the location information of the resource group in the Azure portal. Imagine it as being unable to read the address label on the folder. Check if the resource group is in the Azure portal. This involves confirming that the resource group you are looking for is actually listed within the Azure portal. It's like making sure the folder exists in the directory. Refresh the Azure portal. This entails refreshing the Azure portal to ensure you are viewing the latest data. It's like updating the directory listing to get the most recent information. Resource name description. Inputs. The first input that the resource requires for successful execution. This could be a data file, a configuration setting, or an external service dependency. Example input 1. This could be a CSV file containing customer data for a data processing resource. The second input that the resource requires, similar to input 1, this could be another data file, a configuration setting, or an external service dependency. Example input 2. This could be a JSON file specifying the transformation rules for the customer data. In input 1. Outputs. The first output that the resource generates after processing the inputs. Example output 1. This could be a transformed CSV file with the customer data processed according to the rules in input 2. The second output that the resource generates. This could be a log file containing information about the execution of the resource. Example output 2. This could be a log file recording the start and end times of the processing task and any errors that occurred. Steps. The first step involved in the execution of the resource. This step is typically executed in sequence with other steps. Example step 1. This could be the step where the resource reads the customer data from input 1. The second step involved in the execution of the resource. This step is typically executed after step 1 and before step 3. Example step 2. This could be the step where the resource applies the transformation rules from input 2 to the customer data. Prerequisites. The first condition or dependency that needs to be met before the resource can be executed. Example values for prerequisite 1. This could be the existence of a specific database table required for the transformation process. The second condition or dependency that needs to be met before the resource can be executed. Example values for prerequisite 2. This could be the availability of a specific software library needed to perform the transformation logic. Fine-tune parameters. The first parameter that can be adjusted to modify the behavior or performance of the resource. Example parameter 1. This could be a parameter controlling the number of threads used for parallel processing to optimize execution speed. The second parameter that can be adjusted to modify the behavior or performance of the resource. Example parameter 2. This could be a parameter specifying the memory allocation for the resource to ensure sufficient resources are available for processing. Challenges and fixes. A common challenge or issue that can arise during the execution of the resource. Fixes to challenge 1. This could be a list of steps or workarounds to address the challenge, such as increasing the memory allocation or modifying the input data format. Another common challenge or issue that can arise during the execution of the resource. Fixes to challenge 2. This could be a list of steps or workarounds to address the challenge, such as updating the software library or checking the database connection. Deployment blades. The deployment blades section describes the process of deploying Azure resources using Azure Resource Manager ARM templates. ARM templates are JSON files that define the infrastructure and configuration of Azure resources, such as virtual machines, storage accounts, and network resources. Inputs. Resource group name. This input specifies the name of the Azure resource group where the resources will be deployed. Resource groups are containers for Azure resources, providing a logical grouping for management and billing purposes. For example, you might use a resource group to organize resources related to a specific application or project. ARM template location. This input specifies the location of the ARM template file. The template file can be stored in a variety of locations, including Azure Storage, GitHub, or a local file system. The location should be accessible to the deployment process. Outputs. Deployed resources. This output represents the list of resources successfully deployed by the ARM template. It provides a summary of the resources created or updated during the deployment process. This information can be used to track and manage the deployed resources. Deployment status. This output indicates the overall status of the deployment process. It can be either succeeded, failed, or cancelled, depending on the outcome of the deployment. This output provides visibility into the success or failure of the deployment operation. Steps. Create resource group. This step involves creating a new Azure resource group if one doesn't already exist. A resource group serves as a container for Azure resources, facilitating management and organization. For instance, you might create a resource group to house the resources related to a particular application or project. Deploy ARM template. This step involves deploying the ARM template to the specified Azure resource group. The ARM template defines the infrastructure and configuration of the resources that will be deployed, such as virtual machines, storage accounts, and network resources. The deployment process applies the template specifications to create or update the resources within the resource group. Prerequisites. Azure subscription. This prerequisite ensures an active Azure subscription is available for the deployment process. An Azure subscription is required to access and manage Azure resources, including the deployment of ARM templates. Active subscription. This prerequisite specifically requires that the Azure subscription is active and has sufficient permissions to deploy resources. This implies that the subscription is in good standing and not suspended or expired. Azure Resource Group. This prerequisite verifies the existence of a specific Azure resource group. A resource group is a logical container for Azure resources, providing organization and management capabilities. For example, you might create a resource group to house the resources related to a particular application or project. Existing resource group. This prerequisite indicates that the specified resource group must already exist before the deployment can proceed. This ensures that the deployment targets a pre-existing resource group, facilitating the organization of resources within a defined container. Fine-tune parameters. Deployment mode. This parameter allows you to specify the deployment mode, which determines the behavior of the deployment process. Common modes include incremental, where only changes are applied, and complete, where the entire resource configuration is reapplied. Location. This parameter indicates the Azure region where the resources defined in the ARM template will be deployed. Location selection influences factors like resource availability, performance, and cost. Challenges and fixes. Invalid template syntax. This challenge arises when the ARM template contains syntax errors, preventing it from being correctly parsed and deployed. Validate template syntax. This fix involves carefully reviewing the ARM template syntax to identify and correct any errors. Tools like the Azure Portal or Visual Studio Code provide syntax highlighting and validation capabilities, assisting in identifying and resolving issues. Missing resource permissions. This challenge occurs when the deploying account lacks the necessary permissions to manage the Azure resources specified in the ARM template. Grant necessary permissions. This fix involves assigning the appropriate Azure role-based access control (RBAC) permissions to the deploying account, enabling it to manage the resources in the target resource group. For instance, the contributor role provides broad permissions for managing resources within a resource group. Deployment failure. This challenge indicates that the deployment process encountered an error, preventing the resources from being successfully deployed. Review deployment logs. This fix involves examining the deployment logs for detailed information about the failure. The logs often provide valuable insights into the specific error, helping identify the cause and potential solutions. Troubleshoot errors. This fix involves investigating the identified errors using the available documentation, forums, and support resources. Troubleshooting may involve validating the ARM template syntax, checking resource permissions, verifying dependencies, and addressing specific error messages. Deployment information. Deployment type. This refers to the type of deployment that the model undergoes. Batch deployment indicates that the model is deployed in a way where a large amount of data is processed in one go, as opposed to real-time or continuous deployment. For example, a model that is trained on a large dataset of images and then deployed to classify images uploaded by users in batches. Inputs. This refers to the raw data that is fed into the machine learning model for training and processing. Data ingestion involves collecting, cleaning, and preparing the data for use by the model. This could involve retrieving data from databases, APIs, or files and transforming it into a format suitable for the model. For example, a model that predicts house prices might ingest data from a real estate database containing details like location, size, and amenities. This step involves using the collected data to train the machine learning model. This includes feeding the data to the model and adjusting its parameters to learn patterns and make accurate predictions. For example, a spam detection model is trained using a dataset of emails labeled as spam or not spam, allowing the model to learn the characteristics of spam emails. Outputs. This refers to the trained model itself, which can be used to make predictions. It captures the knowledge learned during the training process. For example, a trained model for image classification can be saved as a file and deployed to a server for real-time image classification. These are metrics that quantify the performance of the model, indicating its accuracy and effectiveness. Performance metrics can include accuracy, precision, recall, and F1 score, among others. They help evaluate the model's ability to generalize to new data and make accurate predictions. For example, the accuracy of a spam detection model could be measured by the percentage of emails correctly classified as spam or not spam. Steps. This step involves cleaning and organizing the data before feeding it to the machine learning model. Data preparation may include tasks like handling missing values, formatting data, and feature engineering to ensure data quality and model performance. For example, in a model predicting customer churn, data preparation might involve imputing missing customer information or creating new features based on existing data. This involves feeding the prepared data to the chosen machine learning model and adjusting its parameters to learn patterns and make accurate predictions. This step is critical for the model to learn from the data and improve its performance. For example, a model predicting customer churn might be trained using algorithms like logistic regression or decision trees. This step involves evaluating the trained model's performance using different metrics and testing its ability to generalize to new, unseen data. This helps assess the model's effectiveness and identify any biases or limitations. For example, a trained model for predicting customer churn can be evaluated using metrics like accuracy, precision, and recall on a separate test dataset. This involves deploying the trained model to a production environment where it can be used to make predictions on real-world data. Model deployment can be done on a server, cloud platform, or embedded into applications. For example, a trained model for predicting customer churn can be deployed on a website to identify customers at risk of leaving. Prerequisites. This refers to the availability of the necessary data for training and evaluating the model. The data should be of sufficient quality and volume to train a robust model. Data quality involves checking for inconsistencies, errors, or missing values that could affect the model's performance. For example, a model predicting house prices would require access to accurate data on house characteristics, location, and market trends. This involves having the necessary computing resources, including hardware and software, to train, deploy, and run the model efficiently. Infrastructure setup involves configuring the computing environment and ensuring sufficient storage and processing power for the model. For example, training a large language model might require access to powerful GPUs and a cloud computing platform with sufficient storage. Fine-tune parameters. This refers to the process of optimizing the model's hyperparameters to achieve better performance. Hyperparameter tuning involves adjusting the parameters of the learning algorithm, such as learning rate, regularization strength, and number of layers to improve the model's accuracy and generalization. For example, a model for image classification could be fine-tuned by adjusting the learning rate to control a model's learning speed. This involves selecting or designing the architecture of the machine learning model. The model architecture determines the model's structure and how it processes information, which can significantly influence its performance. For example, a convolutional neural network (CNN) is a popular architecture for image classification, while recurrent neural networks (RNNs) are often used for natural language processing tasks. Challenges and fixes. This refers to a common challenge in machine learning where the dataset contains an uneven distribution of classes. Data imbalance can lead to biased models that favor the majority class. Resampling techniques aim to address this by adjusting the data distribution, such as oversampling the minority class or undersampling the majority class. For example, in a fraud detection model where fraudulent transactions are rare, oversampling fraudulent transactions can improve the model's ability to detect them. This refers to a scenario where the model performs well on the training data but fails to generalize well to new, unseen data. Overfitting can occur when the model learns the training data too well, memorizing noise and patterns that are not representative of the real world. Regularization techniques aim to prevent overfitting by adding penalties to the model's complexity. Common techniques include L1 and L2 regularization, dropout, and early stopping. For example, in a model predicting customer churn, regularization techniques can help prevent the model from overfitting to specific customer profiles, improving its ability to predict churn for new customers. Azure OpenAI Azure subscription. This section describes Azure OpenAI service, which is a cloud-based service that provides access to powerful AI models, including GPT 3.5, GPT-4, and Codex. Inputs. Azure subscription refers to a subscription to Microsoft Azure, a cloud computing platform that offers various services, including Azure OpenAI. To use Azure OpenAI service, you need to have an active Azure subscription. Azure OpenAI resource represents the specific resource that you create within your Azure subscription to interact with Azure OpenAI models. This resource encapsulates the settings and configurations related to your Azure OpenAI usage. Outputs. Access to Azure OpenAI models enables you to utilize the various AI models offered by Azure OpenAI, including GPT 3.5, GPT-4, and Codex. These models can be used for tasks like text generation, translation, summarization, and code generation. Ability to fine-tune models grants you the capability to customize the behavior of Azure OpenAI models by providing them with specific training data. This allows you to tailor the models to perform tasks aligned with your specific needs and objectives. Steps. Create an Azure subscription involves signing up for a Microsoft Azure account and choosing a subscription plan based on your requirements. This step is crucial to access and utilize the resources within the Azure ecosystem, including Azure OpenAI service. Create an Azure OpenAI resource involves configuring a dedicated resource within your Azure subscription to interact with Azure OpenAI models. This resource encompasses essential settings such as the resource group, location, and pricing tier. Deployed an Azure OpenAI model entails selecting and deploying a specific AI model from the Azure OpenAI catalog to your Azure OpenAI resource. This model will then be available for usage within your Azure environment, enabling you to leverage its capabilities for your projects. Prerequisites. Azure subscription is a prerequisite for accessing and utilizing Azure OpenAI service. It can be an Azure free trial, pay-as-you-go subscription, or an enterprise agreement depending on your usage needs and budgetary considerations. Azure OpenAI Resource is a prerequisite for using Azure OpenAI models. It requires you to create a resource within your Azure subscription, specifying details like the resource group, location, and pricing tier. This resource is essential to interact with and manage your Azure OpenAI models. Fine-tune parameters. Training data refers to the data that is used to fine-tune Azure OpenAI models. This data should be relevant to the task you want the model to perform and can be in various formats such as text, code, or other data types supported by the model. For instance, if you want to fine-tune a language model for generating code, you would provide it with a dataset of code examples. Model parameters refer to the settings and configurations that can be adjusted during the fine-tuning process to influence the behavior of Azure OpenAI models. These parameters include factors like the learning rate, the number of training epochs, and the batch size. By tuning these parameters, you can achieve optimal performance for your specific use case. Challenges and fixes. Access denied to Azure OpenAI resource can occur due to insufficient permissions for the user attempting to access the resource. This issue can be resolved by verifying user permissions and ensuring they have the necessary privileges to interact with the Azure OpenAI resource. For example, if a user does not have the contributor role on the resource group containing the Azure OpenAI resource, they will be denied access. Model deployment errors can arise due to misconfigurations during the deployment process. These errors can be resolved by carefully reviewing and verifying the deployment configuration, ensuring that all settings are correct and align with the requirements of the Azure OpenAI model being deployed. For example, an error might occur if the deployment configuration specifies an incorrect resource group or pricing tier. Azure OpenAI Azure Account. Azure OpenAI Service is a cloud-based service that provides access to powerful AI models. Azure OpenAI offers a range of pre-trained AI models, including GPT-3, Codex, and DAL, that can be used for various tasks such as text generation, translation, code completion, and image creation. These models are highly versatile and can be customized to meet specific needs. Inputs. An Azure subscription is a prerequisite for accessing and utilizing Azure OpenAI Service. An Azure subscription serves as the foundation for your cloud environment, enabling you to provision resources and manage your cloud deployments. It acts as a central account for billing and accessing various Azure services, including Azure OpenAI. An Azure OpenAI resource is a dedicated instance of Azure OpenAI Service, providing a platform to host and interact with OpenAI models. It acts as a container for your OpenAI models, allowing you to manage and deploy them within your Azure environment. Outputs. AI-generated text refers to the output produced by Azure OpenAI models in response to user prompts or requests. It can encompass various forms of written content, such as articles, stories, poems, summaries, or even creative writing. Chatbot responses represent the conversational interactions generated by Azure OpenAI models, simulating human-like dialogue. They can provide information, answer questions, or engage in natural language conversations, enhancing user experiences in applications like customer support or virtual assistants. Steps. 1. Create an Azure OpenAI resource. 2. Deploy an OpenAI model. 3. Configure access to your Azure OpenAI resource. Prerequisites. An active Azure subscription is required to create and use Azure OpenAI resources. An Azure subscription acts as your account with Microsoft Azure. enabling you to create, manage, and access resources within the Azure Cloud Platform. It allows you to deploy and manage your Azure OpenAI resources, which are essential for using Azure OpenAI models and services. An Azure OpenAI resource is needed to deploy and use OpenAI models. An Azure OpenAI resource serves as a dedicated platform within your Azure environment to host and manage your OpenAI models. It provides a controlled environment for deploying, accessing, and interacting with OpenAI models, ensuring secure and efficient utilization of these powerful AI tools. Fine-tune parameters. Learning rate is a critical parameter in the fine-tuning process, determining the step size taken during each update of the model's weights. It controls how quickly the model adapts to new training data, balancing the trade-off between convergence speed and potential overfitting. Epochs represent the number of times the entire training dataset is passed through the model during fine-tuning. Each epoch provides an opportunity for the model to learn from the data and update its parameters. The choice of epochs influences the model's training duration and its ability to learn complex patterns from the data. Challenges and fixes. Access denied issues often arise due to insufficient permissions granted to the user account. Attempting to access the Azure OpenAI resource. Ensure that the user account has the necessary roles and permissions to access and interact with the Azure OpenAI resource. This can be achieved by assigning the appropriate Azure role to the user account, granting them the required privileges for managing and using the Azure OpenAI service. Model deployment issues can stem from various factors, including incorrect configuration, network connectivity problems, or underlying infrastructure issues. Thoroughly review the Azure OpenAI resource deployment status and examine any error messages to identify the root cause of the issue. Consult relevant documentation, utilize troubleshooting tools, and seek assistance from Azure support if needed to resolve the deployment issues effectively. Azure OpenAI Deployment Blades. Inputs. Azure subscription represents the Azure subscription that you are using to access and deploy Azure OpenAI resources. This is a fundamental requirement for any Azure-based operation, ensuring that you have the necessary permissions and resources to work with Azure OpenAI services. Azure Resource Group. A logical grouping of Azure resources within your subscription. This helps you organize your resources, control access, and manage billing for your Azure OpenAI deployment. This group will house the specific resources related to your chosen model and deployment. Azure Location. The geographic location where your Azure OpenAI deployment will be hosted. This is important for data residency considerations, latency optimization, and compliance with regional regulations. You can choose from a variety of Azure regions worldwide based on your needs. Azure OpenAI Service Name. A unique identifier for your Azure OpenAI service within your Azure subscription. This service provides access to Azure OpenAI models and enables you to deploy and manage them. The service name should be descriptive and easily recognizable. Azure OpenAI Deployment Name. A user-defined name for your Azure OpenAI deployment. This name should be unique within your Azure resource group and help you distinguish between different deployments for different models or purposes. Model type specifies the type of Azure OpenAI model you wish to deploy. This could be a text-based model for language tasks, a code-based model for generating or analyzing code, or a model tailored to a specific domain or application. Choose a model based on your desired capabilities and use case. Model version identifies the specific version of the chosen Azure OpenAI model. This ensures consistency and reproducibility, as versions may include improvements, bug fixes, or enhancements. It is recommended to use the latest stable version unless you have a specific reason for using an older version. Model SKU: the pricing tier associated with your chosen Azure OpenAI model. Different SKUs offer varying levels of compute power, memory, and pricing. Select the SKU that best aligns with your performance and budget requirements. Deployment type determines how your chosen Azure OpenAI model will be deployed. Options typically include single-node or multi-node deployments. Depending on your scalability and performance needs, choose a type that best fits your expected workload and usage patterns. Deployment size: the amount of compute resources allocated to your Azure OpenAI deployment. This directly impacts the performance and capacity of your deployment. Higher deployment sizes provide greater resources but come at a higher cost. Choose a size based on your anticipated throughput, response times, and budget. Outputs: deployed Azure OpenAI model: the specific Azure OpenAI model that has been successfully deployed based on your input parameters. This output provides information about the model itself, including its type, version, and associated properties. Deployment endpoint: the URL or endpoint where your deployed Azure OpenAI model is accessible for use. This is the address you will use to send requests to your model and receive responses. Usage metrics: data related to the usage of your deployed Azure OpenAI model, such as requests made, response times, and resource consumption. This information is valuable for monitoring performance, identifying potential bottlenecks, and optimizing your deployment. Steps: create Azure OpenAI resource: the initial step involves creating the necessary Azure OpenAI resources in your chosen Azure resource group. This includes setting up the Azure OpenAI service and configuring its access permissions. Create Azure OpenAI deployment: this step entails the creation of the actual deployment for your chosen Azure OpenAI model. This involves specifying the deployment name, location, model type, and version, as well as defining the deployment's configuration settings. Configure deployment settings: after creating the deployment, you can further customize its settings to optimize its behavior and performance. This might involve configuring the deployment size, deployment type, or setting specific parameters for the model's execution. Deploy model: this crucial step initiates the actual deployment of your chosen Azure OpenAI model onto the Azure infrastructure. This involves provisioning the necessary resources, loading the model's data, and making it available for use. Test deployment: once the deployment is complete, it is essential to test its functionality and ensure it is working as expected. This involves sending sample requests to the model, analyzing the responses, and verifying that they meet your requirements. Prerequisites: Azure subscription: the Azure subscription should be active and have sufficient permissions to create and manage Azure OpenAI resources. You may need to enable specific features within your subscription to work with Azure OpenAI. Azure Resource Group: an existing Azure Resource Group should be available to house the Azure OpenAI resources related to your deployment. This ensures proper organization and management of your resources. Azure OpenAI Service: a created Azure OpenAI service should be available within your subscription. This provides the necessary framework to access and deploy Azure OpenAI models. Fine-tune parameters. Training data: this refers to the dataset used to fine-tune your chosen Azure OpenAI model. Fine-tuning allows you to adapt a pre-trained model to your specific domain or application, improving its performance and accuracy for your use case. Fine-tuning objectives: these are the goals you aim to achieve through fine-tuning. For example, you might want to improve the model's ability to generate more relevant responses or enhance its Understanding of specific terminology. Evaluation metrics. These are the measures used to assess the effectiveness of fine-tuning. Common metrics include accuracy, precision, recall, and F1 score, depending on your task and objectives. Challenges and fixes. Deployment failure. Deployment failures can occur due to various factors such as insufficient resource limits, incorrect deployment settings, or transient infrastructure issues. Check resource limits. Ensure that your Azure subscription and resource group have adequate resources, including compute power and memory, to accommodate your chosen Azure OpenAI model and deployment size. Verify deployment settings. Carefully review and double-check all deployment settings, including model type, version, deployment size, and any other parameters to ensure they are accurate and aligned with your requirements. Retry deployment. In some cases, deployment failures might be transient and can be resolved by simply retrying the deployment process. Model performance issues. Even after a successful deployment, model performance may not meet your expectations due to factors such as inadequate fine-tuning, inappropriate model configuration, or simply the inherent limitations of the chosen model. Review fine-tuning parameters. Evaluate the training data, objectives, and metrics used for fine-tuning to ensure they are relevant and optimized for your use case. Optimize model configuration. Explore the various configuration options available for your chosen model, such as parameters for controlling response generation, temperature settings, or other model-specific settings. Consider alternative models if the current model is not suitable for your task. Consider exploring other available Azure OpenAI models that might be better suited to your specific requirements. Cost optimization. Deploying and using Azure OpenAI models can incur costs, and it's essential to optimize your deployment for cost effectiveness. Select appropriate model SKU. Choose the model SKU that provides the necessary performance while minimizing costs. Consider factors such as usage patterns, throughput requirements, and budget constraints. Implement usage monitoring. Actively monitor the usage of your deployed Azure OpenAI model to identify periods of low activity or potential inefficiencies. This allows you to adjust deployment size or other settings to optimize resource allocation. Optimize deployment size. Ensure that the deployment size is appropriate for your expected workload. Avoid over-provisioning resources that might lead to unnecessary costs, but also ensure sufficient capacity to handle peak usage periods. Azure OpenAI. Create a deployment type. Batch deployment. Real-time inputs. Azure OpenAI resource is an Azure OpenAI service that you need to create and manage your Azure OpenAI deployments. Azure OpenAI deployment name is the name of the deployment you want to create. It is a unique identifier for your deployment. Outputs. Azure OpenAI deployment is the resulting deployment created by following these steps on Azure OpenAI service. It allows you to use the specified model for real-time interactions through API calls. Steps. Navigate to Azure portal is the first step of creating a batch deployment for real-time use cases. On Azure OpenAI, you need to open the Azure portal and log in to your Azure account. Select Azure OpenAI resource is the second step of creating a batch deployment for real-time use cases on Azure OpenAI. You need to navigate to your Azure OpenAI resource within the Azure portal. Click Deployments is the third step of creating a batch deployment for real-time use cases on Azure OpenAI. In the Azure OpenAI resource blade, you need to click on the Deployments section to manage your deployments. Select Create Deployment is the fourth step of creating a batch deployment for real-time use cases on Azure OpenAI. Click on the Create Deployment button to start creating a new deployment. Provide deployment name is the fifth step of creating a batch deployment for real-time use cases on Azure OpenAI. You need to enter a unique name for your deployment in the provided field. Select deployment type is the sixth step of creating a batch deployment for real-time use cases on Azure OpenAI. You need to select the type of deployment you want to create for this deployment. In this case, it is batch deployment for real-time use cases. Configure deployment settings is the seventh step of creating a batch deployment for real-time use cases on Azure OpenAI. You need to specify the model you want to use for this deployment and any other related settings, like the size of the deployment. Click Create is the eighth and the final step of creating a batch deployment for real-time use cases on Azure OpenAI. After configuring the deployment settings, you need to click on the Create button to start the deployment process. Prerequisites. Azure Subscription. Active subscription is a requirement for creating a batch deployment for real-time use cases on Azure OpenAI. You need to have an active Azure subscription to access and use Azure OpenAI services. Azure OpenAI Resource. Created Azure OpenAI Resource is a requirement for creating a batch deployment for real-time use cases on Azure OpenAI. You need to have already created an Azure OpenAI resource in your Azure subscription to proceed with deployment creation. Fine-tune parameters. Model name is the name of the model you want to use for this deployment. It is an important parameter for creating a batch deployment for real-time use cases on Azure OpenAI. Deployment type is a parameter that specifies the type of deployment you want to create. In this case, it is a batch deployment for real-time use cases. Challenges and fixes. Deployment fails to create. Check Azure OpenAI resource status is a solution to the problem of deployment failure. You need to verify the status of your Azure OpenAI resource to ensure it is active and ready for deployment. Deployment takes too long. Monitor deployment progress is a solution to the problem of deployment taking too long. You need to monitor the deployment progress in the Azure portal to track the status and estimated time of completion. Verify Azure OpenAI resource availability is a solution to the problem of deployment taking too long. You need to ensure that your Azure OpenAI resource is available and has sufficient resources to support the deployment. Creating an Azure OpenAI deployment. Type. Real-time deployment type. This represents the type of deployment you want to create. Real-time deployments are used for applications that require immediate responses from the model, such as chatbots or interactive applications. Batch deployment type. This represents the type of deployment you want to create. Batch deployments are used for applications that process large amounts of data at once, such as generating text summaries or analyzing customer feedback. Inputs. Azure OpenAI resource input. This is the Azure OpenAI resource that you want to deploy the model to. You must have an active Azure OpenAI service with the necessary resources to deploy the model. Deployment name input. This is the name you want to give to your deployment. The name should be unique within your Azure OpenAI resource. Model name input. This is the name of the OpenAI model you want to deploy. You can choose from a variety of pre-trained models, such as GPT-3 or Codex. Outputs. Deployed model output. This represents the successfully deployed model which can now be used for its intended purpose, such as text generation, translation, or code completion. Steps. Create Azure OpenAI resource step. This step involves creating an Azure OpenAI resource if you don't already have one. The resource will contain your deployments and allow you to manage your OpenAI usage. Select deployment type step. This step involves selecting the type of deployment you want to create. You can choose between real-time and batch deployments based on your specific needs and application requirements. Select model name step. This step involves selecting the specific OpenAI model you want to deploy. From the available pre-trained models, you can choose a model based on its capabilities, such as text generation, translation, or code completion. Deploy model step. This step involves deploying the selected OpenAI model to the Azure OpenAI resource. This step involves configuring the deployment settings and starting the deployment process. Prerequisites. Azure subscription prerequisite. You need an active Azure subscription to use Azure OpenAI services. This subscription provides the necessary resources and access to the OpenAI platform. Active subscription prerequisite. This is a prerequisite that states that the Azure subscription should be active and not expired or inactive. It indicates that the subscription needs to be in a state where it is usable. Azure OpenAI Service prerequisite. You need an enabled Azure OpenAI service within your Azure subscription to deploy OpenAI models. This service provides the necessary API endpoints and resources for interacting with OpenAI models. Enabled service prerequisite. This is a prerequisite that states that the Azure OpenAI service should be enabled within your Azure subscription. It indicates that the service needs to be activated and available for use. Fine-tune parameters. Fine-tuning data parameter. This refers to the data that you want to use to fine-tune the pre-trained OpenAI model to suit your specific needs. This data should be relevant to your application and aligned with the model's capabilities. Fine-tuning hyperparameters parameter. This refers to the settings that you can adjust during fine-tuning to control the training process and optimize the model's performance. These settings include parameters such as learning rate, batch size, and number of epochs, challenges and fixes. Deployment failure challenge. This refers to a situation where the deployment process fails to complete successfully. This could be due to various factors, such as insufficient resources, network issues, or configuration errors. Check resource permissions fix. This is a fix for a deployment failure. It involves verifying that your Azure OpenAI resource has the necessary permissions and resources to deploy the model. It might involve checking if the resource has sufficient storage, compute power, and access to the required APIs. Model not found challenge. This refers to a situation where the specified OpenAI model cannot be found within the available pre-trained models. This could be due to incorrect model name, availability issues, or access restrictions. Verify model name fix. This is a fix for a model not found error. It involves double-checking the name of the OpenAI model you are trying to deploy and making sure it is spelled correctly and exists in the available models. Resource quota exceeded challenge. This refers to a situation where the Azure OpenAI resource has reached its limit for deploying models. This could be due to exceeding the allocated quota for deployments, storage, or compute resources. Increase quota fix. This is a fix for a resource quota exceeded error. It involves increasing the resource quota for your Azure OpenAI resource. This might involve contacting Azure support or adjusting the resource settings to allocate more resources for deployments. Deployment timeout challenge. This refers to a situation where the deployment process takes too long to complete and times out before finishing. This could be due to complex models, high resource demands, or network limitations. Increase timeout fix. This is a fix for a deployment timeout issue. It involves increasing the timeout duration for the deployment process. This might involve adjusting the deployment settings to allow more time for the process to complete. Azure OpenAI Endpoint URL usage. Description of input parameters used for accessing the Azure OpenAI endpoint. The name of the deployed Azure OpenAI model that will be used for making requests. This name is provided during the deployment process in the Azure OpenAI service. For instance, if you have deployed a GPT-3 model named Text Generation Model, then this value would be Text Generation Model, an authentication key provided by Azure OpenAI service used for securely accessing the deployed model. This key is associated with your Azure subscription and the specific Azure OpenAI resource you created. Keep this key confidential and store it securely to prevent unauthorized access. Description of outputs from the Azure OpenAI endpoint usage. The response received from the Azure OpenAI service after sending a request to the endpoint. This response will contain the generated text or other output from the model based on your input prompt. It may include parameters like tokens used, completion probability, and other relevant information. Description of steps involved in utilizing the Azure OpenAI endpoint. Retrieve the URL of the Azure OpenAI endpoint based on the provided deployment name. This endpoint is unique to each deployed model and allows you to communicate with the model. You can obtain this URL through the Azure OpenAI Service Portal or API. Construct an HTTP request with necessary headers in the input prompt you want to send to the model. The headers should include authentication information using your API key and other required parameters. The body of the request will contain the text prompt or instruction for the model. Send the constructed HTTP request to the Azure OpenAI endpoint. This step establishes a connection with the deployed model and sends your input prompt. The Azure OpenAI service will process the request and use the model to generate a response. Receive the response from the Azure OpenAI service and process the output. This response will contain the generated text or other output based on your prompt. Analyze the response, extract the desired information, and use it accordingly in your application. Description of prerequisites for utilizing the Azure OpenAI endpoint. An active Azure subscription is required to access and use the Azure OpenAI service. This subscription allows you to create Azure OpenAI resources and deploy models for your projects. An Azure OpenAI resource needs to be created within your subscription to access and utilize the Azure OpenAI service. This resource is a container for your Azure OpenAI models and allows you to manage and deploy them. A model needs to be deployed to your Azure OpenAI resource to generate text or other outputs. You can deploy models from the Azure OpenAI Service Marketplace, including models like GPT-3, Codex, and DAL. Description of parameters used for fine-tuning the Azure OpenAI model. This parameter controls the degree of randomness or creativity in the model's output. Higher temperatures result in more unpredictable and diverse responses, while lower temperatures produce more focused and deterministic outputs. For example, a temperature of 1 would make the model more creative and explore different ideas, while a temperature of 0 would make the model more predictable and likely to stick to the main theme of the input. This parameter controls the diversity of the model's output by setting a probability threshold for token selection. A higher top p-value will allow more tokens with higher probabilities to be considered, resulting in more diverse outputs. Conversely, a lower top p-value will restrict the model to a smaller set of tokens with the highest probabilities, leading to more focused and predictable outputs. This parameter specifies the maximum number of tokens the model is allowed to generate in its output. This limit is useful for controlling the length of the generated text and preventing excessively long responses. For example, if you set max tokens to 100, the model will generate no more than 100 tokens in its response. regardless of the input prompt or other parameters. Description of common challenges encountered and their corresponding fixes when using the Azure OpenAI endpoint. Ensure that the API key and deployment name you are using are correct and have not expired. Double-check that the API key matches the key associated with your Azure subscription and pay. Deployment name is correct for the desired model. Incorrect authentication credentials can result in authentication errors. Make sure that the Azure OpenAI resource name you are referencing in your request is accurate. Verify that the resource name is correctly specified and that the resource exists within your Azure subscription. A mismatched resource name will lead to endpoint not found errors. Azure OpenAI service has rate limits in place to prevent overuse of the service. If you are exceeding the rate limit, you may receive errors indicating that you are being rate limited. Consider increasing your rate limit if possible or implement rate limiting mechanisms in your application to avoid exceeding the limits. Verify that the Azure OpenAI model is currently healthy and available to process requests. Check the model status in the Azure OpenAI Service Portal or API to ensure that it is running correctly. Also, verify that the network connectivity between your application and the Azure OpenAI endpoint is stable. Network issues can result in unresponsive models and connection errors. Azure OpenAI resource allocations. Inputs. Azure subscription refers to a specific Azure subscription that holds the necessary resources to provision and use Azure OpenAI services. For instance, this could be your company's main Azure subscription used for development and deployment. Azure Resource Group represents a logical container within your Azure subscription where you group related Azure resources. For example, you could have a resource group named OpenAI Project to hold your Azure OpenAI resources, like deployments and resources. Outputs. Azure OpenAI resource. This output represents the created Azure OpenAI resource, providing you with access to powerful large language models for natural language processing tasks. For example, you might get an Azure OpenAI resource named My OpenAI resource that lets you use a specific language model for your project. Azure OpenAI deployment represents a deployed instance of an Azure OpenAI model, making it accessible for use within your application. For instance, you might create a deployment named GPT-3 deployment to make the GPT-3 model ready for tasks like text generation. Steps. Create Azure OpenAI resource. This step involves provisioning an Azure OpenAI resource within your Azure subscription and resource group, giving you access to the desired language models. For instance, you might create an Azure OpenAI resource called My OpenAI resource to use for text summarization. Create Azure OpenAI deployment. This step deploys a specific Azure OpenAI model onto your created resource, making it ready for use within your application. For example, you might deploy the GPT-3 model to your resource named My OpenAI resource so you can use it for language translation tasks. Prerequisites. Azure subscription. Active Azure subscription. This refers to a valid and active Azure subscription that has the necessary permissions and quotas for provisioning Azure OpenAI resources. This ensures you have the necessary funds and administrative rights to create and use OpenAI services. Azure Resource Group. Existing Azure Resource Group. A pre-existing Azure Resource Group within your subscription where you will allocate and organize your Azure OpenAI resources. Having an existing resource group helps you manage and organize your resources related to OpenAI within a specific environment or project. Fine-tune parameters. Model name specifies the name of the specific Azure OpenAI model you intend to fine-tune for your specific needs. For example, You could choose to fine-tune the GPT-3 model to be better at generating marketing content, giving it a name like GPT-3 Marketing Model. Training data refers to the dataset of text or code used to train the Azure OpenAI model, which is crucial to fine-tuning its capabilities to perform specific tasks. For example, you might use a dataset of marketing slogans to train the GPT-3 model to generate marketing content more effectively. Challenges and fixes. Quota exhaustion represents a situation where you've exceeded your allocated quotas for using Azure OpenAI resources. This can happen if you are making excessive calls to the service or have a high usage volume. Contact Microsoft Support suggests reaching out to Microsoft Support to address the quota issue, potentially requesting a quota increase or discussing alternative solutions to manage your usage. Model training failure occurs when the fine-tuning process for your Azure OpenAI model encounters errors or fails to complete successfully. Review training data recommends carefully examining your training data for any issues like data quality problems, biases, or inconsistencies. These issues can hinder the model's ability to learn effectively. Adjust model parameters suggests experimenting with different fine-tuning parameters, such as learning rate, batch size, and epochs. Optimizing these parameters can improve the model's training process and prevent failures. Azure OpenAI Azure Monitoring. This YAML represents the steps involved in monitoring Azure OpenAI service performance and usage. Using Azure Monitor, it outlines the inputs, outputs, steps, prerequisites, fine-tuning parameters, and potential challenges with solutions. Inputs. The resource ID of the Azure OpenAI service to be monitored. This ID uniquely identifies the service within your Azure subscription. It acts as the target for the monitoring process. The Azure Monitor workspace where the collected performance and usage data will be stored when visualized. This workspace provides a central location for managing and analyzing monitoring data. Outputs. The Azure Monitor workspace stores and displays the collected metrics and logs from the Azure OpenAI service. These metrics provide insights into the service's performance, such as request rates, latency, and successful completions. The logs capture detailed information about individual requests and responses, aiding in troubleshooting specific issues. Based on the configured thresholds and conditions, Azure Monitor triggers alerts and notifications when certain performance or usage patterns are detected. These alerts can be sent via email, SMS, or other channels, enabling prompt intervention when necessary. Steps. First, you need to configure the Azure Monitor workspace to receive data from the Azure OpenAI service. This involves configuring the workspace settings and ensuring it's properly linked to the service. Enable diagnostic logging for the Azure OpenAI service. This ensures that detailed logs about service operations are sent to the Azure Monitor workspace. For analysis, create Azure Monitor alerts based on specific metrics and thresholds. These alerts trigger notifications when the defined conditions are met, providing timely warnings of potential issues. Prerequisites. An active Azure subscription is necessary to access and manage the Azure OpenAI service. The subscription should have the necessary permissions to create and configure resources. An existing Azure Monitor workspace is required to store and analyze the collected data from the Azure OpenAI service. You can create a new workspace or use an existing one that meets your monitoring needs. Fine-tune parameters. The specific metrics to be monitored are crucial for obtaining meaningful insights into the Azure OpenAI services performance and usage. Examples of these metrics include the number of requests, average latency, successful completions, and error rates. Alert thresholds define the critical levels for the monitored metrics. When these thresholds are exceeded, alerts are triggered. Setting appropriate thresholds is crucial to identify potentially problematic situations and respond promptly. Challenges and fixes. If no data appears in the Azure Monitor workspace, ensure that diagnostic logging has been enabled for the Azure OpenAI service. This enables the service to send its performance and usage data to the workspace for analysis. If alerts aren't triggering as expected, review the alert thresholds and conditions. Ensure they accurately reflect the desired monitoring requirements and that the configured metrics are being collected correctly. Create Azure OpenAI resource. The first step involves provisioning an Azure OpenAI resource within your Azure subscription. This resource provides access to the Azure OpenAI service and its underlying models. Upload fine-tuning data. The fine-tuning data is uploaded to the Azure OpenAI resource. This data needs to be formatted in a way the service understands and can process for training. Initiate fine-tuning. Once the data is uploaded, the fine-tuning process is started. This involves feeding the data to the chosen language model and adjusting its parameters to improve its performance on the specific tasks defined by the data. Monitor fine-tuning progress. The progress of the fine-tuning process is monitored. This involves tracking metrics such as loss, accuracy, and training time to gauge the model's learning and identify any potential issues. Deploy fine-tuned model. After successful fine-tuning, the model is deployed, making it available for use in applications. This allows developers to integrate the newly trained model into their systems to perform tasks specific to the training data. Prerequisites. Azure subscription. A subscription to Azure is required to access the Azure OpenAI service. This subscription provides the necessary resources and credits for using the service. Azure account. To use an Azure subscription, a Microsoft Azure account is needed. This account provides access to the Azure portal, where subscription management and service deployment take place. Azure OpenAI resource. A specific Azure OpenAI resource must be created within your subscription. This resource represents an instance of the service and provides access to the various language models and APIs. API key. A unique API key is generated for the Azure OpenAI resource. This key is used to authenticate requests to the service and allows you to control access to your specific resource. Fine-tune parameters. Training data format specifies the format of the fine-tuning data. This might involve defining the structure of the text, code, or label text pairs, ensuring consistency in how the data is presented to the model. Verifying model deployment ensures that the desired Azure OpenAI model is correctly deployed within your Azure OpenAI resource and that it is running as expected. Model type. This parameter defines the type of language model used for fine-tuning. Azure OpenAI offers a range of models with different capabilities and strengths, allowing you to choose the one that best suits your task. Model response error. Epochs. The number of times the training data is passed through the model during fine-tuning. Increasing the number of epochs can improve the model's performance but may also increase training time. Checking the input format ensures that the input data provided to the Azure OpenAI model adheres to the model's expected structure, data types, and formatting conventions. Reviewing model parameters involves analyzing the settings and configurations used with the model to identify any potential issues or misconfigurations that might be causing the error. Learning rate. This parameter controls how much the model's parameters are adjusted during each training step. A higher learning rate can lead to faster training but may make the model less stable. Model performance issues, challenges and fixes. Fine-tuning a model involves using a subset of your specific data to further train the pre-trained Azure OpenAI model, adapting it to your particular tasks and improving its performance on those tasks. Data format inconsistency. If the data provided for fine-tuning is not formatted consistently, the model may struggle to learn effectively. For example, inconsistencies in text formatting or label assignment can confuse the model. Ensure data format compatibility before starting fine-tuning. It's crucial to verify that the data is formatted correctly and adheres to the requirements of the chosen Azure OpenAI model. Optimizing model parameters involves fine-tuning the various settings and configurations of a Azure OpenAI model, such as the learning rate, the number of layers, and the size of the hidden units, to enhance its performance and accuracy. Insufficient training data. If the dataset used for fine-tuning is too small, the model may not learn well enough to perform tasks effectively. This is especially true for complex tasks like text generation or code translation. Increase data quantity to improve performance. Consider increasing the size of the fine-tuning dataset. Gathering more relevant data can help the model learn better and achieve better results. Overfitting. Overfitting occurs when the model learns the training data too well and fails to generalize to new data. This means it performs well on the data it was trained on but poorly on unseen data. Adjust hyperparameters. Adjusting parameters like the learning rate or number of epochs can help prevent overfitting. Experimenting with different values can improve the model's ability to generalize. Use regularization techniques like L1 or L2. Regularization can be applied to the model during training to prevent overfitting. By penalizing complex models, resource constraints. Fine-tuning can be computationally expensive, and resource limitations like CPU or memory can hinder the training process. Use larger compute resources if resource constraints are a concern. Using larger compute resources like GPUs or dedicated virtual machines can speed up training and improve performance. Optimize code. Optimizing the code used for fine-tuning can improve efficiency and reduce resource usage. This may involve using efficient libraries or optimizing data processing steps. Reduce model size if resource constraints are a major concern. Consider using a smaller model variant for fine-tuning. This can reduce the memory and compute requirements, although it may also impact the model's capabilities. Fine-tuning failure. Fine-tuning may fail due to various reasons, such as issues with the data, code errors, or resource limitations. Check error logs. Thoroughly review the error logs generated during the fine-tuning process to identify the root cause of the failure. Retrain model. Once the issue is resolved, retrain the model using the corrected data or code. Debug code. Carefully debug the code involved in the fine-tuning process to identify and fix any errors. This may involve stepping through the code to understand its execution flow and pinpoint potential problems. Azure OpenAI model types. Azure OpenAI model types information. Inputs. Name of the Azure OpenAI model to be used, for example, text DaVinci 003. The name given to the deployment of the Azure OpenAI model. It acts as an identifier for the deployed model. The unique key provided by Azure to access and interact with the deployed Azure OpenAI model. It is essential for making requests and receiving responses. Outputs. The response generated by the Azure OpenAI model based on the provided input and model parameters. It can be text, code, or other relevant outputs. The completed output of the model. It represents the final response generated by the Azure OpenAI model after processing the input and Executing the model's operations. Steps. Creating an Azure OpenAI resource involves setting up an instance of the service within your Azure subscription, defining its configuration, and provisioning resources like compute power and storage. Deploying a model means making a specific Azure OpenAI model available for use within your Azure OpenAI resource. This involves specifying the desired model version and configuring its settings for access. Sending an API request to the Azure OpenAI model requires formulating a structured message containing your input data, desired model parameters, and the API key for authentication. The request is then sent to the deployed model for processing. Prerequisites. Azure subscription. A free trial subscription is a short-term subscription that allows new Azure users to evaluate and experiment with Azure services without any upfront financial commitment. It usually includes a limited amount of free resources and credits for a specific duration. A pay-as-you-go subscription provides flexibility in managing Azure resources based on your specific needs. It involves paying only for the resources you use, making it suitable for projects with varying resource demands. Azure OpenAI Resource. The free tier offers a limited capacity option for experimenting with Azure OpenAI services at no cost. It provides a certain amount of free compute time and storage for basic use cases. The standard tier provides a more robust option with increased compute power, storage, and performance capabilities, making it suitable for production environments and more demanding workloads. Fine-tune parameters. The learning rate is a crucial parameter during model fine-tuning that determines the step size taken during each iteration of the training process. It controls how quickly the model's weights are adjusted based on the training data. The number of epochs represents the number of passes through the entire training dataset during the fine-tuning process. Each epoch involves the model learning from the data, making adjustments, and iteratively improving its performance. Challenges and fixes. Model not responding. Checking the API key validity involves verifying if the provided key is correct, has not expired, and has sufficient permissions to access the deployed model. Verifying model deployment ensures that the desired Azure OpenAI model is correctly deployed within your Azure OpenAI resource and that it is running as expected. Model response error. Checking the input format ensures that the input data provided to the Azure OpenAI model adheres to the model's expected structure, data types, and formatting conventions. Reviewing model parameters involves analyzing the settings and configurations used with the model to identify any potential issues or misconfigurations that might be causing the error. Model performance issues. Fine-tuning a model involves using a subset of your specific data to further train the pre-trained Azure OpenAI model, adapting it to your particular tasks and improving its performance on those tasks. Optimizing model parameters involves fine-tuning the various settings and configurations of a Azure OpenAI model, such as the learning rate, the number of layers, and the size of the hidden units, to enhance its performance and accuracy. Azure OpenAI issue storage account to store models. Inputs. The Azure subscription that the Azure OpenAI service is deployed in. This is a subscription that has been activated and has the necessary resources allocated. The Azure resource group that the Azure OpenAI service is deployed in. This is a logical grouping of Azure resources that allows for organized management and access control. The name of the Azure storage account that will be used to store the Azure OpenAI models. This storage account needs to be in the same Azure region as the Azure OpenAI service. Outputs. The Azure storage account that was created to store the Azure OpenAI models. This storage account can be accessed by the Azure OpenAI service to retrieve and use the stored models. Steps: create a storage account in the Azure region where the Azure OpenAI service is deployed. Ensure that the storage account is configured to be accessible by the Azure OpenAI service. Create a container within the storage account that will be used to store the Azure OpenAI models. Name the container in a way that is easily identifiable and consistent with the Azure OpenAI service configuration. Upload the model files to the container. Ensure that the model files are organized in a way that allows for easy retrieval and use by the Azure OpenAI service. Prerequisites: Azure subscription. The ID of the Azure subscription that the Azure OpenAI service is deployed in. This ID is a unique identifier for the subscription. Azure Resource Group. The name of the Azure Resource Group that the Azure OpenAI service is deployed in. This name is used to identify the resource group. Azure Storage Account Name. The name that will be used for the Azure Storage Account. This name should be unique within the Azure region. Fine-tune parameters. The size of the Azure OpenAI model that will be used for fine-tuning. This parameter influences the complexity and performance of the model. The type of Azure OpenAI model that will be used for fine-tuning. This parameter determines the architecture and capabilities of the model. Challenges and fixes. Access denied error. Verify that the Azure OpenAI service has the necessary permissions to access the storage account. This can be achieved by granting appropriate roles to the Azure OpenAI service. Storage account quota exceeded. Increase the storage account quota to accommodate the Azure OpenAI models. This can be done by contacting Azure support or by upgrading the storage account to a larger tier. Model file size too large. Compress the model files to reduce their size. This can be done using compression tools like 7-zip or WinRAR. Break the model files into smaller chunks. This allows for efficient uploading and storage of large model files. Network connectivity issues. Check the network connectivity between the Azure OpenAI service and the storage account. This can be done by using network diagnostic tools. Use a VPN or express route connection to establish a secure and reliable network connection between the Azure OpenAI service and the storage account. This ensures consistent and fast data transfer. Ensure that the storage account is accessible from the Azure OpenAI service by checking the firewall rules and network security groups associated with the storage account. This allows for unrestricted access to the stored models. Azure OpenAI client configurations. Inputs. Azure subscription. This refers to the Azure subscription that will be used to deploy and manage the Azure OpenAI resource. It's a key prerequisite for accessing and utilizing Azure services, including OpenAI. Azure Resource Group. This is a logical container within Azure, acting as a grouping mechanism for related resources. It simplifies management and organization, providing a central location for deploying and controlling resources. Azure OpenAI resource. This represents the Azure OpenAI resource itself, encompassing the deployed OpenAI model and associated components within Azure. This resource provides access to OpenAI's powerful language models through Azure. Outputs. Deployed OpenAI model. This represents the specific OpenAI model, e.g. TextDaVinci 003, TextQuery 001 that is successfully deployed and operational within the Azure environment. OpenAI API keys. These are unique and confidential keys that provide authentication and authorization for accessing and utilizing the deployed OpenAI model via the API. OpenAI endpoint. This is the specific network address URL where requests to the deployed OpenAI model should be directed. It acts as a gateway for interacting with the model and obtaining responses. Steps. Create Azure Resource Group. Deploy Azure OpenAI Resource. Get OpenAI API keys. Get OpenAI endpoint. Prerequisites. Azure subscription. Active Azure subscription. This refers to a valid and active Azure subscription that is ready to be used for deploying and managing Azure resources. It ensures proper authentication and access to Azure services. Azure OpenAI Resource. Deployment region. This specifies the geographical location within Azure where the Azure OpenAI resource will be deployed. It influences factors like data sovereignty and network latency. Fine-tune parameters. Model type. Text DaVinci 003. This is one of the pre-trained OpenAI models available for fine-tuning. It's known for its high-quality text generation capabilities and diverse language understanding. Text Query 001. This is another pre-trained OpenAI model suitable for fine-tuning. It offers a balance of performance and speed, making it suitable for various text-based tasks. Training data. Text data file. This refers to the dataset or file containing the text data that will be used to fine-tune the chosen OpenAI model. The data should be relevant to the desired task or application. Hyperparameters. Learning rate. This hyperparameter controls the step size used during model training. It impacts the speed and accuracy of the learning process, influencing how quickly the model adapts to the training data. Batch size. This hyperparameter determines the number of training examples processed in each batch. During the learning process, it affects the memory consumption and computation time of training. Challenges and fixes. Challenge 1. Missing Azure credentials. Ensure Azure credentials configured. This involves verifying that the necessary Azure credentials, such as subscription ID, tenant ID, and client secret, are correctly configured and accessible. These credentials are crucial for authenticating with Azure services. Challenge 2. Deployment region unavailable. Select available deployment region. This step requires identifying and selecting a deployment region within Azure that supports Azure OpenAI resources. The availability of deployment regions may vary depending on factors like geographic location and resource quotas. Challenge 3. OpenAI API key not found. Regenerate OpenAI API key. This involves regenerating a new OpenAI API key from the Azure portal. The key should be treated confidentially as it grants access to the deployed OpenAI model. Challenge 4. OpenAI endpoint not found. Contact Azure support. This indicates that the endpoint for accessing the deployed OpenAI model might be missing or inaccessible. It's recommended to contact Azure support for assistance in resolving this issue. Azure OpenAI connection string. Inputs. Azure subscription ID. Unique identifier for the Azure subscription to which the Azure OpenAI resource belongs. It's a string like example. Azure Resource Group. Name of the resource group where the Azure OpenAI resource is deployed. It's a string like my resource group. Example, my OpenAI G. Azure OpenAI deployment name. Name of the deployed Azure OpenAI model. This is the specific version of the model that you want to access and use. It's a string like my GPT model. Example, GPT-35 Turbo. Azure OpenAI resource name. Name of the Azure OpenAI resource, which represents the overall OpenAI service instance. This name helps you identify the resource within your Azure account. It's a string like my OpenAI source. Example, OpenAI Service 001. Outputs. Connection string. A string that contains the access credentials required to connect to and use your Azure OpenAI deployment. It is generated using the provided input values and is used to authenticate and authorize requests to the Azure OpenAI service. An example format is endpoint HTTPS, access key, API version. Example: endpoint HTTPS my OpenAI source, OpenAI, Azure, com access key copy version 202. 30315 preview. Steps. Retrieve Azure credentials. This step involves fetching the authentication credentials necessary to interact with the Azure OpenAI service. These credentials might include an access key or a service principal token. Create Azure OpenAI client. This step involves instantiating a client object that will be used to communicate with the Azure OpenAI service. This client object is typically created using a library or SDK specific to the Azure OpenAI service, such as the Azure Cognitive Services SDK. Get Azure OpenAI deployment details. This step involves retrieving specific information about the Azure OpenAI deployment, such as its endpoint URL, model version, and other relevant details. This information is required to establish a proper connection and interact with the selected model. Generate connection string. This step combines the retrieved credentials, deployment details, and other required parameters to construct the final connection string. This string is used to connect to the Azure OpenAI service and perform operations such as sending requests to the deployed model for generating text or conducting other AI tasks. Prerequisites. Azure subscription. This refers to an existing Azure subscription account that provides access to Azure services and resources. It is essential for deploying and using Azure OpenAI resources. Azure Subscription ID. Unique identifier for the Azure subscription to which the Azure OpenAI resource belongs. It's a string like example. Azure Resource Group. Name of the resource group where the Azure OpenAI resource is deployed. It's a string like my resource group. Example: my OpenAI G. Azure OpenAI resource. This represents a dedicated Azure OpenAI service instance deployed within your Azure subscription. It provides access to various OpenAI models and functionalities. Azure OpenAI resource name. Name of the Azure OpenAI resource, which represents the overall OpenAI service instance. This name helps you identify the resource within your Azure account. It's a string like my OpenAI source. Example: OpenAI Service 001. Azure OpenAI deployment name. Name of the deployed Azure OpenAI model. This is the specific version of the model that you want to access and use. It's a string like my GPT model. Example: GPT-35 Turbo. Fine-tune parameters. Temperature. This parameter controls the randomness and creativity of the responses generated by the Azure OpenAI model. A higher temperature value, e.g. 1.0, leads to more unpredictable and potentially surprising outputs, while a lower value, e.g. 0.2, generates more consistent and predictable results. It's a floating point number between 0 and 1. Example: 0.7. Top P. This parameter influences the selection of words during text generation. It limits the probability distribution of the next word to a certain percentage p. Higher values of top P, e.g. 0.9, allow for a wider range of words to be considered, while lower values, e.g. 0.1, restrict the choices to the most probable words. It's a floating point number between 0 and 1. Example: 0.8. Challenges and fixes. Invalid credentials. This occurs when the provided Azure credentials are incorrect or expired. This could be due to typos, outdated credentials, or insufficient permissions. Verify Azure credentials to address this issue. Carefully recheck the provided Azure credentials for accuracy and ensure that they are up to date. Make sure you have the correct Azure subscription ID, resource group name, and access key or service principal credentials. If necessary, regenerate or update the credentials using the Azure portal or other appropriate methods. Missing deployment. This indicates that the specified Azure OpenAI deployment does not exist in a provided resource group. This could happen if the deployment was deleted or never created. Deploy Azure OpenAI resource to resolve this. You need to deploy the desired Azure OpenAI model to the specified resource group. This can be done using the Azure portal, Azure CLI, or Azure PowerShell. Ensure that you select the correct model and configure the necessary deployment settings. Invalid deployment name. This occurs when the provided deployment name does not match any existing deployments within the specified resource group. This could be due to typos or using an incorrect deployment name. Correct deployment name. Double-check the spelling and case sensitivity of the deployment name. Use the Azure portal or other management tools to verify the correct deployment names available in the specified resource group and adjust your code accordingly. Connection string error. This indicates a problem with the generated connection string, which may prevent successful communication with the Azure OpenAI service. This could be due to errors in the string's format, missing parameters, or invalid credentials. Regenerate connection string to fix this. Try regenerating the connection string using the provided input parameters. Make sure the input values are correct and ensure that the necessary prerequisites, such as Azure subscription and OpenAI resource, are in place. If the issue persists, check for any errors in the code generating the connection string and consult Azure OpenAI documentation for guidance. Azure OpenAI API key details. Inputs. Azure subscription. This refers to the subscription within the Microsoft Azure cloud platform that you are using to access and manage OpenAI resources. It's like your account on Azure, allowing you to pay for and utilize Azure services. OpenAI resource. This represents an instance of an OpenAI service deployed within Azure, providing access to OpenAI models and capabilities. Imagine it as a dedicated space within your Azure environment tailored for using OpenAI. Outputs. API key. This is a unique identifier, like a password, granting you access to the specific OpenAI resource you have set up. It's essential for authenticating your requests and using OpenAI services within your applications. Endpoint URL. This is the web address, like a website URL, pointing to the specific OpenAI resource you are using. You'll need this to connect your code or application to the OpenAI service for making requests. Steps. Navigate to Azure portal. This refers to accessing the Azure portal, the web-based interface for managing Azure resources. It's your primary control panel for interacting with Azure. Access OpenAI resource. This means going to the specific OpenAI resource you created within your Azure subscription. It's like finding the specific OpenAI service you want to use among your Azure resources. Generate API key. This refers to creating a unique key specifically for your chosen OpenAI resource. Think of it as setting up a password for accessing this specific OpenAI service. Copy API key. This means copying the newly generated API key from the Azure portal to use later in your code or application. It's like saving your password in a safe place so you can access it when needed. Prerequisites. Azure subscription. Free trial. A temporary, limited use Azure subscription offered by Microsoft to explore Azure features and services. Think of it as a free trial period to experiment with Azure. Paid subscription. A paid, full-featured Azure subscription providing access to a wider range of Azure resources and services. It's like purchasing an account to fully utilize Azure OpenAI resource. Create OpenAI resource. This means setting up an instance of an OpenAI service within your Azure subscription. It's like creating a dedicated workspace within Azure for utilizing OpenAI. Fine-tune parameters. Model type. This refers to the specific type of OpenAI model you are using, like GPT-3 or Codex. It's like choosing the specific AI tool you want to use for your task. Deployment name. This is a name you give to your chosen OpenAI model when deployed within Azure. It's like giving a label to your chosen AI tool within your Azure environment. Challenges and fixes. Access denied. Verify permissions. This means checking your account's access permissions for the specific OpenAI resource you are trying to access. It's like making sure you have the right credentials to access the AI tool you want to use. API key not found. Regenerate API key. This means creating a new API key for the specific OpenAI resource you are using. It's like resetting your password to gain access to the specific AI tool you want to use. Azure OpenAI Deployment vs Endpoint vs Feature vs Configuration. This document compares the concepts of deployment, endpoint, feature, and configuration in the context of Azure OpenAI. Inputs. Azure OpenAI Deployment is a resource within Azure that encapsulates an AI model and the compute resources it requires to function. Deployments enable you to manage and utilize AI models in a controlled and scalable manner. Azure OpenAI Endpoint acts as a gateway that allows access to an Azure OpenAI deployment. Endpoints provide a dedicated address for interacting with a specific AI model, allowing you to send requests and receive responses. Azure OpenAI feature represents a specific capability of the Azure OpenAI service. Each feature offers a distinct set of functionalities, such as text generation, summarization, translation, and more. These features enable you to leverage the AI model's capabilities for various tasks. Azure OpenAI configuration refers to the settings that customize the behavior of an AI model within an Azure OpenAI deployment. Configuration allows you to fine-tune the model's parameters and settings to achieve desired results. For specific use cases, outputs. A deployment, once created, provides a container for your AI model and its associated compute resources. These resources enable the model to process requests and generate responses. The deployment ensures the model's availability and performance. An endpoint serves as a dedicated address for interacting with the AI model within a deployment. By creating an endpoint, you enable secure and reliable access to the model's capabilities. Features are the core functionalities of the Azure OpenAI service, providing you with access to diverse AI capabilities. Each feature represents a unique set of functionalities tailored to different tasks, such as language generation, summarization, and translation. Configuration settings allow you to tailor the behavior of the AI model within a deployment. These settings include parameters like temperature, top K, and top P, which influence the model's output and its level of creativity. Steps. Deploying a model involves choosing the desired AI model, configuring the compute resources required for its operation, and deploying the model to an Azure environment. This process prepares the model for use. Creating an endpoint involves specifying the access control settings, such as authentication mechanisms and network restrictions, to ensure secure access to the model through the endpoint. Choosing a feature involves selecting the specific capability you want to utilize from Pay. Available features of the Azure OpenAI service. For instance, you may choose the Text DaVinci 003 model for text generation or Text Curie 001 for summarization. Configuring a model involves adjusting the settings specific to the chosen AI model. These settings may include temperature, top K, and top P, which can influence the model's creativity and output style. Prerequisites. An Azure subscription is necessary to access and utilize Azure OpenAI resources. This subscription can be a free trial or a paid subscription, depending on your requirements and usage. An Azure OpenAI resource is required to deploy and manage AI models. This resource represents an instance of the Azure OpenAI service, and it allows you to select and deploy specific models from a catalog. Fine-tune parameters. Learning rate is a crucial parameter in fine-tuning an AI model. It controls the step size during the training process, determining how quickly the model's weights are adjusted based on the training data. A smaller learning rate results in slower but more precise adjustments, while a larger learning rate leads to faster but potentially less precise updates. Epochs represent the number of times the entire training dataset is fed into the AI model during fine-tuning. Each epoch involves processing the entire dataset and updating the model's parameters. More epochs generally lead to better model performance but require more training time and resources. Challenges and fixes. If a model fails to deploy, it could be due to issues with the deployment settings or resource limitations. Check if the selected compute resources are sufficient for the chosen model. Ensure that the deployment settings, such as the model type and version, are correctly configured. If an endpoint is inaccessible, it could be due to problems with endpoint access settings or network connectivity. Verify that the endpoint's access control settings allow the required access. Check if there are any network connectivity issues between your application and the endpoint. If a feature is not available, it might be because the selected AI model does not support that particular feature. Ensure that the model you are using supports the desired feature. Check the documentation or feature descriptions to confirm compatibility. Model configuration issues can arise from incorrect or inconsistent settings. Review the configuration parameters, such as temperature, top K, and top P, to ensure they are suitable for the intended use case. Adjust these settings accordingly to achieve the desired results. Azure OpenAI 1 deployment vs 1 endpoint vs 1 feature vs 1 different set of configurations. This YAML document provides an overview of Azure OpenAI's deployment, endpoint, feature, and configuration options for fine-tuning and using large language models (LLMs). Inputs. A key component for accessing Azure OpenAI's services. This is the primary point of interaction for your projects and is created within the Azure portal. Data used to train a specific model for a particular task. This data must be properly formatted and aligned with the selected LLM's capabilities. Outputs. The final product of the fine-tuning process. This represents an LLM that has been trained on your specific data and is tailored to a particular task. The results generated by the fine-tuned model based on provided inputs. These outputs can be text, code, translations, summaries, or other forms of information. Steps. The first step involves creating an Azure OpenAI resource in your Azure subscription. This resource provides the environment for working with LLMs. Choosing a deployment type is crucial. Azure OpenAI offers options like Azure OpenAI Service for general-purpose LLM deployment and Azure OpenAI Studio for custom model creation. An endpoint is a specific location where your model will be deployed. This endpoint can be based on region and resource availability, affecting performance and latency. The fine-tuning process is about customizing your model. You need to define features like training data, learning rate, and epochs to achieve your desired outcomes. This step involves setting up the environment for deploying your fine-tuned model. It includes configurations like resource allocation, model compatibility, and deployment settings. Using the selected deployment settings and provided fine-tuning parameters, the model is trained on the input data. This process results in a customized LLM. After successful fine-tuning, the model is deployed on the chosen endpoint. It's now ready to receive inputs and generate predictions based on your training data. This involves providing inputs to the deployed model and receiving outputs. The model will utilize the knowledge it gained during fine-tuning to generate accurate and relevant predictions. Prerequisites: an active subscription with Azure to access and manage its resources, including the Azure OpenAI service. The Azure OpenAI service must be enabled within your subscription to utilize its features. This can be done through the Azure portal. Fine-tune parameters: a key factor in the fine-tuning process. It determines how much the model's weights are adjusted during each training iteration. A higher learning rate can speed up training but may lead to instability. The number of times the entire training dataset is presented to the model during fine-tuning. More epochs can improve accuracy but increase training time. The number of training samples used in each iteration of the learning process. Smaller batch sizes can improve accuracy but increase training time. Challenges and fixes: issues may arise during resource creation due to insufficient quota, unavailable services, or subscription problems. It's important to check your subscription status, quota limits, and service availability. Misconfigurations in the endpoint settings, including type, region, and resource limits, can lead to errors. Ensure that the endpoint type, region, and resource limits align with your requirements. The fine-tuning process can be affected by learning rate, epochs, and batch size. To address performance problems, adjust these parameters to find the optimal balance between training speed and accuracy. Deployment failures can occur due to misconfigured settings, limited resources, or model incompatibility. Carefully review deployment settings, resource availability, and model compatibility to resolve these issues. Errors in predictions can arise from incorrect input formats, incorrect prediction parameters, or misinterpretation of model outputs. Ensure that the input format adheres to the model's specifications. Use appropriate prediction parameters, and correctly interpret the generated outputs. Azure OpenAI Network Security Settings. Inputs: Azure subscription. This refers to an existing Azure subscription that will be used to create and manage Azure OpenAI resources. It provides access to Azure services and resources, including virtual networks, network security groups, and private endpoints. Azure Resource Group: a logical grouping of Azure resources, such as virtual networks, storage accounts, and virtual machines, deployed and managed as a unit. Creating a dedicated resource group for Azure OpenAI resources enhances organization and simplifies management. Azure OpenAI Service Name. This defines the unique name assigned to the Azure OpenAI Service instance. It acts as an identifier for this specific service within your Azure subscription. Network Security Group Name. This defines the unique name for the Network Security Group (NSG) created for managing network traffic to and from your Azure OpenAI service. NSGs act as firewalls, controlling network connectivity based on predefined rules. Virtual Network Name. This represents the unique name of the virtual network that will house your Azure OpenAI Service. Virtual networks isolate your resources from the public internet and provide a secure and managed network environment. Subnet name. A subnet is a smaller division within a virtual network, offering more granular network management. A dedicated subnet within the virtual network is reserved for hosting your Azure OpenAI service. Private endpoint name. The unique name for the private endpoint that will be created to securely connect to the Azure OpenAI service. Private endpoints enable secure and private connections from within your virtual network to Azure OpenAI resources. Private endpoint subnet name. The specific subnet within the virtual network where the private endpoint will be hosted. This subnet should be isolated and secure, limiting access to authorized resources. Azure AD Application ID. This is a unique identifier assigned to an Azure Active Directory application created to manage access to the Azure OpenAI service. The application acts as an intermediary, authenticating requests from your applications to the service. Azure AD Tenant ID represents the unique identifier for your Azure Active Directory tenant. It signifies the organization or entity owning the Azure AD instance where the application is registered. Azure AD Secret. A confidential key assigned to the Azure Active Directory application. This secret ensures secure communication between the application and the Azure OpenAI service. Outputs. Secured Azure OpenAI service represents the output of the configuration process, signifying a secure and isolated Azure OpenAI service within your virtual network, accessed through a private endpoint with restricted network access. Steps. Create Azure Resource Group. This step involves creating a dedicated resource group within your Azure subscription to hold and manage all the resources associated with your Azure OpenAI service. Create virtual network. This step creates a virtual network within your Azure subscription to isolate your Azure OpenAI service from the public internet and provide a secure and controlled network environment. Create subnet. This step creates a subnet within the newly created virtual network. The subnet acts as a dedicated space for hosting your Azure OpenAI service, separating it from other network resources. Create Network Security Group. This step creates a Network Security Group (NSG), acting as a firewall to control network access to and from your Azure OpenAI service, enforcing specific ingress and egress rules. Create Private Endpoint. This step creates a private endpoint within your virtual network, providing secure and private access to the Azure OpenAI service. The private endpoint acts as a gateway within your network to connect to the service. Configure Network Security Group rules. This step defines the specific rules for the network security group (NSG) controlling network access to and from your Azure OpenAI service. These rules define which traffic is permitted or blocked based on source, destination, and protocol. Grant access to private endpoint. This step involves granting the private endpoint access to the Azure OpenAI service. This step ensures that the private endpoint can connect to and utilize the service within the restricted network environment. Configure Azure OpenAI Service Network Settings. This step involves configuring the network settings of your Azure OpenAI service, specifically linking it to the private endpoint created in the previous steps. This ensures that the service is only accessible through the secure and isolated private endpoint. Connection. Prerequisites. Azure subscription. Existing Azure subscription. This refers to having an active and valid Azure subscription, which provides access to Azure services and resources, including the ability to create and manage virtual networks, network security groups, and private endpoints. Azure AD Application. Application ID. This is a unique identifier assigned to an Azure Active Directory application created for managing access to the Azure OpenAI service. The application acts as an intermediary, authenticating requests from your applications to the service. Tenant ID represents the unique identifier for your Azure Active Directory. Tenant. It signifies the organization or entity owning the Azure AD instance where the application is registered. Secret. A confidential key assigned to the Azure Active Directory application. This secret ensures secure communication between the application and the Azure OpenAI service. Fine-tune parameters. Network security group rules allow inbound traffic from specific IP addresses. This rule allows specific IP addresses to access your Azure OpenAI service. For example, you might allow access from a specific range of IP addresses used by your development team, ensuring that only authorized individuals can access the service. Allow outbound traffic to specific IP addresses. This rule defines which external IP addresses the Azure OpenAI service can communicate with. This ensures that the service only connects to pre-approved external services, reducing the risk of unauthorized connections. Challenges and fixes. Private endpoint connectivity issues. Verify private endpoint configuration. This involves carefully checking the configuration of the private endpoint, ensuring that it is correctly linked to the Azure OpenAI service and the associated virtual network and subnet. Any misconfiguration in the private endpoint settings can lead to connectivity problems. Check network security group rules. This step involves reviewing the rules defined within the network security group NSG associated with the private endpoint. Incorrectly configured NSG rules can block traffic to the private endpoint, causing connectivity issues. Azure OpenAI Service Authentication Errors. Ensure Azure AD application permissions. This involves verifying that the Azure Active Directory application used for authentication has the necessary permissions to access the Azure OpenAI service. Insufficient permissions can result in authentication failures. Validate Azure AD application secret. This step involves double-checking the secret assigned to the Azure AD application. An incorrect or expired secret will lead to authentication errors, preventing access to the Azure OpenAI service. Insufficient network bandwidth. Increase virtual network subnet size. This involves increasing the size of the subnet hosting the Azure OpenAI service. Insufficient subnet size can result in network congestion, leading to slow performance. Increasing the subnet size allocates more network resources, potentially improving performance. Optimize Azure OpenAI service deployment region. This involves selecting an Azure region geographically close to your users and data sources. Deploying the Azure OpenAI service in a region closer to users reduces latency and improves performance. Security vulnerabilities. Implement strong password policies. This involves implementing strong password policies for all accounts accessing the Azure OpenAI service. Strong password policies require complex passwords, including a mix of uppercase and lowercase letters, numbers, and special characters, making it more difficult for unauthorized individuals to guess passwords. Enable multi-factor authentication. This involves enabling multi-factor authentication for all accounts accessing the Azure OpenAI service. Multi-factor authentication adds an extra layer of security by requiring users to provide a second form of authentication, such as a code sent to their phone, in addition to their password. Regularly scan for vulnerabilities. This involves regularly scanning the Azure OpenAI service and its associated infrastructure for security vulnerabilities. Regularly scanning helps identify and address potential security weaknesses before they can be exploited. This refers to the name assigned to your created Azure OpenAI resource. It identifies the specific resource within your Azure subscription where you deploy and manage your Azure OpenAI models. Azure OpenAI model. Model name. This refers to the name of the Azure OpenAI model you choose to use for text generation. It determines the specific model's capabilities and how it interacts with your input prompts. Fine-tuning parameters. Temperature. This parameter controls the creativity and randomness of the generated text. Higher temperatures lead to more unexpected and diverse outputs, while lower temperatures produce more predictable and coherent responses. For example, a high temperature value might generate more creative and less conventional outputs, while a low temperature value might produce more accurate and consistent outputs. Top K. This parameter controls the number of most likely next words that the model considers when generating text. Higher values lead to more diverse outputs, while lower values produce more consistent and focused responses. For example, a high top K value might include less common and unexpected words, while a low top K value might focus on the most common and expected words. Challenges and fixes. Incorrect prompt. Refine prompt. This refers to the situation where the input prompt is not clear, ambiguous, or does not effectively communicate the desired text generation. To address this, refine the prompt by providing more context, specifying the desired output style, or breaking down the request into smaller, more manageable parts. Insufficient context. Provide more context. This refers to the situation where the input prompt lacks sufficient information for the model to generate relevant and coherent text. To address this, provide additional context in the prompt, such as background information, specific details, or examples of desired output. Model not found. Check model availability. This refers to the situation where the requested Azure OpenAI model is not available or has not been deployed correctly. To address this, ensure that the model name is correct, that the model is properly deployed in your Azure OpenAI resource, and that it is accessible within your Azure subscription. Rate limiting. Implement rate limiting mechanism. This refers to the situation where the Azure OpenAI service limits the number of requests you can make within a given time period. To address this, implement a rate limiting mechanism to ensure you do not exceed the service's limits and maintain consistent access to the Azure OpenAI models. This could involve limiting the frequency of requests, using a queuing system, or employing other strategies to manage the rate of requests to the service. Retrieve deployment details. The next step is to get the information about your OpenAI deployment. This involves retrieving the details like the deployment name, model version, endpoint, and other relevant information. Check deployment health. Finally, you can check the health of your OpenAI deployment by using the client and sending a health check request to the deployment. Prerequisites. Azure subscription. Subscription ID. Your unique identifier for your Azure subscription. It's a string of numbers and letters that helps identify your account. Resource group. A logical grouping of resources within your Azure subscription. Think of it as a folder for your resources. OpenAI resource. Resource name. The name you gave to your OpenAI resource in Azure. This name must be unique within your resource group. Location. The Azure region where your OpenAI resource is deployed, for example, East US, West US, or Europe West. Fine-tune parameters. Model version. The version of the OpenAI model you are using. Different versions may have different features and capabilities. A P version. the version of the API you are using to interact with the OpenAI service. It's important to be aware of the latest API version for compatibility and access to new features. Challenges and fixes. Network connectivity issues. Verify network connectivity. Ensure that your network is configured to allow access to the OpenAI service. Check for firewalls or other network restrictions that might be blocking the connection. Deployment not found. Check deployment name. Double-check that the name you are using to access the deployment is correct. Misspellings or case sensitivity can lead to deployment not found errors. Insufficient permissions. Grant access to resource. Make sure your account has the necessary permissions to access the OpenAI resource in deployment. This might involve granting your account a specific role with access permissions. Azure Open AI Generate Input. A description of the YAML structure for using Azure OpenAI to generate text. Inputs. Prompt a text string that provides context and instructions to the AI model. For example, write a short story about a cat who goes on an adventure. Model the specific AI model to be used for text generation. This could be a GPT-3 model like Text DaVinci 003 or a fine-tuned model created specifically for a particular task. Outputs. Generated text. The text generated by the Azure OpenAI service based on the provided prompt and model. Steps. Select model, choosing the appropriate AI model for the desired text generation task. Considering factors like model size, capabilities, and cost. Create prompt crafting, a clear and concise prompt that effectively guides the AI model to generate the desired output. This may involve providing examples, setting boundaries, or specifying the desired tone and style. Send request. Sending the prompt and selected model to the Azure OpenAI API to initiate text generation. Prerequisites. Azure subscription. An active Azure account with a subscription that allows access to Azure OpenAI services. Azure Resource Group. A logical grouping of resources within Azure, which can be used to manage and control access to Azure OpenAI resources. Azure OpenAI Service. A deployment of Azure OpenAI service within the Azure subscription, which provides access to the underlying AI models. Deployment. A specific instance of an Azure OpenAI service deployment, which allows for configuration and control of the service, such as setting quotas and access levels. API key. A secret key obtained from the Azure OpenAI service deployment, which is required for authenticating requests to the API. Fine-tune parameters. Temperature. A parameter that controls the randomness of the generated text. Higher temperatures lead to more creative and unpredictable outputs, while lower temperatures produce more deterministic and consistent results. Max tokens. The maximum number of tokens that the AI model can generate in a single output. Tokens are units of text, with each word typically being assigned one or more tokens depending on its length and complexity. Top P. A parameter that limits the probability distribution of potential outputs, focusing the model on generating more likely and relevant text. Challenges and fixes. API key not found. An error encountered when the provided API key is invalid or not found. Check API key. Verify the API key, ensuring that it is correct and has not expired, and that it has been properly configured in the Azure OpenAI service deployment. Model not found. An error encountered when the specified model is not available or has not been deployed in the Azure OpenAI service. Check model availability. Verify that the desired model is deployed within the Azure OpenAI service, and that the deployment is active and accessible. Testing Azure OpenAI models. Inputs. Text that is provided as input to the model. This input can be anything from a simple sentence to a longer piece of text. For example, if the model is designed to summarize text, the input could be a news article. The expected output of the model based on the given input. This is used as a benchmark to evaluate the model's performance. For example, if the input is a news article, the expected output might be a concise summary of the article's key points. Outputs. The output generated by the Azure OpenAI model based on the provided input text. This could be a summary, translation, or any other type of output that the model is designed to generate. A comparison between the expected output and the actual output generated by the model. This helps in evaluating the model's accuracy and identifying potential areas for improvement. Steps. Preparing the input text by cleaning it, formatting it, and ensuring it is compatible with the model's requirements. This might involve removing irrelevant information, converting the text to a specific format, or tokenizing the text into individual words. Running the Azure OpenAI model with the prepared input text. This involves sending the input to the model and receiving the generated output. Comparing the generated output with the expected output to evaluate the model's performance. This involves identifying discrepancies between the two outputs and analyzing the reasons behind them. Prerequisites. An Azure OpenAI service account is necessary for accessing and using the OpenAI models. This account provides authentication and authorization for accessing the models and their associated resources. A subscription key is a unique identifier for your Azure OpenAI service account, which is used for authentication when accessing the API. You can obtain the subscription key from the Azure OpenAI service portal. Access to the desired Azure OpenAI model is required to run the experiments. You can choose from a variety of models, each with different capabilities and strengths, based on your specific needs. The model name is a unique identifier for the specific Azure OpenAI model you want to use. This name allows you to select and access the specific model you need for your experiments. Fine-tune parameters. The learning rate is a hyperparameter that controls how much the model's weights are updated during training. A higher learning rate leads to faster updates but can also lead to instability, while a lower learning rate leads to slower updates but can improve stability. Batch size refers to the number of data points used in each iteration of the model's training process. A larger batch size can help to improve the model's performance by providing more data for each update, but it can also increase the computational cost. Challenges and fixes. The model might generate inaccurate outputs due to various factors, such as poor training data or incorrect hyperparameter settings. This can lead to inconsistencies or errors in the generated output, making it unreliable. Adjusting the learning rate can help to optimize the model's training process and improve its accuracy. By fine-tuning the learning rate, you can control how much the model's weights are updated during each iteration, leading to better convergence and potentially reducing errors. Increasing the batch size can provide the model with more data for each update, potentially leading to better performance and reducing errors. This is especially helpful when dealing with large datasets or complex models. Fine-tuning the model with more relevant training data can significantly improve its accuracy. By providing the model with a larger and more diverse dataset that aligns with the specific task you are trying to solve, you can help the model learn better and generate more accurate outputs. The model might struggle to generalize to unseen inputs, meaning it might not perform well on data that it hasn't encountered during training. This can be a problem when trying to apply the model to real-world scenarios where the data might be different from the training data. Increasing the training data diversity can help the model generalize better to unseen inputs. By exposing the model to a wider range of data, it can learn to identify patterns and features that are common across different types of data. Fine-tuning the model with more diverse data can also help it generalize better to unseen inputs. By providing the model with a wider range of training data, it can learn to identify patterns and features that are common across different types of data, making it more robust to variations in the input. Using a larger model can also improve the model's ability to generalize to unseen inputs. This is because larger models have more parameters and can learn more complex relationships within the data. The model might take too long to generate outputs, which can be a problem when working with time-sensitive applications. This could be due to a complex model architecture, inefficient processing, or insufficient resources. Optimizing the model architecture can help to reduce the time it takes to generate outputs. This involves selecting the right model architecture and hyperparameters to efficiently process input data and generate outputs. Using a smaller model can also reduce the time it takes to generate outputs. This is because smaller models have fewer parameters and require less processing power to operate. Using a GPU for inference can significantly speed up the model's output generation process. This is because GPUs are specifically designed for parallel processing and can efficiently handle the complex computations involved in running a language model. Azure OpenAI Model Testing. Description of inputs required for Azure OpenAI Model Testing. Name of the Azure OpenAI deployment where the model is deployed. This is the specific instance of the model that will be tested. Dataset used for evaluating the model. This data should be representative of the real-world scenarios the model will encounter. Description of outputs generated by Azure OpenAI Model Testing. Metrics measuring the model's performance on the test data. These metrics could include accuracy, precision, recall, F1 score, and more, depending on the model type and task. Logs recording any errors or exceptions encountered during the testing process. This helps identify potential issues and debug the model or the testing process. Description of steps involved in Azure OpenAI Model Testing. Setting up the necessary environment for running the tests. This may include installing required libraries, configuring the testing framework, and preparing the test data. Loading the test data into the testing environment and preparing it for use in the model evaluation. This may involve formatting the data correctly and splitting it into appropriate sets for training and testing. Running the model on the test data to generate predictions. This involves feeding the test data into the model and obtaining the model's output. Comparing the model's predictions with the actual values in the test data to determine how well the model performs. This involves calculating various performance metrics based on the model's predictions. Examining any errors or discrepancies between the model's predictions and the actual values to identify potential problems with the model. This may involve analyzing the types of errors made by the model and investigating their causes. Description of prerequisites for Azure OpenAI Model Testing. An active Azure subscription is needed to access and utilize the Azure OpenAI services. An Azure subscription provides the necessary infrastructure and resources to deploy, manage, and use Azure OpenAI services. An existing Azure OpenAI service is required to deploy and test the Azure OpenAI model. This service provides the necessary resources and APIs to interact with the model. This includes a pre-configured environment for running the model, along with access to the necessary computational power and storage for the model and its data. a unique key that allows authentication and access to the specific Azure OpenAI service. This key is used to securely authorize access to the model and its capabilities. Description of fine-tuned parameters for Azure OpenAI model testing. The rate at which the model adjusts its internal parameters during training. A higher learning rate may result in faster training but could lead to instability. A lower learning rate may be more stable but could take longer to train. The number of times the model processes the entire training dataset during training. More epochs generally lead to better model performance but could also lead to overfitting. Description of challenges and fixes for Azure OpenAI model testing. When the training data is skewed towards certain classes, the model may be biased towards those classes and perform poorly on less represented classes. This technique involves replicating instances of underrepresented classes to balance the data. However, oversampling can lead to overfitting if not done carefully. This technique involves removing instances of overrepresented classes to balance the data. However, undersampling can lead to loss of valuable data and may not effectively address data imbalance in all cases. When the model learns the training data too well, it may perform poorly on new, unseen data. Techniques that penalize large model weights to prevent the model from relying too much on specific features. This helps to generalize the model to new data. A technique that stops training the model before it overfits to the training data. This is done by monitoring the model's performance on a validation set and stopping training when the performance on the validation set starts to decline. The time it takes for the model to produce predictions after receiving an input. High inference latency can be problematic for real-time applications. Streamlining the model's architecture to reduce computational complexity and improve efficiency. This could involve using fewer layers or reducing the number of parameters in each layer. Leveraging specialized hardware like graphics processing units (GPUs) for inference. GPUs are designed for parallel processing and can significantly speed up inference by processing multiple operations simultaneously. Azure OpenAI Top P values. Top P sampling is a technique used to control the diversity of text generated by a language model. It is a method for selecting tokens during text generation, aiming to balance the trade-off between predictability and creativity. In essence, it prioritizes tokens with higher probabilities while limiting the influence of extremely unlikely tokens. This results in more coherent and engaging text, avoiding nonsensical outputs or excessive repetition. Inputs. Text prompt: the input text that provides context and direction for the language model to generate text. Top P value: a floating point number between 0 and 1 that determines the probability threshold for token selection. It specifies the cumulative probability of the tokens that are eligible for sampling. Outputs. Generated text: the output text generated by the language model using Top P sampling. It reflects the influence of the Top P value on the selection of tokens during the generation process. Steps. Calculate the probability of each possible token. The language model assigns a probability to each token based on its likelihood of appearing in the context of the given prompt. Sort the tokens by probability in descending order. The tokens are ranked from the most probable to the least probable based on their assigned probabilities. Calculate the cumulative probability of the tokens. The cumulative probability of each token is determined by summing the probabilities of all the tokens preceding it in the sorted list. Select the tokens whose cumulative probability is less than or equal to the Top P value. This step involves identifying tokens whose cumulative probability falls within the threshold defined by a Top P value. The goal is to retain a subset of tokens with relatively high probabilities. Sample a token from the selected tokens. A token is randomly chosen from the selected tokens. Based on their probabilities, this sampled token becomes the next element in the generated text sequence. Prerequisites. Language model: a statistical model capable of understanding and generating human-like text. Example: GPT-3, a large language model developed by OpenAI. Renowned for its ability to produce coherent and contextually relevant text. It is trained on a vast dataset of text and code, enabling it to understand complex language patterns and generate creative outputs. Text prompt: and input text that provides context and direction for the language model to generate. Text. Fine-tune parameters. Top p-value: a floating point number between 0 and 1 that determines the probability threshold for token selection. It specifies the cumulative probability of the tokens that are eligible for sampling. Challenges and fixes. High top p-value may result in repetitive or nonsensical text. A high top p-value may lead to selection of less probable tokens, resulting in text that lacks coherence or logical flow. Lower the top p-value. Decreasing the top p-value reduces the probability threshold for token selection. Focusing on more probable tokens and promoting a smoother and more predictable text generation. Low top p-value may result in limited diversity of text. A low top p-value may result in text that lacks creativity and variety. This is because the model is restricted to a narrower range of possible tokens. Increase the top p-value. Increasing the top p-value expands the pool of eligible tokens, enabling the model to explore a wider range of possibilities and generate more diverse and creative text. Azure OpenAI Max tokens. Inputs. Model type: this defines the type of the OpenAI model to be utilized, such as GPT 3.5 or GPT-4. For text generation. Context length: this represents the length of the input context provided to the OpenAI model, which can be measured in words, characters, or tokens, depending on the specific model and its requirements. Outputs. Generated text: this represents the output generated by the OpenAI model based on the provided input and model settings. The output can be a text response, a summary, a translation, or other forms of text depending on the model's capabilities. Steps. Tokenize input: this step involves breaking down the input text into smaller units called tokens, which are the fundamental building blocks for the OpenAI model to process and understand the input. Encode tokens: once the input text is tokenized, these tokens are encoded into numerical representations that the model can process and understand. This step is essential for the model to convert the textual input into a format suitable for its internal computations. Decode tokens: after the model has processed the encoded tokens, the output needs to be converted back into human-readable text. This step involves decoding the numerical representations of the tokens back into their original textual form, resulting in the generated text output. Prerequisites. Azure OpenAI Service: this represents the Azure OpenAI Service, which provides access to the OpenAI models for developers to use in their applications. Utilizing this service requires specific credentials and configuration. Subscription key: this is a unique key that identifies the subscription to the Azure OpenAI service, providing access to the available OpenAI models. Endpoint: this specifies the URL of the Azure OpenAI service endpoint, which serves as the gateway for accessing and utilizing the OpenAI models within the Azure environment. Model: this specifies the specific OpenAI model to be used for the text generation process. There are various models available, each with its strengths and limitations. GPT 3.5. This is a popular OpenAI model known for its versatile text generation capabilities, including creating stories, translating languages, and answering questions in a comprehensive manner. Fine-tune parameters. Max tokens. This parameter controls the maximum number of tokens that the OpenAI model can generate in a single response. Setting an appropriate limit helps manage the length of the generated text and avoid unnecessary resource consumption. Temperature. This parameter influences the creativity and randomness of the generated text. A higher temperature setting leads to more diverse and unpredictable outputs, while a lower temperature setting produces more coherent and predictable outputs. Challenges and fixes. Token limit exceeded. This issue occurs when the generated text exceeds the specified max tokens limit. Truncate input. To address this challenge, the input context can be truncated to reduce the number of tokens being processed, ensuring the generated text stays within the specified limit. Model performance issues. This refers to instances where the model's output quality is not satisfactory or encounters difficulties in processing the input. Reduce context length. Reducing the length of the input context can help improve model performance by simplifying the processing burden on the model. Optimize prompt. Refining the input prompt can significantly impact the model's performance by providing clear and concise instructions and context within the prompt. The model can better understand the intended task and generate more relevant and accurate outputs. Steps. Determine top K value. The process of selecting an appropriate top K value for the specific task or application. This involves considering factors like the desired level of creativity, diversity, and control over the generated output. For example, a higher top K value might be suitable for creative writing tasks, while a lower top K value might be preferred for more technical or factual outputs. Execute model with top K. The execution of the Azure OpenAI model with the determined top K value, prompt, and other relevant parameters. This step involves providing the model with the input, allowing it to generate text based on the configured settings. Prerequisites. Azure OpenAI Service. The Azure OpenAI Service provides access to a suite of powerful language models and tools for developers to build AI-powered applications. This service requires an Azure subscription and a dedicated resource group to manage access and resources. Azure subscription. An Azure subscription is required to access and manage Azure resources, including the Azure OpenAI Service. This subscription provides billing and account management for the resources used within the Azure environment. Azure Resource Group. An Azure Resource Group is a logical container that holds related Azure resources. It enables efficient management and organization of resources, including the Azure OpenAI Service, within a single unit. Python library. A Python library provides a convenient and efficient way to interact with the Azure OpenAI Service and perform tasks like model selection, parameter configuration, and text generation. Azure OpenAI Library. The Azure OpenAI Library is a specific Python library specifically designed for working with the Azure OpenAI Service. It provides an API for interacting with the service, allowing developers to programmatically manage models, tasks, and outputs. Fine-tune parameters. Top K. The top K parameter is a crucial aspect of fine-tuning the behavior of an Azure OpenAI model. By adjusting the top K value, you can directly control the model's creativity, diversity, and overall output quality. Challenges and fixes. High top K value. A high top K value can lead to increased computational cost and potential for irrelevant or Nonsensical outputs. It might be necessary to reduce the top K value to improve efficiency and ensure more coherent results. Reduce top K value. To address the issue of high top K values, it is recommended to decrease the value to a more appropriate level. This reduction can lead to faster processing, improved output quality, and more controlled results. For example, if you are generating creative text outputs, reducing the top K value from 100 to 50 might result in more relevant and coherent outputs without sacrificing too much creativity. Low top K value. A low top K value can limit the model's creativity and diversity, resulting in predictable and potentially less interesting outputs. Increasing the top K value might be necessary to encourage the model to explore a wider range of possibilities. Increase top K value. If the model's outputs are too predictable or lacking in diversity, consider increasing the top K value. This will allow the model to consider a broader range of tokens, potentially leading to more creative and engaging outputs. For example, if you are generating summaries of factual articles, increasing the top K value from 10 to 20 might help the model to include more diverse and nuanced details. Azure Open AI Stop Sequences. Stop sequences are special tokens that instruct the model to stop generating text. They act as signals to the model, indicating that the text generation should be terminated at that point. Inputs. A prompt or context that provides the model with the initial information or instructions to base the generated text on. A list of stop sequences, which are the specific tokens that signal the model to stop generating text when encountered. Outputs. Text generated by the model based on the given prompt and using the provided stop sequences. This text is generated according to the model's training and the input prompt, stopping at any encountered stop sequence. Steps. The model first processes the input prompt, understanding the context and the desired style or information to be generated. The model then starts generating text, sequentially producing tokens based on its learned patterns and the input prompt. During the generation process, the model checks each generated token against the list of provided stop sequences. If any of the defined stop sequences are found in the generated text, the model immediately stops generating further text, preventing the generation from going beyond the intended point. Prerequisites. An Azure OpenAI service with a deployed model, which refers to a service with a trained and accessible AI model. It's crucial to ensure that the specific model deployed supports stop sequences as a feature. A list of stop sequences to use, which are the specific tokens that signal the end of text generation. These sequences should be carefully defined based on the context of the text generation to ensure accurate termination at the desired points. Fine-tune parameters. The stop sequences parameter is used to specify the list of stop sequences that will signal the model to stop generating text. This parameter allows users to customize the termination points of text generation. The max tokens parameter is used to limit the number of tokens that the model can generate. This parameter is useful to control the length of the generated text and prevent excessive or unwanted text generation. Challenges and fixes. Unexpected behavior when using stop sequences can occur due to various reasons. It's essential to ensure that the stop sequences are unique and not present in the input prompt. Model generating text beyond the desired stop sequence might occur if the max tokens parameter is not adequately set or if the stop sequences are not specific enough. Using the max tokens parameter to limit the generated text length helps prevent this issue. Azure OpenAI presents penalty value. The presence penalty is a technique used to adjust the likelihood of a text generation model producing a token that has already appeared in the generated text. This penalty can be used to encourage the model to generate more diverse and creative text outputs, or to prevent the model from repeating the same phrases or words excessively. Inputs. The input text is a string that serves as the prompt or context for the text generation model. The model utilizes this text to generate a coherent response. The presence penalty value is a numerical parameter ranging from 2.0 to 2.0. This value determines the magnitude of the penalty applied to tokens that have already appeared in the generated text. Outputs. The output text is a string representing the text generated by the model in response to the input prompt and the applied presence penalty. The presence penalty value, as specified in the input, is applied to the output text, influencing the probability of specific tokens being generated. Steps. The model first generates a probability distribution for the next token to be generated based on the input text and its internal knowledge. This distribution reflects the likelihood of each possible token being generated. The presence penalty value is then applied to this probability distribution. If the presence penalty value is positive, it reduces the probability of generating tokens that have already appeared in the output text, encouraging the model to generate more diverse text. If the presence penalty value is negative, it increases the probability of generating tokens that have already appeared in the output text, potentially leading to more repetitive text. The model finally samples a token from the modified probability distribution. The token with the highest probability is chosen, resulting in the next token in the generated text. Prerequisites. The model must be trained on a dataset of text to acquire the knowledge necessary to generate text. This dataset should contain diverse examples of the type of text you wish the model to generate. The model must be configured to use presence penalty. This means enabling the presence penalty feature in the model's settings, allowing it to adjust the probability distribution based on the presence penalty value. Fine-tune parameters. Presence penalty is the parameter that is used to control the degree to which the model is penalized for generating tokens that have already appeared in the text. Challenges and fixes. The model may generate repetitive text, which can be undesirable in some contexts. Reducing the presence penalty value can encourage the model to generate more diverse and creative text, preventing the repetition of phrases or words. For instance, in a chat application, reducing the presence penalty value might help avoid repetitive responses from the chatbot, leading to more engaging interactions. The model may generate text that is not relevant to the input text, which can be confusing or frustrating for users. Increasing the presence penalty value can help to guide the model towards generating text that is more relevant to the input text. For example, in a text summarization task, increasing the presence penalty value might help the model to focus on generating text that is a concise summary of the input text, avoiding irrelevant details or tangents. Azure OpenAI Content Delivery Network. This describes the integration of Azure OpenAI service with Content Delivery Network's CDNs to enhance the speed and responsiveness of AI-powered applications. By leveraging CDNs, the latency for model inference can be significantly reduced, leading to a smoother and faster user experience. Inputs. This refers to the Azure OpenAI service deployment that will be integrated with the CDN. This deployment consists of the chosen AI model, configuration settings, and access credentials. This indicates the CDN provider that will be utilized to deliver the Azure OpenAI services responses. Common options include Azure CDN, Cloudflare, and others, each offering unique features and performance characteristics. Outputs. This highlights the key benefit of using CDNs with Azure OpenAI services, which is a reduction in latency for model inference. Latency refers to the time it takes for an AI model to process a request and return a response. By caching model responses closer to the end users, CDNs minimize the distance data needs to travel, resulting in faster response times. This refers to the enhanced scalability and availability that CDNs provide for Azure OpenAI service. Deployments. By distributing the workload across multiple CDN servers, CDNs ensure that applications can handle a large volume of requests and remain available even in case of server failures. Steps. This involves configuring the Azure OpenAI service to work effectively with the chosen CDN. This typically entails setting up endpoints and authentication mechanisms to enable secure communication between the Azure OpenAI service and the CDN. This step involves configuring the CDN provider to accommodate the Azure OpenAI service endpoints. This includes specifying the origin server's Azure OpenAI service endpoints, defining caching policies, and setting up security measures to protect the service's responses. This involves incorporating the CDN endpoints into the application code, enabling it to communicate with the CDN instead of directly accessing the Azure OpenAI service. This ensures that all requests are routed through the CDN for efficient delivery. Prerequisites. This indicates the requirement of a deployed Azure OpenAI service as a foundation for integration with the CDN. This deployment includes an Azure OpenAI service resource, which is the actual instance of the chosen AI model within the Azure platform. This refers to the need for a CDN account, which is provided by the chosen CDN provider. This account is where the CDN configuration, settings, and management are performed. It is essential for setting up the CDN infrastructure to handle Azure OpenAI service responses. Fine-tune parameters. These settings control how the CDN caches responses from the Azure OpenAI service. This includes parameters such as the cache duration time to live, TTL, cache invalidation policies, and cache control headers. Optimal caching settings are crucial for balancing responsiveness and data freshness. These settings are essential for securing the CDN against potential threats. They include measures like access control lists (ACLs), encryption, and security protocols (HTTPS) to protect sensitive information and ensure the integrity of Azure OpenAI service responses delivered through the CDN. Challenges and fixes. This challenge arises when the CDN's cached responses become outdated, potentially providing users with inaccurate or stale information. Solutions involve implementing a proper cache invalidation mechanism that ensures timely updates of cached content whenever the underlying Azure OpenAI service data changes. This might involve using techniques like cache tags, purge APIs, or time-based invalidation. This challenge focuses on vulnerabilities that might exist within the CDN infrastructure, potentially allowing attackers to compromise the security of the Azure OpenAI service responses being delivered. Mitigation strategies include adopting strong CDN security measures like encryption, authentication, and regular security audits to identify and address potential weaknesses. It is also essential to stay updated on the latest security best practices and vulnerabilities to ensure robust protection. Azure OpenAI GPUs. Azure OpenAI Service, a cloud-based service that offers access to powerful large language models (LLMs), Equipped with GPU acceleration for enhanced performance in processing and generating text. Inputs. Text prompts user-provided input in the form of text, serving as the starting point for the LLM to generate responses or complete tasks. Model configurations parameters that define the specific LLM to be used, including its size, type, and any customization settings. Outputs. Generated text. The output produced by the LLM, which can be a continuation of the text prompt, a summary, a translation, or any other form of text generation based on the model's capabilities. Model outputs. Additional outputs generated by the LLM beyond the primary text output, such as probabilities for each generated word, confidence scores, or other model-specific information. Steps. Select appropriate GPU-enabled Azure OpenAI service. Choose the service that offers the most suitable GPU resources and model configuration for the specific task at hand. Considering factors like model size and expected performance requirements, deploy model with GPU resources. Utilize the selected GPU-enabled Azure OpenAI service to deploy a chosen LLM, allocating appropriate GPU resources to ensure efficient model execution and faster processing times. Submit text prompt with parameters. Provide the LLM with the text prompt and any necessary parameters to guide the model's generation process, specifying context, desired output format, and other relevant information. Receive generated text or model outputs. Retrieve the output generated by the LLM, which will include the generated text and potentially other model outputs depending on the chosen configuration and the model's capabilities. Prerequisites. Azure subscription and active account with Azure, granting access to the Azure OpenAI service and other cloud resources. Azure OpenAI service and Azure Cloud Service that provides access to a variety of LLMs, including GPT-3, Codex, and others. GPU-enabled Azure OpenAI service. A specific Azure OpenAI service that leverages GPU resources for accelerated processing, enabling faster execution of LLMs and enhancing their capabilities for complex tasks. Suitable model in LLM that aligns with the specific requirements of the task, considering factors like its size, training data, and specialized capabilities. For example, if the task involves translating languages, a model trained on multilingual datasets would be more suitable than one trained on only English text. Fine-tune parameters. Learning rate. A key parameter in the fine-tuning process, determining the step size for adjusting model weights during training. A higher learning rate can lead to faster convergence but might also result in overshooting a optimal parameter values. Batch size. The number of training examples processed at a time during model fine-tuning. Larger batch sizes can help accelerate training but might require more memory resources. Challenges and fixes. GPU resource allocation issues. Insufficient or incorrectly allocated GPU resources can impact model performance, leading to slower execution times or even model crashes. Check GPU availability and capacity. Verify that the selected Azure OpenAI service has sufficient available GPU resources to accommodate the chosen model and workload. Optimize model configuration for GPU resources. Fine-tune the model configuration parameters, such as batch size and model size, to effectively utilize the available GPU resources and prevent resource contention. Performance bottlenecks. Performance bottlenecks can arise due to inefficient code, inadequate GPU utilization, or limitations in the model's architecture. Profile model execution and identify bottlenecks. Analyze the model's execution profile to pinpoint the specific areas where performance is being hindered, helping identify potential bottlenecks. Adjust GPU settings for optimized performance. Tune GPU-related settings, such as memory allocation and kernel optimization, to improve the model's execution speed and overall performance. Consider using specialized GPU libraries. Explore specialized GPU libraries, such as CUDNN or QBLAS, to leverage optimized functions and libraries for specific tasks, potentially improving performance. Model training time. Training large language models can be time-consuming, especially when dealing with extensive datasets and complex models. Use larger batch sizes. Increasing the batch size can accelerate the training process by processing more data points in parallel, but requires careful consideration of memory limitations. Experiment with different learning rates. Adjust the learning rate to optimize the training process, finding the balance between faster convergence and overshooting the optimal parameters. Explore techniques for reducing training time. Investigate techniques like early stopping, gradient accumulation, and model compression to reduce training time without sacrificing model accuracy. Model deployment time. Deploying a trained model, especially large ones, can take time depending on the size and complexity of the model and the available resources. Optimize model size and architecture. Minimize the model's size and complexity by exploring model compression techniques or using smaller models that still meet the task's requirements. Leverage GPU acceleration for deployment. Utilize GPU-enabled Azure OpenAI service for deployment to accelerate the model loading and inference process, enabling faster responses and improved user experience. Explore cloud-based deployment options. Consider cloud-based deployment options that offer pre-configured infrastructure and managed services, simplifying the deployment process and potentially reducing deployment time. Azure OpenAI Azure Key Vault Secrets. Inputs. Azure OpenAI resource. This refers to the Azure OpenAI service resource created within your Azure subscription. It's the primary resource that enables you to use Azure OpenAI services like GPT-3 and Codex. You can create and manage Azure OpenAI resources through the Azure portal or Azure Key. Azure Key Vault name. This is the name of your Azure Key Vault instance. Azure Key Vault is a service that allows you to store, manage, and control access to sensitive information like API keys, passwords, and certificates. Azure Key Vault secret name. This represents the name you give to the secret stored within your Azure Key Vault. For example, you might store your Azure OpenAI API key as a secret named OpenAI API key. Outputs. Azure Key Vault secret value. This is the actual value of the secret retrieved from your Azure Key Vault. It could be an API key, a password, or any other sensitive information that you store in your Key Vault. Steps. Create Azure OpenAI resource. This step involves creating a new Azure OpenAI resource within your Azure subscription. You'll need to provide details like the resource name, location, and pricing tier for the OpenAI resource. Create Azure Key Vault. In this step, you create a new Azure Key Vault resource within your Azure subscription. This provides a secure environment to store your secrets. Create Azure Key Vault secret. This step involves creating a new secret within your Key Vault, storing the Azure OpenAI API key or other sensitive information within it. You'll specify the name of the secret and the actual value you want to store. Retrieve Azure Key Vault secret. This step retrieves the secret like the Azure OpenAI API key from your Azure Key Vault. You'll need to provide the name of the Key Vault and the name of the secret you want to retrieve. Use secret in Azure OpenAI. This step involves using the retrieved secret Azure OpenAI API key to interact with your Azure OpenAI service. This could be sending prompts, generating text, or using other OpenAI features. Prerequisites. Azure subscription. This represents your existing Azure subscription where you'll create the necessary resources for Azure OpenAI and Key Vault. Azure Subscription ID. Your Azure Subscription ID is a unique identifier for your Azure account. You can find your subscription ID in the Azure portal. Azure Resource Group. An Azure Resource Group is a logical container that helps you organize related resources in your Azure subscription. This enables you to manage, deploy, and monitor them as a group. Resource Group. Name. The name you provide for your Azure Resource Group. For example, My OpenAI Source Group. Fine-tune parameters. Azure OpenAI model. This refers to the specific Azure OpenAI model you'll be using, such as Text DaVinci 003 or Code DaVinci 002. Azure OpenAI deployment. This represents the Azure OpenAI deployment that you've created based on the selected model. Deployments allow you to configure and manage the specific model instances within your Azure OpenAI resource. Challenges and fixes. Key Vault access denied. This occurs when the Azure OpenAI service doesn't have the necessary permissions to access the secrets in your Key Vault. Grant Azure OpenAI access to Key Vault. You need to grant the Azure OpenAI service its managed identity access to the Key Vault by assigning the appropriate roles. This could be a reader role for accessing the secret or a contributor role for more comprehensive access. Secret not found. This error happens when the Key Vault doesn't contain the secret with the name you specified. Create Key Vault secret. You need to create the secret within your Key Vault, making sure to use the correct name and value. Invalid secret type. This occurs if the secret's format doesn't match what's expected by the Azure OpenAI service. Use supported secret type. Ensure the secret is stored as a supported type, such as a string or a byte array, to be used effectively with the Azure OpenAI service. Secret retrieval error. This can occur due to network connectivity issues, permission problems, or other issues preventing access to the Key Vault. Check Key Vault connectivity. Verify that your Azure OpenAI service can communicate with your Key Vault. Ensure there are no network firewalls or other security restrictions blocking communication. Verify secret permissions. Confirm that the Azure OpenAI service has the necessary permissions to access the secret. You might need to adjust roles or permissions assigned to the Azure OpenAI service within the Key Vault. Retry secret retrieval. If the error persists, you can try retrieving the secret again, as temporary issues might have been resolved. If the error persists, consider checking logs and monitoring for any deeper problems. Azure OpenAI API key header. Inputs. This input represents the API key required to authenticate with the Azure OpenAI service. It is a unique string that identifies your account and grants you access to the API capabilities. For example, you can obtain an API key from the Azure OpenAI Studio by creating an Azure OpenAI resource and then generating an API key. This input specifies the endpoint URL of the Azure OpenAI service you are connecting to. The endpoint is a unique address that directs your requests to the correct Azure OpenAI service instance. For example, the endpoint might look something like this: https://api.openai.azure.com. Outputs. This output represents the successful authentication and access to the Azure OpenAI service. Once the API key header is correctly set with the valid API key and endpoint, you will be granted access to all the features and capabilities offered by the Azure OpenAI service. Steps. This step involves setting the API key as a header in your request to the Azure OpenAI service. The API key header is typically added to the authorization field of your HTTP request. This ensures that your request is authenticated with your Azure OpenAI account. This step appends the endpoint to the API key header. The endpoint is used to direct your request to the correct Azure OpenAI service instance. By adding the endpoint to the header, you ensure that your request reaches the intended Azure OpenAI service. Prerequisites. This prerequisite refers to the creation of an Azure OpenAI service account. To use the Azure OpenAI API, you need to have an Azure subscription and create an Azure OpenAI resource within your subscription. This resource represents your dedicated instance of the Azure OpenAI service and is associated with your Azure OpenAI service account. This step involves creating an Azure OpenAI resource within your Azure subscription. This resource provides you with access to the Azure OpenAI service and allows you to use its capabilities. You can create an Azure OpenAI resource through the Azure portal or using Azure CLI commands. This prerequisite highlights the necessity of having an API key. An API key is a unique string that identifies your Azure OpenAI service account and grants you access to the API. This step describes the process of generating an API key for your Azure OpenAI service account. You can generate an API key within the Azure OpenAI Studio associated with your Azure OpenAI resource. The API key is essential for authenticating your requests to the Azure OpenAI service. Fine-tune parameters. This parameter specifies the version of the Azure OpenAI API you are using. Different API versions may have different features or capabilities. You should always refer to the Azure OpenAI documentation for the latest API version and its supported features. This parameter represents the name of the Azure OpenAI model you want to use. Azure OpenAI offers various models with different capabilities and specializations. For example, you might choose a model specifically designed for text generation, translation, or code completion. Challenges and fixes. This challenge describes the scenario where the provided API key is incorrect or invalid. An incorrect API key will prevent you from authenticating with the Azure OpenAI service. This fix involves carefully verifying the accuracy of your API key. Ensure that you are using the correct API key associated with your Azure OpenAI service account. You can check the API key in the Azure OpenAI Studio associated with your Azure OpenAI resource. This challenge highlights the possibility of using an incorrect or invalid endpoint. An incorrect endpoint will direct your request to the wrong Azure OpenAI service instance. This fix involves checking the correctness of the endpoint you are using. Make sure that the endpoint URL matches the address of the Azure OpenAI service instance you are trying to access. You can confirm the correct endpoint by referring to the Azure OpenAI documentation or by checking the Azure OpenAI Studio associated with your Azure OpenAI resource. Azure OpenAI API base value. Inputs. Deployment name. This is the name assigned to your deployed Azure OpenAI model within your Azure resource. It allows you to reference and manage your specific model instances. For example, you might name a deployment GPT-35 Turbo for text generation to distinguish it from other models. API key. Your unique secret key used to authenticate with the Azure OpenAI service. You obtain this key from your Azure OpenAI resource. Treat it like a password and keep it confidential. You'll need this key to make requests to the API endpoint, the unique URL of your Azure OpenAI service. It acts as the gateway to your Azure OpenAI resource. You'll use this URL to connect to your deployed model and send requests. You can find it within the Azure OpenAI resource settings. Think of it like the address of your Azure OpenAI service. Model name. The specific identifier of the Azure OpenAI model you want to use. It's typically a pre-trained model from OpenAI like Text DaVinci 003 or Coda DaVinci 002 or a custom model you fine-tuned. It determines the model's capabilities and the type of tasks it's suited for. For example, GPT-35 Turbo is a versatile language model while Coda DaVinci 002 is optimized for code generation. Prompt the text input you provide to the Azure OpenAI model, guiding it to generate a response. It can be a question, a creative writing instruction, a code snippet, or any other textual input. The quality and clarity of your prompt significantly impact the quality of the response. For example, if you want the model to summarize a news article, you would provide the article as the prompt. Temperature, a parameter that controls the creativity and randomness of the model's response. A lower temperature closer to 0 produces more deterministic and predictable responses, while a higher temperature closer to 1 generates more creative and unexpected outputs. Think of it like setting the temperature of a creative engine. The higher the temperature, the more diverse and unpredictable the output. Max tokens, the maximum number of tokens units of text the model can generate in its response. This is used to control the length of the response and prevent excessively long outputs. It helps manage the computational resources used and ensures you get a response of the desired length. Top P, a parameter that controls the diversity of the model's response. A lower value closer to 0 focuses the model on generating the most likely words, while a higher value closer to 1 increases the diversity by considering a wider range of words. It balances predictability with creativity in the output. Frequency penalty, a parameter that discourages the model from repeating the same words or phrases too often. A higher penalty closer to 1 makes the model less likely to repeat words, while a lower penalty closer to 0 allows more repetition. It helps avoid repetitive and less interesting outputs. Presence penalty, a parameter that discourages the model from using words or phrases that have already appeared in the prompt. It encourages the model to generate new and unique content. A higher penalty closer to 1 makes the model less likely to repeat phrases from the prompt, while a lower penalty closer to 0 allows more repetition. It promotes freshness and originality in the responses. Outputs. Response text. This is the generated text output produced by the Azure OpenAI model in response to your prompt and parameters. It can be a poem, a summary, a code snippet, or any other text content. The quality and usefulness of the response are directly related to your prompt, the chosen model, and the parameter settings. For example, the model might generate a creative story based on your prompt or provide a code solution for a programming problem. Steps. Create an Azure OpenAI resource. You must first create an Azure OpenAI resource within your Azure subscription. This involves navigating to the Azure portal, selecting the Create a Resource option, and choosing Azure OpenAI. Then, you need to provide the necessary details for your resource, such as its name, region, and pricing tier. This creates a dedicated environment for hosting and managing your Azure OpenAI services. Deploy a model. Once your Azure OpenAI resource is created, you can deploy a specific Azure OpenAI model. This involves selecting the desired model from the available options like Text DaVinci 003 or Coda DaVinci 002, specifying the deployment name, and choosing the compute resources. This process makes your chosen model available within your Azure OpenAI resource for use. Get API key and endpoint. After deploying a model, you need to obtain the API key and endpoint for your Azure OpenAI resource. These credentials are essential for authenticating your requests to the API and accessing a deployed model. You can find these within the resource settings in the Azure portal. Think of them as the password and address needed to communicate with your Azure OpenAI service. Send a request to the API. You can now interact with your deployed Azure OpenAI model by sending requests to the API using the obtained endpoint and API key. You'll need to formulate your request in the correct format, including your prompt, model name, and other relevant parameters. This process allows you to utilize the model's capabilities to generate responses and perform tasks. Prerequisites: Azure subscription. You need a valid Azure subscription to use Azure OpenAI. This subscription provides access to Azure resources, including the ability to create and manage Azure OpenAI resources. Think of it as your account for accessing and utilizing Azure services. Azure OpenAI resource. You must have created an Azure OpenAI resource within your Azure subscription. This resource acts as a dedicated environment for hosting and managing your Azure OpenAI models. It is essential for using the API and deploying models. Fine-tune parameters. Model type. This parameter specifies the type of model you want to fine-tune. You can choose from various pre-trained models, such as text or code generation models. It determines the base capabilities of the model and the types of tasks it's suitable for. Training data. The dataset you provide to train your model. It should be relevant to the tasks you want your fine-tuned model to perform. It acts as the learning material for your model, enabling it to adapt to your specific needs. This data needs to be in a format that Azure OpenAI understands. Learning rate. This parameter controls how quickly the model learns from the training data. A higher learning rate leads to faster learning but may result in overfitting, while a lower learning rate can be slower but may result in better generalization. It balances the speed of learning with the accuracy of the model's performance. Epochs. The number of times the model iterates through the training data. More epochs generally result in better performance, but also require more time and computational resources. It helps fine-tune the model based on the training data for better performance and accuracy. Challenges and fixes. Insufficient quota. You may encounter a quota limit for the number of requests you can send to Azure OpenAI. This could be due to factors like exceeding the usage limit for your pricing tier. If you encounter this, you need to contact Azure support to request an increase in your quota. Slow response times. If your requests to Azure OpenAI take longer than expected, you may need to optimize your model and prompt for efficiency. This could involve using a smaller model or simplifying your prompt to reduce computational demands. You can also try to avoid using overly complex language or requesting too many tokens in your response. API key issues. If you have trouble authenticating with the Azure OpenAI API, it's possible there are issues with your API key. You may need to regenerate your API key or ensure that it is entered correctly in your requests. Double-check the key you are using and regenerate if necessary. Model not found. If you receive an error stating that the model you specified is not found, you need to ensure that the correct model name is being used. Check the model name you provided against the available models and ensure that there are no typos. Invalid request. If you receive an error stating that your request is invalid, you need to check the request parameters for errors. Ensure that all required parameters are included and that their values are in the correct format. Review the format of your request and adjust as necessary. Rate limiting. If you encounter rate limiting issues, you may need to implement rate limiting strategies in your code. This involves limiting the number of requests you send per unit of time to avoid exceeding the API's limits. Consider incorporating rate limiting mechanisms to avoid hitting the API too quickly. Model deployment issues. If you have problems deploying a model, You need to check the deployment status and retry if needed. Ensure that the deployment is successful and check the logs for any errors. If necessary, retry the deployment process. Azure OpenAI Choose Deployment to extract results. Inputs. The name assigned to the deployment within Azure OpenAI, which is used for referencing and managing the deployed model. For instance, if you deploy a text generation model called Text DaVinci 003 for a specific purpose like summarization, you might name the deployment Summarization DaVinci. This designates the specific Azure OpenAI model to be deployed. It typically includes a model family, generation, and version, like Text DaVinci 003, representing a powerful text generation model from the text family, the DaVinci generation, and version 003. Outputs. This is the unique address or URL that is assigned to the deployed model, making it accessible for sending requests and receiving responses. It serves as the endpoint for interaction with the model. For example, the deployment endpoint could be https://yourdeployment.openai.azure.com. A secret key or token associated with the deployment, granting access to the deployed model. It's used for authentication when making API calls to the deployment endpoint, ensuring only authorized users or applications can interact with the deployed model. Steps. This involves creating an Azure OpenAI resource within your Azure subscription. This resource provides the foundation for deploying and managing Azure OpenAI models. Creating this resource typically requires specifying a resource name and selecting an appropriate pricing tier for your usage. Once the Azure OpenAI resource is created, this step focuses on deploying a chosen Azure OpenAI model to make it operational. This includes selecting a deployment type, e.g., text, code, specifying the model name, and potentially configuring additional settings like memory allocation. Prerequisites. A subscription to Azure, granting access to its various services, including Azure OpenAI. This typically involves creating an Azure account and signing up for a subscription. The ability to access and interact with the Azure portal, which is the web-based interface for managing Azure resources. This allows you to create, monitor, and configure Azure OpenAI resources and deployments. A successfully created Azure OpenAI resource within your Azure subscription, which provides the environment for deploying and managing Azure OpenAI models. This resource serves as a container for your OpenAI deployments. The subscription identifier associated with your Azure account, used for billing and resource management. It is a unique string that identifies your Azure subscription, allowing you to manage resources within that subscription. Fine-tune parameters. This refers to the type of deployment being created, specifically whether it involves a text model, e.g., for language generation, or a code model, e.g., for code generation or analysis. The specific version of the Azure OpenAI model being deployed. This version number indicates the specific implementation and capabilities of the model, with higher versions potentially offering improvements or new features. Challenges and fixes. This indicates a situation where the deployment process fails to successfully start. This fix suggests investigating if the available resources, e.g., compute, memory, are sufficient to support the deployment. This might involve checking resource quotas, scaling up resources, or optimizing the deployment configuration. This refers to an issue where the deployed model's endpoint is not accessible, preventing communication with the model. This suggests verifying the network connectivity between the client trying to access the endpoint and the deployment itself. This may involve checking firewall rules, network configurations, or Ensuring the endpoint URL is correct. Azure OpenAI Model Selection. This document outlines the process of selecting the appropriate Azure OpenAI model for a given task. Inputs. Nature of the task. This refers to the specific task the model will perform, such as text generation, question answering, code completion, summarization, translation, etc. For example, if you need to generate creative content, you would choose a model known for its text generation capabilities. Desired output quality. This specifies the quality of output expected from the model. Aspects such as accuracy, fluency, creativity, and coherence are considered here. For instance, if your task requires accurate and factual responses, you'd prioritize models renowned for their accuracy. Data volume and complexity. This encompasses the amount of training data available and the complexity of the task. Consider the size of your dataset and the complexity of the information it contains. If you have a large dataset with intricate patterns, you may need a powerful model capable of handling the volume and complexity. Computational resources. This refers to the available memory and processing power for model training and inference. Depending on your resources, you may choose a model with different computational requirements. For example, if you have limited resources, you might opt for a smaller, less demanding model. Cost considerations. This involves the pricing of different models. Azure OpenAI models come with different costs based on their size, capabilities, and usage. Consider the budget constraints and choose a model that provides the best value for your needs. Outputs. Selected Azure OpenAI model. This represents the chosen model that best suits the defined task and requirements. For instance, for a task requiring high-quality text generation, a model known for its creativity and fluency might be selected. Model-specific parameters. These are specific parameters used for fine-tuning and optimization of a selected model. This could include settings like learning rate, epochs, and batch size, which are adjusted to improve the model's performance on the given task. Steps. Define the task and desired output quality. Begin by clearly defining the objective of the task and the desired quality of the output. This sets the baseline for model selection. For example, if your task is to generate summaries of news articles, define the expected output quality in terms of conciseness, accuracy, and comprehensiveness. Identify relevant models. Research different Azure OpenAI models and identify those that align with the task's capabilities and use cases. Consider the model's strengths and weaknesses in relation to your requirements. For instance, if the task involves translating text, explore models specifically designed for translation tasks. Consider data volume and computational resources. Evaluate the data volume and complexity, and ensure the selected model can handle it effectively. Similarly, assess the computational resources available for model training and inference. Matching the model's requirements with the available resources is crucial for efficient operation. Compare model pricing. Compare the pricing of the shortlisted models and select the most cost-effective option that meets the performance requirements. Consider factors like the cost per token and the expected usage of the model. Fine-tune the selected model. Fine-tune the selected model using your specific data to optimize its performance for the target task. This involves adjusting model parameters and providing relevant training data. For example, if your task involves generating text in a specific domain, fine-tune the model using domain-specific data to improve its accuracy and fluency in that context. Prerequisites. Azure subscription with access to Azure OpenAI service. This requires an active Azure subscription. with access to the Azure Open AI service. This enables you to utilize the available models and resources. Understanding of the task and desired output quality. A clear understanding of the task and its desired output quality is crucial. This involves a comprehensive analysis of the task's requirements and the expected performance of the chosen model. Fine-tune parameters. Learning rate. This parameter controls the speed at which the model learns during training. A higher learning rate allows the model to learn quickly but can lead to instability, while a lower learning rate ensures stability but might require more time for training. The optimal learning rate depends on the dataset and the model's architecture. Epochs. This refers to the number of times the model trains on the entire dataset. Each epoch involves iterating through the entire dataset and adjusting the model's weights based on the training data. The number of epochs determines the extent to which the model learns from the data. More epochs generally result in better learning, but it can also lead to overfitting, where the model performs well on the training data but poorly on unseen data. Batch size. This represents the number of data samples used in each training iteration. During each iteration, the model processes a batch of data and adjusts its weights accordingly. A larger batch size generally requires more computational resources but can lead to faster training. Conversely, a smaller batch size requires less computational power but may result in slower training. Challenges and fixes. Model selection challenges. Insufficient model performance. Consider using a larger or more specialized model. If the chosen model fails to meet the performance expectations, consider using a larger or more specialized model that aligns better with the task's requirements. For instance, if the model struggles to handle complex language patterns, exploring a model with advanced language understanding capabilities might be beneficial. Fine-tune the model with more data. Fine-tuning the model with a larger or more relevant dataset can significantly improve its performance. This involves providing the model with additional training data that aligns with the task-specific requirements. High latency or cost. Choose a smaller or faster model. If latency or cost becomes a concern, consider using a smaller or faster model that balances performance and efficiency. Explore models that are optimized for speed and resource utilization. Optimize model parameters for performance. Optimize model parameters such as batch size and learning rate to enhance performance and reduce latency. Experiment with different parameter values to find the optimal configuration for your specific task and resources. Lack of specific functionality. Explore different models. If the chosen model lacks specific functionality required for the task, explore different models that offer the desired capabilities. For instance, if the task requires image recognition, investigate models specialized in computer vision tasks. Consider custom model development. If no existing model meets the specific functionality requirements, consider custom model development. This involves training a model from scratch using a tailored dataset and architecture. Fine-tuning challenges. Overfitting. Increase data diversity. Overfitting occurs when the model performs well on the training data but poorly on unseen data. To address this, increase the diversity of the training data to expose the model to a wider range of patterns and reduce its reliance on the specific characteristics of a training set. Use regularization techniques. Employ regularization techniques to prevent overfitting. These techniques add constraints to the model's learning process, preventing it from becoming overly specialized to the training. Data underfitting. Increase model complexity. Underfitting occurs when the model fails to capture the underlying patterns in the data. Increase model complexity by adding more layers or parameters to the model. This allows the model to learn more complex relationships in the data. Use more epochs. Increase the number of epochs to provide the model with more opportunities to learn from the data. This can help the model converge to a better solution by allowing it to adjust its weights more extensively. Lack of fine-tuning resources. Consider using a smaller dataset. If fine-tuning resources are limited, consider using a smaller dataset that is relevant to the task. This reduces the computational demands of training while still providing valuable information to the model. Explore cloud-based training platforms. Explore cloud-based training platforms that offer scalable and cost-effective solutions for model fine-tuning. These platforms provide the necessary resources and infrastructure for training large models on extensive datasets. Azure OpenAI time range. Inputs. Azure subscription. An Azure subscription is a logical container for your Azure resources, providing a centralized billing and management point. It's essential for accessing and using Azure OpenAI services. OpenAI Resource. An OpenAI resource represents an instance of OpenAI's powerful language models (LLMs) hosted within Azure. These resources allow you to interact with models like GPT-3, Codex, and others, enabling various natural language processing applications. Outputs. Model deployment. Model deployment refers to the process of making an OpenAI model available for use within your Azure environment. Once deployed, you can integrate the model with your applications and leverage its capabilities for tasks like text generation, summarization, or code completion. API calls. API calls represent the interactions your applications have with the deployed OpenAI model. Through these calls, you send prompts and requests to the model, receiving responses and utilizing the model's capabilities. Steps. Create Azure OpenAI resource. This step involves provisioning an OpenAI resource within your Azure environment. You'll select the desired OpenAI model and configure settings like resource type, location, and deployment options. This sets up the foundation for interacting with the model. Deploy model. Once the OpenAI resource is created, you deploy the selected model to it. Deployment makes the model accessible for use and prepares it to handle requests from your applications. Integrate API. The final step involves integrating the deployed OpenAI model with your applications code. This integration allows you to send requests to the model, receive responses, and leverage its capabilities within your application logic. Prerequisites. Azure subscription. Free trial. Azure offers a free trial period that allows you to explore its services, including Azure OpenAI, without incurring any charges. This is a great way to experiment and familiarize yourself with the platform. Pay-as-you-go. Pay-as-you-go pricing offers flexibility and cost control by charging only for the resources you use. This option is suitable for ongoing projects and workloads that may have fluctuating resource needs. OpenAI resource. Text completion. Text completion models like GPT-3 excel at generating coherent and contextually relevant text. You can use them for tasks like writing different types of creative content, translating languages, or summarizing information. Code generation. Code generation models, such as Codex, are specifically designed for generating code in various programming languages. They can assist with tasks like writing code snippets, completing functions, or even generating entire programs based on natural language descriptions. Fine-tune parameters. Training data is essential for fine-tuning the OpenAI model to perform specific tasks or improve its performance on your desired domains. This data needs to be relevant and representative of the tasks you intend for the model to handle. Model hyperparameters. Model hyperparameters are settings that influence the training process and the model's final performance. They include parameters like learning rate, batch size, and epochs. Careful optimization of these parameters is crucial for achieving the desired model performance. Challenges and fixes. Resource quota exhaustion. Increase resource quota if your Azure OpenAI resource encounters resource quota limitations. You can request an increase in your quota. This will provide you with more resources to handle increased workload or complex tasks. Model performance issues. Fine-tune model if your model isn't performing as expected. Fine-tuning it using relevant training data can significantly improve its accuracy and effectiveness. For your specific tasks, optimize hyperparameters. Experimenting with different hyperparameter values during training can lead to better model performance. Tuning these parameters to optimize the model's behavior is crucial for achieving desired results. Adjust API parameters. Fine-tuning the API parameters used when interacting with the model can also help improve performance. For example, adjusting the temperature or top P values can influence the creativity or predictability of a model's responses. Azure OpenAI accuracy. The accuracy of the Azure OpenAI service is influenced by several factors, such as the quality of the training data used, the size of the chosen model, the fine-tuning parameters applied, and the specific task being performed. Inputs. The text used to prompt the model, providing context and instructions for the desired output. For example, a prompt for generating a poem could be write a poem about the beauty of nature. Data used to train the AI model, which is crucial for the model's ability to learn patterns and generate accurate outputs. The quality and relevance of the training data directly impact the model's performance. Outputs. The text generated by the Azure OpenAI model based on the provided inputs and training data. This output can be a variety of formats like summaries, creative text, translations, code, and more. A numerical score that reflects the accuracy of the model's generated output. This score is typically calculated based on various evaluation metrics, such as perplexity, blue score, and rouge score. Steps. The process of training an Azure OpenAI model using a dataset relevant to the task. This step involves feeding the training data to the model and allowing it to learn patterns and relationships. The art of crafting effective prompts that guide the model to generate the desired output. A well-designed prompt is clear, concise, and provides enough context for the model to understand the task. After training and prompt engineering, the model is ready to process new inputs and generate outputs based on its learned patterns. This is the step where the model utilizes the information it has acquired to produce the desired outcome. Evaluating the accuracy of the generated output against a set of predefined criteria. This involves using various metrics to assess the model's performance, including perplexity, blue score, and rouge score. Prerequisites. An active subscription to Microsoft Azure, providing access to cloud-based resources and services. The Azure OpenAI service, which enables access to powerful AI models and functionalities for text generation, translation, summarization, and more. An Azure storage account is required to store the training data and other relevant files needed for the model's training and deployment. The dataset used to train the model needs to be of high quality and relevant to the task. High-quality data means it is accurate, complete, and free from errors or inconsistencies. Relevance ensures the data is aligned with the specific task the model will perform. For example, training a chatbot for customer service would require data related to customer interactions, inquiries, and complaints. Fine-tune parameters. The learning rate determines how much the model adjusts its internal parameters during training, based on the errors it encounters. A higher learning rate leads to faster learning but might result in instability, while a lower learning rate provides more stability but might require longer training times. The number of times the entire training dataset is processed during training. Each epoch allows the model to refine its parameters and improve its understanding of the data. More epochs usually lead to better model accuracy but might increase training time. The number of training samples used to update the model's parameters in each training iteration. A larger batch size generally leads to faster training but might require more memory, while a smaller batch size allows for more frequent updates but might slow down training. Challenges and fixes. Bias in training data can lead to biased outputs from the AI model. For example, if the training data contains gender stereotypes, the model might generate text that reflects those stereotypes. Augmenting the training data with diverse examples helps to reduce bias by exposing the model to a wider range of perspectives. This can involve adding data from different sources, demographics, and cultures. Techniques specifically designed to mitigate bias in AI models are employed. These techniques aim to identify and address biases in the training data and model architecture. Overfitting occurs when the model learns the training data too well and fails to generalize to new data. This results in poor performance on unseen data. Regularization techniques are applied to prevent the model from overfitting by penalizing complex models. This encourages the model to find simpler solutions that generalize better. Early stopping involves monitoring the model's performance on a validation set during training and stopping training when the model's performance on the validation set starts to degrade. This prevents overfitting by stopping training before the model starts to memorize the training data. Data leakage occurs when information from the test data is inadvertently included in the training data, leading to artificially inflated accuracy. This can happen when the same data is used for both training and testing. Splitting the data into separate training, validation, and test sets ensures that the model is not exposed to information from the test set during training. Cross-validation is a technique used to evaluate the model's performance on unseen data by repeatedly splitting the data into different training and validation sets and averaging the results. Limited context in prompts can lead to inaccurate or irrelevant outputs from the model. For example, a prompt that lacks context might result in the model generating responses that are not related to the desired topic. Techniques like providing background information, specifying the desired output format, and using examples in the prompt help to provide more context for the model. Crafting clear, specific, and concise prompts that provide enough context for the model to understand the task and generate accurate outputs. Ambiguous prompts can lead to the model generating outputs that are not aligned with the user's intentions. For example, a prompt that is too vague might result in the model generating responses that are not relevant to the intended topic. Using clear and specific prompts that avoid ambiguity and clearly define the desired output format helps to ensure the model generates outputs that align with the user's intentions. crafting prompts that are precise and well-defined, avoiding ambiguous language and providing clear instructions to the model. Hallucination occurs when the model generates outputs that are not factually accurate or supported by the training data. This can happen when the model makes assumptions or extrapolates beyond its knowledge base. Techniques like verifying the generated outputs against reliable sources, using fact-checking tools, and incorporating external knowledge bases into the model can help to reduce hallucination. Rigorous model validation processes are essential to identify and address hallucination issues. These processes involve evaluating the model's outputs against ground truth data and identifying potential inconsistencies. Lack of domain expertise can lead to inaccurate or irrelevant outputs from the model when dealing with specialized topics. For example, a model trained on general text data might not be able to generate accurate outputs for topics related to finance or medicine. Fine-tuning the model on domain-specific data can help to improve its accuracy and relevance for specialized topics. This involves training the model on a dataset that is specifically related to the desired domain. Integrating external knowledge bases into the model can provide it with access to domain-specific information and improve its ability to handle complex tasks related to that domain. Computational constraints can limit the size and complexity of the models that can be trained and deployed, potentially affecting accuracy. Optimizing resource usage by utilizing efficient algorithms, compressing models, and employing techniques like quantization can improve computational efficiency and reduce resource consumption. Selecting models with an appropriate size and complexity for the specific task and available resources helps to balance accuracy and efficiency. Latency issues can arise during model inference, leading to delays in generating outputs. This can occur when the model is computationally intensive or when the underlying infrastructure experiences limitations. Optimizing model architecture, using techniques like model distillation, and deploying models on optimized hardware can improve model inference speed and reduce latency. Optimizing the infrastructure used to host and serve the model, such as using high-performance computing resources or caching mechanisms, can minimize latency issues. Data privacy concerns arise when dealing with sensitive information during training and inference. This is particularly important when working with data that contains personally identifiable information. Techniques like data masking, which involves replacing sensitive information with random or synthetic values, can help to protect data privacy. Differential privacy is a technique that adds noise to the training data to protect the privacy of individual data points while still allowing the model to learn from the data. Ethical considerations are crucial when developing and deploying AI models. This involves ensuring that the models are fair, unbiased, and do not perpetuate harmful stereotypes or discriminate against individuals. Following responsible AI practices, which involve ethical guidelines for AI development, deployment, and use. Implementing mechanisms for bias detection and mitigation to identify and address potential biases in the model's outputs. Azure OpenAI Fluency. Azure OpenAI Fluency is a feature that enables you to fine-tune OpenAI models to generate more fluent and grammatically correct text inputs, text data that is used to fine-tune the model. For example, if you want to fine-tune a model to write marketing copy, you could provide it with a data set of successful marketing copy OpenAI model that you want to fine-tune. Popular OpenAI models include GPT-3 and Codex. Outputs: fine-tuned model that is better at generating fluent and grammatically correct text. For example, A fine-tuned model could be used to write marketing copy, generate code, or translate languages. Steps. Prepare text data for fine-tuning. This involves cleaning and pre-processing the data, such as removing punctuation and converting the text to lowercase. Train the model on the prepared text data. This involves feeding the data to the model and adjusting its parameters until it can accurately predict the next word in a sequence. Evaluate the model's performance on a held-out dataset. This is done to ensure that the model is not overfitting to the training data and can generalize to new data. Prerequisites. Azure OpenAI service that allows you to access and fine-tune OpenAI models. An Azure subscription, which is a cloud computing platform that provides access to a variety of services, including Azure OpenAI. An Azure OpenAI resource that is a dedicated resource for using Azure OpenAI. This resource provides you with access to the OpenAI API and the ability to fine-tune models. OpenAI model that you want to fine-tune. GPT-3. A powerful language model that can generate text, translate languages, write different kinds of creative content, and answer your questions in an informative way. Codex. A powerful language model that can generate code, translate natural language into code, and answer your questions in a code-related context. Fine-tune parameters. Learning rate, which is a parameter that controls how quickly the model learns during training. A higher learning rate can lead to faster learning but may also cause the model to overfit to the training data. Epochs, which are the number of times the model is trained on the entire dataset. More epochs can lead to better performance but also increase training time. Challenges and fixes. Overfitting, which occurs when the model learns the training data too well and does not generalize well to new data. Use a smaller learning rate, which will cause the model to learn more slowly and prevent it from overfitting to the training data. Use a larger training dataset, which will provide the model with more data to learn from and reduce the risk of overfitting. Underfitting, which occurs when the model does not learn the training data well enough and does not perform well on new data. Use a larger learning rate, which will cause the model to learn more quickly and help it learn the training data better. Use a smaller training dataset, which will make it easier for the model to learn the training data. Poor generalization, which occurs when the model does not perform well on new data even though it performs well on the training data. This can be caused by a lack of diversity in the training data. Use a more diverse training dataset that includes a wider range of examples. This will help the model to learn the underlying patterns in the data and generalize better to new data. Increase the number of epochs, which will allow the model to learn the training data more thoroughly. Azure Open AI Fluency. Azure Open AI Fluency is a feature that helps improve the fluency of text generated by Azure OpenAI models. This feature analyzes the generated text for grammatical errors, awkward phrasing, and other issues that can hinder readability and comprehension. By identifying these issues, the fluency feature can help developers and users create more natural and engaging text. Inputs. The input to Azure Open AI Fluency is the text that needs to be analyzed for fluency. This could be any text generated by an Azure OpenAI model, such as summaries, stories, or even code. Outputs. The output of Azure Open AI Fluency is a fluency score. This score represents the overall fluency of the input text, with higher scores indicating better fluency. The score can be used to identify areas where the generated text needs improvement and to track the progress of fluency over time. Steps. The Azure Open AI Fluency feature analyzes the input text for grammatical errors, awkward phrasing, and other issues that affect fluency. This analysis may involve using a combination of natural language processing techniques, such as part-of-speech tagging and dependency parsing. Based on the analysis, Azure Open AI Fluency assigns a fluency score to the input text. This score represents the overall fluency of the text, with higher scores indicating better fluency. Prerequisites. The Azure Open AI service is a cloud-based platform that provides access to a wide range of natural language processing models, including the Azure OpenAI Fluency feature. To use the Fluency feature, you need an Azure OpenAI service account. To use the Azure Open AI Fluency feature, you need to have an Azure OpenAI model. Azure OpenAI models are pre-trained language models that can be used for various natural language processing tasks, including text generation and fluency analysis. Fine-tune parameters. The Azure Open AI Fluency feature does not have any fine-tune parameters. This means that the feature is not customizable and uses a fixed set of parameters for analyzing fluency. Challenges and fixes. The Azure Open AI Fluency model may not be able to identify all fluency issues. For example, the model might miss some subtle errors in grammar or phrasing. To address this, it is recommended to train the model on a dataset that includes examples of fluency errors. This will help the model learn to identify a wider range of fluency issues. The Azure Open AI Fluency model may assign inaccurate fluency scores. This could happen if the model is not properly trained or if the input text is too complex or unusual. To address this, it is recommended to fine-tune the model on a dataset with known fluency scores. This will help the model learn to assign more accurate scores. Azure OpenAI Coherence. This YAML document describes the Azure OpenAI Coherence feature, which evaluates the quality and consistency of generated text. It outlines the inputs, outputs, steps involved, prerequisites, fine-tuning parameters, and common challenges and fixes. Inputs. The input text that needs to be evaluated for its coherence. This could be a paragraph, an article, or any other text format. For example, you might provide a summary of a scientific paper or a creative writing piece. The specific OpenAI model used to generate the text being evaluated. Popular options include the TextDaVinci 003 model, known for its versatility and quality. The choice of model depends on the desired level of detail and complexity in the generated text. Outputs. A numerical score representing the coherence of the generated text. This score indicates how well the text flows logically and consistently. A higher score suggests better coherence, while a lower score indicates potential inconsistencies or lack of clarity. Steps. The specified OpenAI model is used to generate text based on the provided input. This could involve tasks like summarizing a document, writing a poem, or composing a creative story. The model uses its learned patterns and knowledge to produce text that aligns with the given input and context. The generated text is then analyzed to determine its coherence. Various techniques are employed to evaluate the logical flow, consistency of ideas, and overall readability of the text. The coherence score is calculated based on these analyses. Prerequisites. Access to the Azure OpenAI service is required to utilize this feature. This involves having an active Azure subscription, which provides access to the cloud platform and its resources. An Azure subscription is necessary to access and utilize the Azure OpenAI service. This subscription serves as a contract with Microsoft Azure, granting you the ability to use their cloud computing resources. For various purposes, including AI and machine learning tasks, you need to have an appropriate OpenAI model selected for the text generation. Popular choices include the DaVinci 003 model, renowned for its versatility and capacity for generating high-quality text. Choosing the right model depends on the specific task and the desired complexity of the generated text. The DaVinci 003 model is a powerful AI model offered by OpenAI. It's known for its ability to generate creative, informative, and engaging text across a wide range of applications. This model is particularly adept at handling diverse tasks, such as summarizing articles, writing poems, and composing fictional stories. Fine-tune parameters. Temperature controls the randomness of the generated text. A higher temperature value leads to more creative and unpredictable outputs, while a lower temperature produces more predictable and consistent results. Max tokens specifies the maximum number of tokens the model can generate in a single output. This parameter helps limit the length of the generated text and ensures efficiency in the process. For example, setting max tokens to 100 would limit the generated text to a maximum of 100 tokens. Challenges and fixes. The chosen model might have limitations in handling specific types of text or tasks. For instance, it might struggle with technical or highly specialized content. To overcome model limitations, it's often beneficial to consider using a more advanced or specialized model. This might involve selecting a model specifically trained on the relevant domain or task. For example, if you need to generate technical documentation, you might choose a model trained on a large corpus of technical texts. Incorrect or poorly formatted input text can significantly impact the quality of the generated text and the coherence score. For instance, providing ambiguous or inconsistent information can lead to incoherent output. It's crucial to review and correct any errors or inconsistencies in the input text before submitting it for coherence evaluation. Ensuring clarity, accuracy, and logical flow in the input text can greatly improve the coherence of the generated text. This involves carefully proofreading and revising the input, paying close attention to grammar, punctuation, and the overall structure of the text. Azure OpenAI Virtual Networks VNets configuration. This YAML document outlines the configuration process for integrating Azure OpenAI service with a virtual network VNet in Azure. This integration is crucial for enhancing security and control over Azure OpenAI service. Deployments. Inputs. This refers to the Azure OpenAI service resource itself, including its configuration settings and deployment details. The virtual network VNet that you will use to host and isolate the Azure OpenAI service. Outputs. By integrating with a VNet, you create a secure and isolated environment for your Azure OpenAI service. This environment helps protect your sensitive data and applications from unauthorized access. Integrating with a VNet allows you to implement enhanced data security measures and ensure compliance with relevant regulations. You can leverage network security groups, encryption, and other security features within the VNet to control access to the Azure OpenAI service and protect your data. Steps. Create a virtual network VNet in Azure using the Azure portal or Azure key. This VNet will be the foundation for your secure environment. Define a subnet within the VNet that will specifically host your Azure OpenAI service. This step helps with resource organization and network segmentation. Create an Azure OpenAI service resource within Azure using the Azure portal or Azure key. Configure the resource with the desired settings, such as the model you plan to use. Connect the Azure OpenAI service resource to the subnet you created within the VNet. This step establishes the link between the service and the secure network environment. Prerequisites: you must have an active Azure subscription to create and manage the necessary resources. An Azure subscription provides access to Azure services and resources. An Azure account is required to manage your subscriptions and access Azure services. Before integrating with a VNet, ensure you have provisioned an Azure OpenAI service resource in Azure. This involves creating an Azure OpenAI service resource and obtaining an API key to access its capabilities. Fine-tune parameters: the size and address range of the subnet within the VNet that will host the Azure OpenAI service. This parameter influences network capacity and resource allocation. Network security groups (NSGs) are essential for controlling network access and implementing security policies for the Azure OpenAI service. Define the rules and restrictions for inbound and outbound traffic on the subnet. The region where you choose to deploy the Azure OpenAI service within Azure. Selecting an appropriate region is crucial for latency, data residency, and compliance considerations. Integrating the Azure OpenAI service with other Azure services can enhance its functionality. Examples include integrating with Azure Cognitive Services for natural language processing or with Azure Blob Storage for data storage. Challenges and fixes: network connectivity issues can arise during the integration process. Troubleshooting steps include verifying network configuration, checking firewall rules, ensuring proper routing, and verifying if any security groups are blocking traffic. Data security is a paramount concern when integrating Azure OpenAI service with a VNet. Implement encryption in transit and at rest for your data. Utilize network security groups to control access. And monitor network traffic and logs to detect and prevent potential security threats. Compliance requirements vary by industry and region. Ensure you follow Azure security best practices. Use Azure policy to enforce compliance rules. And regularly audit and monitor your environment to maintain compliance. Ensure seamless integration with other Azure services. This includes configuring proper authentication and authorization, establishing network connectivity between services, and utilizing available Azure service integration features to maximize efficiency and functionality. Azure OpenAI Firewalls. This document outlines a comprehensive approach to securing Azure OpenAI services by implementing network security groups (NSGs), effectively restricting network access and enhancing security. Inputs: Azure OpenAI resource. This refers to an Azure OpenAI service instance, enabling developers to interact with powerful language models for various tasks like text generation, translation, and code completion. Network Security Group (NSGs) are fundamental security components in Azure. They act as virtual firewalls, controlling inbound and outbound network traffic to Azure resources, providing granular control over network access. Outputs: secure Azure OpenAI service by implementing NSG rules. The Azure OpenAI service will be shielded from unauthorized access, ensuring secure and controlled communication with the service. Steps: create Azure OpenAI resource. This step involves provisioning an Azure OpenAI service instance within your Azure subscription. Create NSG rules. NSG rules are defined to specify allowed and blocked network traffic. For instance, you can allow access from specific IP addresses or subnets, block access from specific ports, or restrict access based on protocols like HTTP or HTTPS. Prerequisites: Azure subscription to access and manage Azure services, including Azure OpenAI. An active Azure subscription is required. Active Azure subscription. This signifies an active and functional Azure account with the necessary resources and permissions to deploy and manage Azure resources. Azure OpenAI resource. An existing Azure OpenAI resource is crucial for implementing NSG rules. Existing Azure OpenAI resource. This implies a previously provisioned Azure OpenAI service within your Azure subscription, ready for network security configuration. Fine-tune parameters. NSG rule configuration. This encompasses defining the specific rules for the NSG, including source and destination IP addresses, ports, protocols, and actions allow or deny. Network traffic filtering. The NSG rules act as filters, carefully controlling network traffic based on the configured rules. This mechanism ensures that only authorized network traffic can reach the Azure OpenAI service. Challenges and fixes. Insufficient security. Without proper network security measures, the Azure OpenAI service might be vulnerable to unauthorized access or malicious activities. Implement NSG rules. Deploying NSG rules effectively addresses this challenge by creating a strong security perimeter around the Azure OpenAI service. Unauthorized access. Unsecured Azure OpenAI services might face unwanted access, potentially leading to data breaches or misuse. Restrict network access. Implementing NSG rules allows you to restrict network access to the Azure OpenAI service, limiting access to only authorized users or systems. Azure OpenAI Azure Active Directory integration. Inputs. Azure OpenAI resource. This input represents the Azure OpenAI resource that you want to integrate with Azure Active Directory. This resource is a deployment of the Azure OpenAI service, which provides access to various language models. Azure AD Tenant ID. This input specifies the unique identifier of your Azure Active Directory tenant. This identifier is used to locate your organization's Azure AD instance, which is responsible for managing user identities and permissions. Azure AD Application ID. This input represents the unique identifier assigned to the Azure AD application that you create to handle authentication with Azure OpenAI. This identifier is used to distinguish your application from others in Azure AD. Azure AD Application Secret. This input is a confidential string used to secure the communication between your Azure AD application and the Azure OpenAI service. It acts as a secret key that verifies the application's identity during authentication. Outputs. Secure access to Azure OpenAI models. This output indicates that after the integration is completed, your users will have secure access to the Azure OpenAI models through the Azure AD application. This means that only authorized users with appropriate permissions can interact with the models. Authentication for users. This output represents the authentication mechanism that is established between users and Azure OpenAI models through the integrated Azure AD application. It provides a secure and standardized way for users to access and interact with the models while ensuring their identity is verified. Steps. Register Azure OpenAI resource. This step involves registering your Azure OpenAI resource within your Azure subscription. This step ensures that your Azure OpenAI service is properly provisioned and configured within your Azure environment. Create Azure AD application. In this step, you create a new Azure AD application within your Azure AD tenant. This application acts as an intermediary between your users and the Azure OpenAI service, handling authentication and authorization. Configure Azure AD permissions. This step involves defining the specific permissions that your Azure AD application needs to access the Azure OpenAI service. You grant the application appropriate permissions to interact with the service, allowing it to perform tasks like creating and managing models, Grant Azure AD application access. In this step, you grant access to the Azure OpenAI resource for your Azure AD application. This step allows the application to interact with the Azure OpenAI service on behalf of your users, enabling them to leverage the language models. Prerequisites. Azure subscription. This prerequisite represents the need for an active Azure subscription. A subscription provides a dedicated environment for deploying and managing Azure resources, including the Azure OpenAI service. Subscription ID. This represents the unique identifier assigned to your Azure subscription. This ID is crucial for locating and accessing your subscription's resources within the Azure platform. Azure OpenAI service. This prerequisite highlights the requirement to have an Azure OpenAI service deployed within your Azure subscription. This service provides access to various language models that can be used for a wide range of natural language processing tasks. Deployment location. This refers to the specific geographic location where your Azure OpenAI service is deployed within Azure. This location influences factors like data residency and latency. Fine-tune parameters. Authentication method. This parameter represents the chosen method used for authentication between users and the Azure OpenAI service. It defines how users will be verified and authenticated before accessing the language models. Scope of access. This parameter determines the level of access that users have to the Azure OpenAI models. It defines what specific models and functionalities users can interact with based on their roles and permissions. Challenges and fixes. Incorrect Azure AD permissions. This challenge arises when the Azure AD application is not granted the necessary permissions to access the Azure OpenAI service. This can lead to errors or limitations in accessing the models. Verify permissions granted. To fix this challenge, you need to carefully verify the permissions granted to your Azure AD application. Ensure that the application has been assigned all the required permissions to interact with the Azure OpenAI service. Missing application secret. This challenge occurs when the Azure AD application lacks a secret key, which is essential for secure communication with the Azure OpenAI service. This can prevent the application from authenticating and accessing the models. Regenerate application secret. To resolve this challenge, you can regenerate a new application secret for your Azure AD application. This secret acts as a password, ensuring secure communication between the application and the Azure OpenAI service. Azure OpenAI Security Logs. Azure OpenAI Service security logs provide comprehensive insights into user activities, model usage, and potential security events. Inputs. Azure OpenAI Service. The Azure OpenAI service that is being used. User authentication data. Data about the users who are accessing the Azure OpenAI service, including their authentication details, timestamps, and IP addresses. Model usage data. Data about the models that are being used, including the models' names, versions, and usage patterns. Outputs. Audit logs. Logs that record all actions taken by users, including model deployments, fine-tuning, and API calls. Security events. Logs that capture potential security threats, such as unauthorized access attempts, API key misuse, and data breaches. User activity logs. Logs that track user activities, such as model deployments, API calls, and data access. Steps. Enable security logging. Enables security logging for the Azure OpenAI service, ensuring that all security-related events are captured. Configure logging destination. Specifies the destination for security logs, such as Azure storage accounts, event hubs, or log analytics workspaces. Monitor and analyze logs. Regularly monitors and analyzes security logs to identify potential security threats and investigate security incidents. Prerequisites: Azure subscription and active Azure subscription with appropriate permissions to manage and access. Azure OpenAI Services. Azure OpenAI Service, a created and configured Azure OpenAI Service instance, which is the core component of Azure OpenAI security logging. Fine-tune parameters. Logging level defines the level of detail captured in security logs, including different levels like informational, warning, and error. Retention policy specifies the duration for which security logs are retained, ensuring that relevant data is available for security investigations. Challenges and fixes. Insufficient logging, a situation where security logs lack adequate details or don't capture all necessary events. It can be addressed by adjusting logging levels, optimizing logging policies, and ensuring that logs capture all relevant activities. Log analysis complexity, the challenge of effectively analyzing and interpreting vast amounts of security logs to identify threats and anomalies. It can be addressed by utilizing specialized security information and event management SIEM tools. Leveraging the capabilities of Azure Security Center to automate log analysis and threat detection. Azure OpenAI TLS/SSL protocols. Azure OpenAI uses TLS/SSL to encrypt communication between your application and the Azure OpenAI service. Inputs. The Azure OpenAI service endpoint is a URL that your application connects to. Application credentials are used to authenticate your application with the Azure OpenAI service. These credentials can be in the form of an API key, a service principal, or a managed identity. Outputs. Secure communication ensures that data exchanged between your application and the Azure OpenAI service is protected from eavesdropping and tampering. Data encryption in transit safeguards sensitive information while it is being transferred between your application and the Azure OpenAI service. Steps. Establish a TLS/SSL connection initiates a secure communication channel between your application and the Azure OpenAI service. Authenticate with Azure OpenAI service verifies the identity of your application and grants access to the Azure OpenAI service. Send requests and receive responses allows your application to interact with the Azure OpenAI service by sending requests and receiving responses. Prerequisites. TLS/SSL enabled on both client and server ensures that both your application and the Azure OpenAI service support TLS/SSL for secure communication. Use TLS 1.2 or higher is essential because older versions of TLS have known vulnerabilities. Azure OpenAI Service subscription grants you access to the Azure OpenAI service and its capabilities. Fine-tune parameters. TLS/SSL protocol version determines the specific version of TLS/SSL used for communication. For example, TLS 1.3 is the latest version and offers improved security and performance. Cipher suites specify the encryption algorithms and hashing functions used during TLS/SSL communication. Choosing strong and up-to-date cipher suites is essential for strong security. Challenges and fixes. TLS/SSL handshake failures occur when the client and server cannot establish a secure connection. Ensure TLS/SSL is enabled on both client and server ensures that both sides support TLS/SSL communication. Verify that the TLS/SSL protocol versions are compatible ensures that both the client and server support the same version of TLS/SSL. Check for certificate validation issues verifies that the service certificate is trusted and valid. Update the TLS/SSL certificates ensures that the certificates used for communication are up to date and valid. Performance issues can arise due to inefficient TLS-SSL configuration or network conditions. Use a faster TLS-SSL cipher suite can improve performance by leveraging more efficient encryption. Algorithms. Optimize network configuration can improve performance by reducing network latency and improving bandwidth. Security vulnerabilities can exist in TLS-SSL protocols. Implementations or certificates. Keep TLS-SSL certificates up to date ensures that the certificates are not expired and are not subject to known vulnerabilities. Use strong cipher suites safeguards communication by using robust encryption algorithms and hashing functions. Implement TLS-SSL best practices protects communication by adhering to industry-recommended security practices for TLS-SSL. Azure OpenAI Security Measures. The Azure OpenAI Service, a powerful tool for leveraging the capabilities of advanced AI models, prioritizes security measures to safeguard sensitive data and ensure ethical AI development. Practices. Inputs. Data used for training and inference. This refers to the data used to train the AI model and subsequently, the data used as input for the model to generate outputs. Examples include text data for natural language processing tasks, images for computer vision, or numerical data for predictive analysis. User inputs provided to the model. These are the inputs provided by users when interacting with the AI model. For instance, a user might input a question in a chatbot or a description of an image for analysis. Outputs. Model outputs generated by the AI model. These are the outputs generated by the AI model based on the provided inputs. The outputs could be text, images, predictions, or any other form of data relevant to the model's capabilities. Insights derived from data analysis through the analysis of the input data. The AI model may generate insights or patterns that can be used for decision making or further research. Steps. Data encryption at rest and in transit. This refers to the encryption of data while it is stored in, while it is being transmitted between different components of the system. It ensures that sensitive data remains secure even in the event of unauthorized access. Access control and authentication. This involves implementing mechanisms to restrict access to the AI model and its associated data. Authentication verifies the identity of users and allows only authorized individuals to interact with the system. Secure model deployment and management. This encompasses measures to securely deploy the AI model within the Azure environment and manage its life cycle, including updates and maintenance, in a secure and controlled manner. Responsible AI principles and guidelines. Azure OpenAI Service adheres to principles of responsible AI, ensuring that the models are used ethically and responsibly. These principles cover areas such as fairness, transparency, accountability, and privacy. Prerequisites. Azure subscription. Access to the Azure OpenAI Service requires an active Azure subscription. It is essential to have an Azure account to deploy and manage the service within the Azure cloud environment. Azure OpenAI Service deployment. Once you have an Azure subscription, you need to deploy the Azure OpenAI Service to your subscription. This involves configuring the service with your desired settings and resources to utilize its capabilities. Fine-tune parameters. Model selection. The choice of the AI model is crucial to align with the specific task or problem you are trying to solve. The Azure OpenAI Service offers various pre-trained models with different capabilities and strengths. Training data. This refers to the data used to train the selected model for a specific task. This data must be relevant to the problem and of high quality to ensure the model's accuracy and performance. Hyperparameters: these are parameters that control the training process of the AI model. By adjusting these parameters, you can fine-tune the model's behavior and optimize its performance for the specific task. Challenges and fixes. Data security: protecting sensitive data used for training and inference is paramount. Data encryption: implementing encryption techniques safeguards data at rest and in transit, making it unintelligible to unauthorized individuals. Access control: restricting access to sensitive data through robust authentication and authorization mechanisms prevents unauthorized access and data breaches. Model security: securely deploying and managing the AI model is crucial to prevent malicious attacks and ensure its integrity. Secure model deployment: deploying the model within a secure environment and utilizing appropriate security measures mitigates risks of unauthorized access and tampering. Model access control: implementing access controls restricts access to the model and its outputs, ensuring that only authorized individuals can interact with it. Responsible AI: utilizing AI models ethically and responsibly is a critical aspect of their development and deployment. Bias mitigation: identifying and mitigating potential biases in the training data and model outputs is essential for ensuring fairness and equity in AI applications. Explainability and transparency: providing insights into the model's decision-making process and ensuring transparency in its outputs fosters trust and accountability in AI systems. Azure OpenAI emerging threats. Azure OpenAI service is a powerful tool for developers who are looking to leverage the power of large language models. However, there are several emerging threats that organizations need to be aware of when using this service. These threats can impact the security, privacy, and ethical use of AI models, and organizations must take proactive steps to mitigate them. Inputs. Data privacy: data privacy is a critical concern when using Azure OpenAI service. Sensitive data, such as personal information or confidential business data, should be handled with utmost care. Organizations must ensure that data is collected, stored, and used in compliance with relevant privacy regulations, such as GDPR and CCPA. Model security: model security refers to protecting AI models from unauthorized access, manipulation, or misuse. This involves securing the model itself, as well as the data used to train and operate the model. Organizations must implement measures to prevent malicious actors from compromising the integrity and reliability of their AI models. Outputs. Secure data handling: implementing robust data security practices is crucial for safeguarding sensitive information. This involves encrypting data at rest and in transit, implementing access controls, and regularly auditing data access logs. Organizations must ensure that data is handled securely throughout its life cycle, from collection to storage and use. Model integrity: ensuring the integrity of AI models is essential for maintaining their reliability and trustworthiness. This involves monitoring models for performance degradation, bias, or unintended consequences. Organizations must have mechanisms in place to detect and address any issues that may arise, ensuring that models continue to operate as intended. Steps. Evaluate risk. Evaluating the potential risks associated with using Azure OpenAI service is a critical first step. This involves identifying potential threats, assessing their likelihood and impact, and prioritizing risks based on their severity. By understanding the potential risks, organizations can develop appropriate mitigation strategies, implement controls once risks have been evaluated, Organizations must implement controls to mitigate them. These controls can include technical measures, such as encryption and access control, as well as organizational policies and procedures. By implementing these controls, organizations can reduce the likelihood and impact of potential threats. Prerequisites: data security. Ensuring the security of data used to train and operate AI models is paramount. This involves implementing measures to protect data from unauthorized access, modification, or disclosure. Organizations must establish robust data security practices to maintain the confidentiality, integrity, and availability of data. Data encryption is a fundamental security measure that involves converting data into an unreadable format, making it inaccessible to unauthorized individuals. Encrypting data at rest and in transit is crucial for protecting sensitive information from unauthorized access. Model integrity. Maintaining the integrity of AI models is essential for ensuring their reliability and trustworthiness. This involves monitoring models for performance degradation, bias, or unintended consequences. Organizations must have mechanisms in place to detect and address any issues that may arise, ensuring that models continue to operate as intended. Model monitoring involves continuously tracking the performance of AI models to identify any deviations from expected behavior. This includes monitoring model accuracy, fairness, and explainability, as well as detecting any signs of model drift or bias. By monitoring models, organizations can identify and address issues before they escalate. Fine-tune parameters. Data privacy. Ensuring data privacy is a critical concern when using Azure Open AI service. Sensitive data, such as personal information or confidential business data, should be handled with utmost care. Organizations must ensure that data is collected, stored, and used in compliance with relevant privacy regulations, such as GDPR and CCPA. Model security. Model security refers to protecting AI models from unauthorized access, manipulation, or misuse. This involves securing the model itself, as well as the data used to train and operate the model. Organizations must implement measures to prevent malicious actors from compromising the integrity and reliability of their AI models. Challenges and fixes. Data breaches. Data breaches can occur when sensitive information is accessed or stolen by unauthorized individuals. This can have significant consequences for organizations, including financial losses, reputational damage, and legal penalties. Implementing robust data security measures, such as encryption and access controls, can help prevent data breaches. Secure data handling. Implementing robust data security practices is crucial for safeguarding sensitive information. This involves encrypting data at rest and in transit, implementing access controls, and regularly auditing data access logs. Organizations must ensure that data is handled securely throughout its life cycle, from collection to storage and use. Model poisoning. Model poisoning is a type of attack where malicious actors manipulate the training data used to create an AI model, causing the model to produce biased or incorrect outputs. This can be mitigated by carefully vetting training data and implementing robust data validation processes. Model monitoring. Model monitoring involves continuously tracking the performance of AI models to identify any deviations from expected behavior. This includes monitoring model accuracy, fairness, and explainability, as well as detecting any signs of model drift or bias. By monitoring models, organizations can identify and address issues before they escalate. Model bias. Model bias occurs when an AI model produces outputs that are discriminatory or unfair towards certain groups of individuals. This can be caused by biases in the training data or by algorithmic biases within the model itself. Implementing fair AI practices and ensuring that training data is representative of the population it will serve can help mitigate model bias. Responsible AI principles. Responsible AI principles provide a framework for developing and deploying AI systems in a way that is ethical, fair, and transparent. These principles emphasize the importance of human oversight, accountability, and transparency in AI development and deployment. Lack of transparency. Lack of transparency in AI models can make it difficult to understand how they make decisions and to identify potential biases or errors. This can lead to a lack of trust and accountability in AI systems. Implementing techniques like model explainability can help improve the transparency of AI models. Model explainability. Model explainability involves developing techniques to understand how an AI model works and to explain its decisions. This can involve visualizing the model's internal workings or providing human-readable explanations of its outputs. Regulatory compliance. Organizations using Azure Open AI service must comply with relevant data privacy regulations, such as GDPR and CCPA. These regulations impose strict requirements on how data is collected, stored, and used, and organizations must implement appropriate measures to ensure compliance. Data privacy laws. Data privacy laws are designed to protect individuals' personal information and to provide them with control over how their data is used. Organizations must be aware of and comply with all applicable data privacy laws, ensuring that they handle personal data responsibly. Ethical considerations. The use of AI raises a number of ethical considerations, such as the potential for bias, discrimination, and harm. Organizations must carefully consider the ethical implications of their AI systems and ensure that they are developed and deployed in a responsible manner. AI ethics guidelines. AI ethics guidelines provide a framework for developing and deploying AI systems in a way that is ethical, fair, and transparent. These guidelines emphasize the importance of human oversight, accountability, and transparency in AI development and deployment. Model drift. Model drift occurs when the performance of an AI model degrades over time due to changes in the underlying data or the environment. This can be caused by factors such as data distribution shifts or changes in user behavior. Regular model retraining can help mitigate model drift. Model retraining. Model retraining involves updating an AI model with new data to improve its performance and to adapt to changes in the environment. Regular retraining can help ensure that models remain accurate and relevant over time. Lack of skills. A lack of skills in AI can hinder an organization's ability to develop, deploy, and manage AI systems effectively. This can involve a lack of expertise in areas such as data science, machine learning, and AI ethics. Organizations must invest in training and development programs to build a skilled AI workforce. AI training programs. AI training programs can provide individuals with the skills and knowledge necessary to develop, deploy, and manage AI systems effectively. These programs can cover a range of topics, such as machine learning, deep learning, data science, and AI ethics. Resource constraints. Resource constraints can limit an organization's ability to invest in the development, deployment, and management of AI systems. This can involve financial limitations, a lack of skilled personnel, or access to computing resources. Organizations must carefully consider their resources and develop strategies for managing them effectively. Cloud-based solutions can provide organizations with access to the computing resources, infrastructure, and expertise necessary to develop and deploy AI systems effectively. Cloud platforms offer a scalable and cost-effective way to manage AI workloads. Security threats to AI systems can include unauthorized access, data breaches, and model poisoning. These threats can compromise the integrity, reliability, and security of AI models, leading to negative consequences for organizations. Implementing robust security measures is crucial for protecting AI systems. Access control measures are designed to restrict access to sensitive data in systems, ensuring that only authorized individuals can access them. Implementing strong access controls, such as role-based access control and multi-factor authentication, can help prevent unauthorized access to AI systems. Data leakage occurs when sensitive information is unintentionally disclosed or leaked to unauthorized individuals. This can be caused by human error, system vulnerabilities, or malicious actors. Implementing data loss prevention (DLP) measures can help prevent data leakage. Data loss prevention (DLP) measures are designed to detect and prevent the unauthorized transmission or disclosure of sensitive data. These measures can include data encryption, access controls, and monitoring of data transfer activities. Model exploitation involves using an AI model for malicious purposes, such as generating fraudulent content, impersonating individuals, or manipulating systems. This can be mitigated by implementing measures to prevent model exploitation, such as model sandboxing. Model sandboxing involves isolating an AI model from other systems to prevent it from being exploited or used for malicious purposes. This involves running the model in a controlled environment where its access to data and resources is restricted. Malicious actors can use AI models for harmful purposes, such as creating fake news, spreading propaganda, or automating cyber attacks. Organizations must implement measures to prevent the malicious use of their AI models, such as content filtering. Content filtering techniques are used to identify and block harmful or inappropriate content from being generated or disseminated by AI models. This can involve using machine learning algorithms to detect and filter malicious content. Unintended consequences. AI systems can sometimes have unintended consequences, such as creating biases, perpetuating harmful stereotypes, or causing unforeseen social or economic impacts. Organizations must carefully consider the potential unintended consequences of their AI systems and implement measures to mitigate them. Impact assessment involves evaluating the potential consequences of an AI system before it is deployed. This can include assessing the system's impact on society, the economy, and the environment, as well as identifying any potential risks or harms. Data governance refers to the processes and policies that organizations use to manage their data, ensuring that it is used responsibly and ethically. This involves establishing clear data ownership, access controls, and data quality standards. Data governance policies define the rules and principles that govern the use, access, and management of data within an organization. These policies can address issues such as data privacy, security, quality, and retention. Azure OpenAI Functions. This document details the integration of Azure OpenAI Service with Azure Functions. Azure OpenAI Service provides a powerful platform for interacting with large language models. enabling tasks like text generation, summarization, translation, and code completion. Azure Functions, on the other hand, offer a serverless platform for running code in response to events or on a schedule. By combining these services, you can create dynamic and scalable applications that leverage the power of AI. Inputs. The API key is a unique identifier that allows your Azure function to authenticate with the Azure OpenAI service and access its resources. It acts like a password, ensuring that only authorized requests can use the service. You can find your API key in the Azure OpenAI resource settings within your Azure portal. The endpoint is the URL address of the Azure OpenAI service. It specifies where your Azure function should send its requests to interact with the OpenAI models. You can find the endpoint in the same location as the API key in your Azure OpenAI resource. Settings. Azure function code is the actual code that you write to implement the logic of your application. It can be written in various languages supported by Azure Functions, including C, JavaScript, Python, and more. The code should include the logic for invoking the OpenAI API, handling responses, and potentially interacting with other Azure services. Triggers define the events that will trigger your Azure function to execute. Common triggers include HTTP requests, scheduled events, messages from other Azure services, and more. For example, you might have a function triggered by an HTTP request that receives a user query, then uses the OpenAI API to generate a response, and finally sends the response back to the user. Outputs. The outputs of your Azure function will be determined by the tasks you implement using the Azure OpenAI API. For instance, if your function is designed to generate text based on a given prompt, the output will be the generated text. Similarly, if your function translates text, the output will be the translated text. Steps. Creating an Azure function is the first step in implementing the integration. You can do this through the Azure portal or using the Azure CLI. You need to choose a suitable runtime for your function, e.g., C, JavaScript, Python, and define the trigger type that will activate the function. Install Azure OpenAI SDK. The Azure OpenAI SDK provides a set of libraries that simplify interacting with the Azure OpenAI service. You can install the SDK for your chosen language in your Azure Function project, which allows you to directly use functions and classes provided by the SDK to communicate with the OpenAI API. Configuration involves providing the API key and endpoint to your Azure function code. This typically involves creating environment variables in your function app settings in the Azure portal, allowing you to securely store these credentials. You can then access these environment variables within your function code to authenticate with the OpenAI service. Implementing API calls involves writing the code that interacts with the Azure OpenAI API. This may involve constructing requests, sending them to the API endpoint, and handling the responses. The OpenAI API offers a wide range of features for different tasks, so you will need to choose the appropriate API calls based on your application's needs. Deploying the Azure function makes it available to users or other Azure services. This involves publishing your function code to the Azure cloud. You can deploy your function using the Azure portal, the Azure CLI, or continuous integration and continuous delivery CI/CD tools like Azure DevOps. Prerequisites. An Azure subscription provides access to the Azure OpenAI service and Azure functions. You need to create an Azure account and obtain an Azure subscription to use these services. An Azure account is your user identity within the Azure platform, allowing you to manage your Azure resources. You can create an Azure account through the Azure portal or by signing up for a free trial. An Azure Function app is a container for your Azure functions. It provides a runtime environment where your functions can execute. You can create a new function app in the Azure portal and choose the appropriate settings, such as the runtime environment and hosting plan. An Azure OpenAI resource is essential for using the OpenAI API. You need to create an Azure OpenAI resource in the Azure portal, where you can configure access and billing settings. The API key acts as an authentication token, enabling your Azure function to interact with the OpenAI service. You can find and manage your API keys within the Azure OpenAI resource settings in the Azure portal. The endpoint is the URL where your Azure function should send requests to interact with the Azure OpenAI service. You can find the endpoint in the same location as the API key in the Azure OpenAI resource settings. Fine-tune parameters. The model type refers to the specific OpenAI model you want to use for your application. Azure OpenAI offers various models, each optimized for different tasks. For example, you might choose a text generation model like GPT 3.5 or a code completion model like Codex. Fine-tuning data involves providing specific data to train your selected OpenAI model to better perform a particular task. For example, if you are building a chatbot, you can fine-tune the model with conversational data to improve its ability to generate natural-sounding responses. The learning rate is a parameter used in the fine-tuning process that controls how much the model updates its weights during training. A higher learning rate indicates more significant updates per training iteration, while a lower learning rate implies smaller updates. The appropriate learning rate depends on the specific model and dataset used for fine-tuning. Challenges and fixes. Authentication issues often arise when the Azure function cannot verify the API key or endpoint properly. Verify API key and endpoint. Ensure that the API key and endpoint are correctly configured in your Azure function code and that they match the values in your Azure OpenAI resource settings. Incorrect values or typos can lead to authentication failures. Ensure correct Azure function role. Make sure the Azure function has the necessary permissions to access the Azure OpenAI service. This typically involves assigning the appropriate role to the function app identity or using managed identities. Check network connectivity. Verify that the Azure function can connect to the Azure OpenAI service. Firewalls, network configuration, or internet connectivity issues can prevent the function from reaching the API endpoint. Model availability issues can arise if the chosen model is unavailable or has limitations. Use supported models. Ensure that the OpenAI model you choose is supported by the Azure OpenAI service. Not all models might be available, and some models may have usage restrictions or require specific permissions. Check model limits. Verify that the model you are using does not exceed its capacity or has usage limitations. Some models have quotas on the number of requests or characters they can process, which could cause issues if you are sending too many requests or processing large amounts of text. Request quota increase. If you encounter model limits, you might need to request a quota increase from Microsoft. They can adjust your resource limits based on your specific needs and usage patterns. API call errors can occur due to issues with the request itself or the response from the OpenAI API. Handle HTTP errors. Implement error handling in your Azure function code to catch any HTTP errors returned by the OpenAI API. This allows you to gracefully handle issues such as invalid API keys, incorrect requests, or server-side errors. Check API request structure. Ensure that the request you are sending to the OpenAI API is formatted correctly. The API has specific requirements for the request structure, including the model to use, the prompt text, and any other parameters. Errors in the request format can result in invalid responses or errors. Verify input data format. Ensure that the data you are providing to the OpenAI API is in expected format. For example, if you are providing text for analysis, make sure it is properly encoded and formatted as required by the specific model. Function deployment issues can arise when deploying the Azure function to the Azure cloud. Deploy to correct function app. Ensure that you are deploying your Azure function to the correct function app in your Azure subscription. Deploying to the wrong app can lead to misconfiguration or access issues. Review deployment logs. Check the deployment logs for any errors or warnings during the deployment process. This can help identify potential issues and troubleshoot them. Check Azure function configuration. Ensure that the Azure function configuration is correct, including the trigger type, resource bindings, and other settings. Misconfigured settings can prevent the function from executing or accessing necessary resources. Performance degradation can occur if the Azure function or the OpenAI API is not optimized for efficiency. Optimize code for efficiency. Review your Azure function code for potential bottlenecks or areas where performance can be improved. Consider using efficient algorithms, data structures, and code optimization techniques to improve the function's speed. Consider caching strategies. Implement caching mechanisms to store frequently accessed data in memory, reducing the need to repeatedly make API calls to the OpenAI service. This can significantly improve response times. Explore alternative models if you are experiencing performance issues with a particular OpenAI model. Consider exploring alternative models that might be more efficient for your task. Different models have varying computational requirements and performance characteristics. Security vulnerabilities can arise if the API key is not secure or if the application does not properly validate inputs. Use secure API keys. Always store your API key securely, using environment variables or other methods that prevent unauthorized access. Avoid hardcoding the key directly in your code. Implement input validation. Validate user input before sending it to the OpenAI API. This helps prevent malicious attacks or unexpected behaviors caused by invalid data. Use trusted sources for fine-tuning data. If you are fine-tuning your model, ensure that you use trusted and reliable data sources to avoid introducing biases or vulnerabilities. Carefully review and sanitize any data used for fine-tuning. Azure OpenAI Logic Apps. This describes the integration of OpenAI models into Logic Apps, a cloud-based service that helps automate workflows and business processes. It enables users to leverage the power of OpenAI's cutting-edge artificial intelligence models within Logic Apps workflows. Inputs. This refers to the event that triggers the Logic App workflow. This could be an HTTP request, a timer, or any other event that sets the workflow in motion. For instance, a user might trigger a workflow by sending an HTTP request with specific data to a Logic App endpoint, or a workflow might be automatically triggered by a timer at a predetermined time. Input data provided to the OpenAI model is a crucial part of the process. This data could be text for tasks like summarization or translation, or code for tasks like code completion or debugging. The model then uses this input to generate an output based on its trained capabilities. Outputs. This refers to the result generated by the OpenAI model based on the input data. The output can take many forms, depending on the task and the model. For example, it could be a generated text, translated text, or even a piece of code. The output is then used within the Logic App workflow for subsequent actions. Steps. This step involves defining the specific trigger event that starts the Logic App workflow. As an example, if the trigger is an HTTP request, the Logic App will be configured to listen for incoming requests and start processing once a request is received. This step is about connecting the Logic App to the Azure OpenAI service, enabling communication and data exchange. This involves providing the necessary credentials and configuration for the connector to interact with the OpenAI service. This step involves choosing the specific OpenAI model to be used in the Logic App workflow. OpenAI offers a wide range of models for various tasks. The selection depends on the intended use of the workflow and the specific capabilities of a model. This step focuses on providing the input data to the chosen OpenAI model. For example, a text input for summarization or translation, or code input for code completion or debugging. This step involves handling the output generated by the OpenAI model. The workflow might then use this output for further actions. This could be saving the generated text to a file, sending it as an email, or using it as input for another part of the workflow. Prerequisites. An Azure subscription is necessary to access the Azure OpenAI service, which is used to interact with the OpenAI models. A subscription provides the necessary resources and environment for using Azure services. Azure OpenAI Service is a platform provided by Microsoft Azure that offers access to OpenAI models and capabilities. This service enables integration of OpenAI models into various Azure services, including Logic Apps. An OpenAI API key is required for authentication and authorization when accessing and using OpenAI models through the Azure OpenAI service. This key ensures secure access and limits usage to authorized users. A Logic Apps resource is essential for creating and managing Logic App workflows. This resource provides a platform for designing, deploying, and running automated workflows that integrate OpenAI models and other services. Fine-tune parameters. This refers to the specific OpenAI model being used for the task. Choosing the correct model is important as different models are specialized for different tasks. This involves crafting the input prompts effectively to guide the OpenAI model to generate the desired output. This includes understanding the model's strengths and weaknesses, choosing appropriate keywords, and structuring the prompt logically. This parameter controls the randomness of the output generated by the OpenAI model. A higher temperature results in more unpredictable outputs, while a lower temperature leads to more predictable outputs. This parameter sets a limit on the maximum number of tokens, words, or subwords that the OpenAI model can use to generate its output. This helps to control the length of the output and manage costs associated with model usage. Challenges and fixes. This challenge arises when the input data provided to the OpenAI model is incorrect or invalid, or when the model encounters errors during processing. This can lead to unexpected or incorrect outputs, disrupting the workflow. Fixes to challenge 1. Logic Apps offer error handling blocks that can be used to catch and handle these errors gracefully. This ensures that the workflow continues even in the presence of errors, preventing interruptions and maintaining continuity. This challenge involves managing the costs associated with using OpenAI models for large-scale AI operations. OpenAI models can be computationally expensive, especially when processing large amounts of data or generating lengthy outputs. Fixes to challenge 2. Optimizing the design of the prompts to minimize the number of tokens required by the model can help reduce costs. Limiting token usage by carefully crafting the input data can also minimize costs. using pricing tiers offered by OpenAI, which vary based on usage and computational requirements, can also help manage costs effectively. This challenge focuses on ensuring the privacy and security of data used in the Logic App workflow, especially when interacting with OpenAI models. Protecting sensitive information during data transmission and storage is crucial. Fixes to challenge 3. Using secure data storage methods like encryption and access control mechanisms can safeguard sensitive information. Implementing strong authentication and authorization protocols during data access can also enhance data security. This challenge arises when integrating Logic apps with existing systems, such as databases, APIs, or other applications. Ensuring seamless data exchange and communication between these systems can be a challenge. Fixes to challenge 4. Logic apps provide a wide range of connectors and APIs for seamless integration with various systems. These connectors facilitate data exchange and communication, enabling Logic apps to interact with other applications efficiently. The use of these connectors and APIs simplifies the integration process, allowing for smooth data flow and efficient communication between Logic apps and other systems. Azure OpenAI integration with other apps. This YAML document describes the process of integrating the Azure OpenAI service with other applications to leverage the capabilities of AI, such as text generation, code completion, and summarization. Inputs. The unique URL provided by Azure for accessing your specific OpenAI service instance. This endpoint is used to direct API requests to your chosen model. A secret code required to authenticate your application with the Azure OpenAI service. This key ensures secure access and prevents unauthorized use of your service. Outputs. The results generated by the Azure OpenAI service based on the provided input data. This can include text, code, summaries, translations, or any other output format supported by the chosen model. Steps. First, you need to create an Azure OpenAI resource in the Azure portal, which involves selecting a suitable model and configuring the service. This step will provide you with the endpoint and API key needed for accessing the service. Next, you need to configure your application to communicate with the Azure OpenAI service. This involves providing the endpoint and API key obtained in the previous step. This configuration allows your application to send requests to the Azure OpenAI service. Once the configuration is complete, you can start sending requests to the Azure OpenAI service with your desired input data. The service will process the input and return the corresponding AI-powered output based on the chosen model and parameters. For example, you can provide a text prompt and receive a generated response, or send a code snippet and get suggestions for completion. Prerequisites. A subscription to Azure, which provides access to various services, including Azure OpenAI. If you don't have an existing subscription, you can create a new one on the Azure website. An Azure OpenAI service instance, which is a dedicated resource within Azure that allows you to use OpenAI models for various tasks. You can create and configure an Azure OpenAI service in the Azure portal, choosing from a range of available models based on your needs. Fine-tune parameters. The specific type of AI model you want to use for your application. For example, you can choose a model designed for text generation, code completion, or translation. Each model has its own strengths and capabilities, and you should select the one that best suits your requirements. The design and structure of the input prompts you provide to the Azure OpenAI service. Effective prompt engineering involves crafting clear and specific prompts that guide the model to produce the desired output. For example, providing context, specifying desired output format, or using examples can improve the quality and relevance of the generated results. Challenges and fixes. Authentication issues can occur if the API key or endpoint is incorrect or invalid. To resolve this, double-check the provided credentials and ensure they are accurate. You can also try regenerating the API key in the Azure portal if you suspect it might be compromised. API rate limits are implemented to prevent overuse of the service. If you exceed the allowed request rate, you might encounter errors or delays. To address this, implement mechanisms to throttle requests, such as introducing pauses between consecutive requests or using a paid tier of the Azure Open AI service, which offers higher request limits. Model performance can be influenced by the quality and relevance of the training data. Fine-tuning the model with additional data relevant to your specific task can improve its accuracy and generate more accurate outputs. This involves providing the model with examples of the desired input-output pairs, allowing it to learn from your specific context and domain. Azure Open AI GPT-3 Codex. A description of Azure Open AI Services GPT-3 in Codex models. Inputs. Input provided to the models, which can be text, code, or a combination of both. Additional information that helps the models understand the context, instructions, or prompts given. Outputs. The generated text output based on the input and model training. Code in various programming languages, generated based on the input. Steps. The user provides input to the models, either text or code. The model processes the input, taking into account its training data, and generates the output. Prerequisites. A subscription to Azure services for access to the Azure Open AI service. An instance of the Azure Open AI service needs to be created and configured. An API key is required to authenticate and use the Azure Open AI service. Fine-tune parameters. This parameter allows customization of the model size, which impacts its capacity and performance. This parameter adjusts the randomness and creativity of the generated output. Challenges and fixes. The model may have limitations in generating complex code, potentially lacking advanced features or functionalities. Using advanced code generation techniques can help overcome this limitation, allowing the model to generate more sophisticated code. The generated code may be inaccurate or inconsistent, leading to unpredictable results. To ensure consistency and accuracy, it is crucial to provide specific and detailed instructions to the model, guiding its code generation process. Azure Open AI Trigger Event. Inputs. Azure Open AI Service represents the Azure Open AI service that will be utilized for processing pay. Input text. Input text refers to the text that will be provided as input to the Azure Open AI service for processing. It can be a paragraph, a list of words, a code snippet, or any text that needs to be processed by the AI model. Outputs. Generated text. This represents the output generated by the Azure Open AI service based on the input text. It could be a summary, a translation, a code snippet, or any text generated by the AI model based on the input and the model's capabilities. Steps. Create Azure Open AI resource. This step involves creating the required Azure Open AI resource within the Azure subscription. This resource will host the AI model that will be used to process the input text. Deploy Azure function. This step refers to the deployment of an Azure function that will act as the trigger for the Azure Open AI service. This function will receive the input text, send it to the AI model, and receive the generated text. Trigger function with input text. This step involves triggering the Azure function with the input text. The function will then process the input text using the Azure OpenAI service and return the generated text. Prerequisites: Azure subscription. An active Azure subscription is required to access and utilize Azure resources, including the Azure OpenAI service. Subscription ID: this represents the unique identifier of the Azure subscription associated with the user or organization accessing the Azure OpenAI service. It is required for authentication and authorization within the Azure environment. Azure OpenAI Service. The Azure OpenAI Service is a cloud-based service that provides access to powerful AI models for tasks like text generation, translation, and code completion. A P-key: this is a unique identifier that authenticates access to the Azure OpenAI service. It is used to verify the user's identity and authorize requests to the service endpoint. The endpoint is the URL address of the Azure OpenAI service where the requests are sent for processing. It acts as a gateway to access the AI models within the service. Deployment name: this is the name of the specific deployment of the AI model within the Azure OpenAI service. Different deployments can be used to host different AI models or versions of the same model, allowing for flexibility in choosing the appropriate model for specific tasks. Fine-tune parameters: model type: this refers to the specific AI model that will be used to process the input text. There are different types of AI models available within the Azure OpenAI service, each with its own capabilities and strengths. Training data: this refers to the data used to train the specific AI model for the task. Training data is essential to teach the model the patterns and relationships in the data, enabling it to generate coherent and relevant output. Challenges and fixes: authentication issues: these issues can occur when the provided API key or endpoint is incorrect or invalid, preventing access to the Azure OpenAI service. Verify API key and endpoint: ensuring that the provided API key and endpoint are valid and match the configured settings within the Azure OpenAI service is essential to resolve authentication issues. Deployment errors: these issues can arise during the deployment process of the AI model or the Azure function, leading to errors in setting up the necessary resources and configurations. Check deployment status: verifying the deployment status of the AI model and the Azure function helps identify any errors or issues encountered during the deployment process. Redeploy model: in cases where deployment errors occur, redeploying the AI model or the Azure function can resolve issues related to configurations or resource allocations. Retry deployment: reattempting the deployment process can resolve transient errors or issues related to network connectivity or temporary resource unavailability. Resource limits: these issues occur when the available resources, such as CPU, memory, or storage, are insufficient to handle the workload of the AI model or the Azure function. Increase resource limits: increasing the resource limits allocated to the AI model or the Azure function can address resource constraints and improve performance. Optimize code efficiency: optimizing the code of the Azure function or the AI model to reduce resource consumption and improve efficiency can help manage resource limitations. Input text format: issues related to the format of the input text can prevent the AI model from processing it correctly, leading to errors or incorrect output. Ensure valid input format: ensuring that the input text adheres to the expected format and structure for the AI model is crucial for accurate processing. Pre-process input text: pre-processing the input text to clean it, remove irrelevant information, or transform it into a suitable format for the AI model. can improve the accuracy and efficiency of processing. Azure OpenAI Connectors. A description of Azure OpenAI Connectors, which are a set of tools that allow you to integrate your Azure OpenAI service with other services and applications. For example, you can use a connector to send data from your CRM system to your Azure OpenAI service, or to use your Azure OpenAI service to generate text for your website. Inputs. The Azure OpenAI service you want to use. This is the service that will provide the AI capabilities. For instance, if you are using Azure OpenAI to generate text, you'll need to specify the specific model you want to use, such as GPT-3 or Codex, the target service or application you want to integrate with. This is the service or application that you want to use the Azure OpenAI service with. For example, you might want to integrate your Azure OpenAI service with your CRM system, your website, or a third-party application. Outputs. Enhanced data analysis. This could include things like sentiment analysis, topic modeling, and text summarization. For example, you could use Azure OpenAI to analyze customer feedback data to understand customer sentiment and identify common themes. Improved customer experiences. This could include things like personalized recommendations, chatbot conversations, and automated content generation. For example, you could use Azure OpenAI to build a chatbot that can answer customer questions, or to generate personalized product recommendations. Steps. Choose a connector that is compatible with both your Azure OpenAI service and your target service or application. For instance, there are connectors available for popular services like Salesforce, Zendesk, and Microsoft Dynamics 365. Configure the connector to specify the details of your Azure OpenAI service and your target service or application. This will likely involve providing API keys or credentials, as well as specifying the data format that will be used for communication. Test the connection between your Azure OpenAI service and your target service or application to ensure that the connector is working correctly. This can be done by sending a test request to your Azure OpenAI service and verifying that the response is received by your target service or application. Use the connector in your application to start integrating your Azure OpenAI service with your target service or application. This will involve writing code to use the connector to send data to your Azure OpenAI service and receive responses from your target service or application. Prerequisites. An Azure subscription. This is required to access Azure OpenAI services. For instance, you'll need to create an Azure account and subscribe to the Azure OpenAI service. An Azure OpenAI service deployed. This means that you have provisioned an Azure OpenAI service in your Azure subscription. For instance, you'll need to choose a specific Azure OpenAI service plan and deploy it in your Azure subscription. The target service or application you want to integrate with. This could be a CRM system, a website, or a third-party application. For instance, you might want to integrate your Azure OpenAI service with your Salesforce CRM system or your WordPress website. The required API keys or credentials to access the target service or application. These are required to authenticate with the target service or application. For instance, you'll need to obtain API keys or credentials from your Salesforce CRM system or your WordPress website. Fine-tune parameters. The model type you want to use for fine-tuning. This could be a pre-trained model or a custom model. For instance, you might want to use the GPT-3 language model for generating text. Or you might want to fine-tune a custom model for a specific domain, such as healthcare or finance. The training data you want to use to fine-tune your model. This could be text data, code data, or other types of data. For instance, you might want to use a dataset of customer reviews to fine-tune a model for sentiment analysis. Or you might want to use a dataset of code to fine-tune a model for code generation. Challenges and fixes. Connection errors can occur if there is a problem connecting between your Azure OpenAI service and your target service or application. For instance, you might encounter a connection error if your API keys are incorrect or if there is a network issue. Verify that your API keys or credentials are correct and that you have the necessary permissions to access the target service or application. For instance, you can check your API key or credentials against the documentation for the target service or application, and you can ensure that you have the necessary permissions by contacting the target service or application provider. Data format issues can occur if the data format used by your Azure OpenAI service is not compatible with the data format used by your target service or application. For instance, you might encounter a data format issue if your Azure OpenAI service is expecting data in JSON format, but your target service or application is sending data in XML format. Ensure that the data format used by your Azure OpenAI service is compatible with the data format used by your target service or application. For instance, you can use a data connector to convert data between different formats. Or you can modify the code for your Azure OpenAI service or your target service or application to use a compatible data format. Use a data connector to transform the data from the target service or application into the format expected by your Azure OpenAI service. For instance, you can use a data connector to convert data from a CSV file into JSON format. Or you can use a data connector to convert data from a database into the format expected by your Azure OpenAI service. Azure OpenAI application code using OpenAI SDK. This YAML represents an application code using the Azure OpenAI service. It outlines the steps, inputs, outputs, prerequisites, and potential challenges involved in integrating the Azure OpenAI service with Python. Inputs. This input represents the Azure OpenAI API key, which acts as a security credential to authenticate your application with the Azure OpenAI service. It's crucial for authorizing requests and accessing the service. An example of a real-world scenario would be obtaining a unique API key from your Azure OpenAI resource within your Azure subscription. This input represents the Azure OpenAI endpoint, which acts as the address or URL where your application sends requests to interact with the Azure OpenAI service. It's like the gateway to the service. In a real-world scenario, you would find the endpoint associated with your Azure OpenAI resource within your Azure subscription. This input represents the deployment name of your Azure OpenAI model. It's the unique identifier for the specific model you are interacting with within your Azure OpenAI resource. In a real-world scenario, you might choose a descriptive name like my text generation model to easily identify the deployed model. Outputs. This represents the generated text as the output from the Azure OpenAI model. Based on the input provided to the model, it's the result of the model's analysis and processing of the input. An example would be a chatbot's response or a generated summary of a text document. Steps. This step involves importing the necessary Python libraries that provide the functionality to interact with the Azure OpenAI service. Libraries like Azure AI OpenAI and requests are essential for sending API requests and handling responses. This step involves configuring the OpenAI API client using the provided Azure OpenAI API key and endpoint. It sets up the connection between your application and the Azure OpenAI service. This step involves sending requests to the Azure OpenAI endpoint with the specified model, deployment name and input data. The request can be a prompt for text generation, a document for summarization, or any other task supported by the chosen model. This step involves receiving the response from the Azure OpenAI endpoint, processing the generated text, and displaying it to the user or incorporating it into your application. Prerequisites. This prerequisite refers to having an Azure OpenAI service. This service provides access to various AI models and APIs for tasks like text generation, summarization, translation, and more. You can create an Azure OpenAI resource within your Azure subscription to access this service. This prerequisite refers to having Python 3.6 or later installed on your system. Python is a widely used programming language, and the Azure OpenAI SDK requires a specific version to function correctly. This prerequisite refers to having the OpenAI Python SDK installed, which provides a convenient way to interact with the Azure OpenAI service through Python code. You can install this SDK using the pip install Azure AI OpenAI command. Fine-tune parameters. This represents the model fine-tuning process, which allows you to customize and train a pre-trained Azure OpenAI model on your specific data to improve its performance on specific tasks. It involves providing your own dataset and setting parameters to guide the fine-tuning process. This represents the training data used for model fine-tuning, which consists of a collection of text or code examples that are used to adapt the pre-trained model's behavior to your specific needs. For example, training data for a chatbot might include conversations between humans, challenges and fixes. This challenge represents an API key authentication error that can occur when your application fails to authenticate with the Azure OpenAI service. This fix suggests verifying the API key and endpoint to ensure they are correct and accessible. Check if the key is active, if there are any typos in the key or endpoint URL, and if any network connectivity issues are preventing access. This challenge represents a deployment not found error that can occur if the specified deployment name doesn't match an existing model deployment. This fix suggests checking the deployment name to ensure it's correct and that the model is deployed in your Azure OpenAI resource. Double-check for typos in the name and verify that the model is actually deployed. This challenge represents rate-limiting issues that can occur when your application exceeds the allowed number of requests to the Azure OpenAI service in a given time period. This fix suggests implementing rate-limiting mechanisms to control the frequency of requests sent to the Azure OpenAI service. This might involve using time delays between requests, batching requests, or using more efficient methods to minimize the number of requests. This challenge represents model fine-tuning issues that can arise during the customization of a pre-trained Azure OpenAI model. This fix suggests optimizing the training data by ensuring it's relevant to the task, of high quality, and formatted correctly. You might need to experiment with different data cleaning and pre-processing techniques to improve the fine-tuning results. Azure OpenAI Publish Application Inputs. Azure OpenAI Service Deployment. This represents the deployment details for the Azure OpenAI service that you intend to use. It includes information like the service's name, location, and deployment type. This is the foundation upon which your model will be published. Azure OpenAI model. This is the actual OpenAI model you want to publish. It could be a pre-trained model from OpenAI like GPT-3 or Codex, or a model you've fine-tuned on your own data. This is the core of the application. Deployment configuration. This defines the specific settings for deploying your model. This might include things like resource allocation, access control, and pricing tier. Think of it as customizing how your model is made available. Outputs. Published Azure OpenAI model. This is the result of the publishing process. It represents your model deployed and ready to be used via the Azure OpenAI service. Steps. Create an Azure OpenAI service. This step involves setting up the Azure OpenAI service instance in your Azure subscription. This provides the environment where your model will be hosted and accessible. Deploy the Azure OpenAI model. In this step, you take your chosen model from Azure OpenAI models or your fine-tuned model and deploy it to the service you created. Configure deployment. This step involves configuring the deployment based on your specific requirements. This could include setting up access controls, defining pricing plans, and optimizing for performance. Publish the model. This is the final step where you make your model publicly available. Once published, your model can be used by other applications or services through the Azure OpenAI service. Prerequisites. Azure subscription. You need an active Azure subscription to access the necessary resources to publish your OpenAI model. This gives you the ability to create and manage Azure services. Azure Subscription ID. This is the unique identifier of your Azure subscription. It's necessary to access and manage your resources within Azure. Azure OpenAI Resource Group. This is a logical grouping of your Azure resources. It provides organization and helps with access management and billing. Resource Group Name. This is the name you give to the resource group where your OpenAI service and its related components will be located. Fine-tune parameters. Training data. If you are using a fine-tuned model, this refers to the dataset you used to train your model. This data helps to specialize the model to perform specific tasks related to your domain. Hyperparameters. These are the settings that control how your model is trained. Examples include the learning rate, batch size, and number of epochs. You can fine-tune these to optimize your model's performance. Challenges and fixes. Access denied. This indicates that your user account doesn't have the necessary permissions to perform the requested action. Verify permissions. You need to check your user's permissions and ensure they are sufficient for publishing a model. You might need to request access from an administrator or assign yourself the required roles. Model deployment error. This indicates an issue during the deployment process, possibly related to network connectivity, resource limitations, or misconfiguration. Check deployment logs. You should check the deployment logs for error messages. This will give you insights into the cause of a problem and help you identify the appropriate troubleshooting steps. Incorrect configuration. This suggests that there are issues with the settings you've configured for your deployment. This could be in areas like pricing tiers, resource allocation, or access control. Review deployment configuration. Carefully review your deployment settings to ensure they are correct and consistent with your requirements and the capabilities of the Azure OpenAI service. Azure OpenAI Application Code Management using Azure DevOps and GitHub. This YAML document describes the process of managing Azure OpenAI application code using Azure DevOps and GitHub. It outlines the inputs, outputs, steps, prerequisites, fine-tuning parameters, and challenges and their respective fixes involved in this process. Inputs. Details about the Azure OpenAI resource used, including the resource name, location, and pricing tier. Information about the GitHub repository where the OpenAI application code will be stored, including the repository name, owner, and access permissions. Outputs. The OpenAI application code is versioned and managed within the specified GitHub repository. facilitating collaboration and code history tracking. An automated code deployment process is established using Azure DevOps, ensuring consistent and efficient application deployment across various environments. Steps: create a new GitHub repository to store the OpenAI application code. This repository will act as the central location for code management, version control, and collaboration. Initialize the newly created GitHub repository with the OpenAI application code. This includes setting up the initial project structure, files, and dependencies required for the application. Configure an Azure DevOps pipeline to automate the build, test, and deployment processes for the OpenAI application. The pipeline will define the various tasks and steps involved in each stage of the deployment process. Connect the Azure DevOps pipeline to the GitHub repository, enabling continuous integration and continuous delivery (CI/CD). This allows changes made in the GitHub repository to trigger automated pipeline execution. Define specific pipeline steps for building, testing, and deploying the OpenAI application. These steps might include compiling code, running unit tests, packaging the application, deploying to different environments, and monitoring performance. Prerequisites: an Azure subscription is required, with the Azure OpenAI service enabled. This ensures access to Azure OpenAI resources and capabilities for developing and deploying OpenAI applications. Create an Azure OpenAI resource within the Azure subscription. This resource represents the OpenAI service instance, providing access to various models and APIs. Create an OpenAI deployment to provision the necessary infrastructure and resources for running the OpenAI application. This deployment might involve selecting an appropriate Azure region, specifying the model to use, and setting up resource limits. A GitHub account with repository access is necessary for storing and managing the OpenAI application code. This account should have the required permissions to create, modify, and push code to the repository. Fine-tune parameters. Implement code quality checks using tools like linters and static code analyzers to ensure code readability, maintainability, and adherence to coding standards. These checks help identify potential bugs, security vulnerabilities, and code style violations. Conduct security scans to identify and mitigate potential vulnerabilities in the application code. These scans can help protect the application from attacks and ensure compliance with security standards. Challenges and fixes. Managing code changes and version control effectively is crucial for collaboration and code history tracking. Utilize GitHub's features for branching, merging, and pull requests. Branching allows developers to work on independent features without affecting the main code base. Merging combines changes from different branches, while pull requests facilitate code review and collaboration before integrating changes into the main branch, ensuring consistent deployment across different environments, e.g., development, testing. Production is essential for maintaining application stability and predictability. Utilize Azure DevOps pipeline stages to define distinct steps for each environment. Each stage can have its own configuration settings, deployment targets, and testing procedures, allowing for controlled and consistent deployments across different environments. Maintaining security and compliance with industry regulations and standards is critical for protecting sensitive data and ensuring application integrity. Implement security scans and code analysis tools to identify and mitigate potential vulnerabilities. These tools can help detect known security issues, enforce coding best practices, and ensure compliance with security standards. Scaling and performance optimization are crucial for ensuring application responsiveness and Handling increasing user traffic. Optimize code for efficient resource utilization and performance by identifying performance bottlenecks and implementing appropriate optimization techniques. This might involve optimizing database queries, reducing network overhead, and using efficient algorithms. Prerequisites. Azure OpenAI Service is a cloud-based service that provides access to powerful AI models, including GPT-3, Codex, and DAL2. Inputs. Azure subscription refers to a subscription to Microsoft Azure Cloud Platform, which is a prerequisite for accessing Azure OpenAI Service. OpenAI resource refers to a specific resource within Azure that is dedicated to using OpenAI services, like GPT-3, Codex, or DAL2. Outputs. AI model access refers to the ability to use and interact with OpenAI models, such as GPT-3, Codex, or DAL2, within the context of your Azure environment. API keys are unique identifiers used to authenticate and authorize access to OpenAI models within the Azure OpenAI service. Model fine-tuning refers to the ability to customize and optimize OpenAI models for specific tasks or domains by training them on your own data. Steps. Create an Azure subscription means signing up for an account on the Microsoft Azure platform to gain access to its services, including Azure OpenAI Service. Create an OpenAI resource involves setting up a dedicated resource within your Azure environment, specifically for using OpenAI models. Deploy an AI model refers to the process of making an OpenAI model, such as GPT-3, Codex, or DAL2, available within your Azure OpenAI Service instance. Obtain API keys involves generating and retrieving unique identifiers that allow you to authenticate and authorize access to OpenAI models within Azure. Integrate with applications involves connecting your Azure OpenAI service to other applications or systems within your Azure environment to leverage AI capabilities. Prerequisites. Azure subscription. Free trial refers to a limited time period where you can experiment with Azure services, including Azure OpenAI Service, without any financial commitment. Pay-as-you-go refers to a billing model where you are charged only for the Azure resources you consume, including Azure OpenAI Service usage, on a per-use basis. OpenAI Resource. Resource group refers to a logical container in Azure that is used to organize and manage related Azure resources, including your OpenAI resource. Location refers to the geographical region where your Azure OpenAI resource is hosted, influencing factors such as latency and data sovereignty. Fine-tune parameters. Training data refers to the specific data you use to train and customize an OpenAI model, tailoring its behavior and output to your desired tasks or domains. Hyperparameters are adjustable settings that control the training process of an OpenAI model, influencing its learning behavior and overall performance. Challenges and fixes. Quota limits. Increase quota involves requesting a higher usage limit for your Azure OpenAI service to accommodate increased demand or more extensive use of OpenAI models. Model performance. Fine-tune model refers to the process of customizing an OpenAI model for specific tasks or domains, by training it on your own data to improve its performance in those areas. Optimize data involves carefully selecting and preparing the training data used to fine-tune an OpenAI model, ensuring it is relevant, diverse, and of high quality to achieve optimal performance. Integration issues. Review API documentation refers to consulting the official documentation for OpenAI's APIs and Azure OpenAI service to understand how to properly integrate it with your applications. Verify credentials involves ensuring that the API keys used to authenticate and authorize access to OpenAI models within Azure are correctly configured and updated if necessary.